Cloud computing is at the cusp of technological advancement, and when you talk about cloud computing, you cannot shy away without mentioning Amazon Web Services, which is one of the leading cloud service providers in the market. If you are looking for a career in this domain, you have landed at the right place. Edureka brings you a complete course on Amazon Web Services, which not only touches upon the fundamentals, but also dives deeper at a conceptual level. So let us take a look at the offerings of this session. First, we would start with the fundamentals of cloud computing and Amazon Web Services. Moving on, we would talk about the core services that Amazon Web Services has to offer to you. The first domain is the compute domain, where we would be exploring services like EC2, Elastic Beanstalk, and Lambda. Moving on, we would talk about the storage domain, where we would be exploring services like S3, EFS, and Amazon Glacier. Next in line is the networking domain, where we will be talking about services like VPC, Route 53, etc. Then we will be talking about management and monitoring services like CloudWatch, CloudFormation, load balancers, etc. Moving on, we will take a look at cloud security and take a look at services like IAM, etc. Then the database part, where we will be exploring services like Amazon Redshift. Once we are done with the core services, we will be also discussing DevOps on AWS, where we will be talking about AWS services like AWS Code Pipeline, AWS Code Commit, etc. Now that the DevOps part and the core part of AWS is over, we can now switch to the career part, where we will be discussing some numbers like jobs, trends, salaries, etc. And we would also take a look at the roles and responsibilities and what are the kind of things that you should know when you talk about making a career in this particular domain. So before we get started, feel free to subscribe to our YouTube channel to get the latest updates on the trending technologies.
Firstly, let's understand why cloud. To understand this, we need to understand the situation that existed before cloud came into existence. So what happened back then? Well, firstly, in order to host a website, you had to buy a stack of servers. And we all know that servers are very costly. So that meant we ended up paying a lot of money. Next was the issue of traffic. Now, as we all know, if we are hosting a website, we are dealing with traffic that is not constant throughout the day. And that meant more pain. We would understand that as we move further. And the other thing was monitoring and maintaining your servers. Yes, this is a very big problem. Now, all these issues, they led to certain disadvantages. What are those? As I've mentioned, servers are very costly. Yes, the setup was again costly, and thus you ended up paying a lot of money. And there were other factors contributing to this point. Let's discuss those as well. One, troubleshooting was a big issue. Since you're dealing with a business, your prime focus is on taking good decisions so that your business does well. But if you end up troubleshooting problems or you focus more on infrastructure related issues, then you cannot focus more on your business, and that was a problem. So either you had to do multitasking or you had to hire more people to focus on those issues. Thus, again, you ended up paying more money. As I've discussed, the traffic on a website is never constant. And since it varies, you are not certain about its patterns. Say, for example, I need to host a website. And for that, what I decide is I'm reserving 2 petabytes of total memory for my usage based on the traffic. But as the traffic varies, there would be times when the traffic is high and my whole 2 petabytes of data is consumed, or space is consumed rather. But what if the traffic is very low for certain hours of the day? I'm actually not utilizing these servers. So I end up paying more money for the servers than I should be. So yes, upscaling was an issue. So all these things were an issue because we were paying more money. We did not have sufficient time to take our decisions properly. There was ambiguity. There was more trouble monitoring and maintaining all these resources. And apart from that, one important point which we need to consider is the amount of data that is being generated now and that was being generated then. Then it was okay. But nowadays, if you take a look at it, the amount of data that is generated is huge. And this is another reason why cloud became so important. Yeah, as I've mentioned the data. Now, we all know that everything is going online these days. And what that means is we shop online, we buy food online, we do almost everything that is required, as in whatever information we need, we get everything online. Your bookings, your reservations, everything can be taken care of. That means we have a lot of data that is being generated these days, and this is digital data. Back in those times, we were communicating through verbal discussions and all those things, so through paperwork, and that was a different data to maintain. Since everything is moving on cloud or moving online, the amount of data that we have is huge these days. And then when you have this huge amount of data, you need a space where you can actually go ahead and maintain this data. So yes, again, there was a need of this space. And all these issues, that is your cost, your monitoring, your maintenance, providing sufficient space, everything was taken care by cloud. So let us try to understand what this cloud is exactly. Well, think of it as a huge space that is available online for your usage. Now, this is a very generic definition to give you. To be more specific, I would be saying that think of it as a collection of data centers. Now, data centers again are a place where you store your data or you host applications basically. So, when you talk about these data centers, they were already existing. So, what did cloud do differently? Well, what cloud did was it made sure that you are able to orchestrate your various functionings, your applications, managing your resources properly by combining all these data centers together through a network and then providing you the control to use these resources and to manage them properly. To make it even more simpler, I would say there was a group of people or organizations basically that went ahead and bought these servers, these compute capacities, storage places, compute services, and all those things. And they have their own channel or network. All you have to do was go ahead and rent those resources only to the amount you need it and also for the time that you need it. So, yes, this is what cloud did. It let you rent the services that you need and use only those services that you need. So, you ended up paying for the services that you rented and you ended up saving a lot of money. The other thing is these service providers, they take care of all the issues like your security, your underlying infrastructures, and all those things. So you can freely focus on your business and stop worrying about all these issues. So this is what cloud is. In simple words, it's a huge space which has all these services available, and you can just go ahead and pick and rent those services that you want to use. So what is cloud computing? Well, I've already discussed that. Just to summarize it, I would say it is nothing but an ability, or it is a place where you can actually store your data, you can process it, and you can access it from anywhere in the world. Now, this is an important point. Say, for example, you decide to choose a region for your infrastructure somewhere in US. You can sit in maybe China or maybe in India, and you can still have access to all your resources that is there in US. All you need is a good internet connection. So that is what cloud does. It makes the world accessible. It lets you have your applications wherever you want to and manage them the way you want to. Next, we would be discussing different service models. Now, you need to understand one thing. You're being offered cloud services, the platform to use your services or your applications basically. But then different people have different requirements. There are certain people who just want to consume a particular resource, or there are certain people who actually want to go ahead and create their own applications, create their own infrastructure, and all those things. So, based on these needs, we have particular service models, that is, your cloud providers provide you with a particular model which suits your needs. So let us try to understand these models one by one. Well, we have these three models, that is your IaaS, your PaaS, and your SaaS. I would be discussing them in the reverse order. That is, I would be talking about SaaS first, and then I would go upwards. So let us start with SaaS or SaaS. SaaS is nothing but a software as a service. Now, what happens here is basically you're just consuming a service which is already being maintained and handled by someone else. To give you a valid example, we have a Gmail. All you do is you send mail to people and you receive mails. And whatever functionality you do is you just use the service that is there. You do not have to maintain it. You do not have to worry about upscaling, downscaling, security issues, and all those things. Everything is taken care by Google. Say, for example, your Gmail is what I'm talking about. Google manages everything here. So all you have to worry about is consuming that service. Now, this model is known as software as a service, that is SaaS. Next, we have PaaS, that is platform as a service. Now, here you are provided with a platform where you can actually go ahead and build your own applications. To give you an example, we have our Google App Engine. Now, when you talk about Google App Engine, what you can do is you can go ahead and you can create your own applications and you can put it on Google App Engine so that others can use it as well. So in short, you're using the platform to create your own applications. And lastly, we have IaaS, that is infrastructure as a service. Now, what do I mean by this? Well, the whole infrastructure is provided to you so that you can go ahead and create your own applications. That is, an underlying structure is given to you. Based on that, you can go ahead and choose your operating systems, the kind of technology you want to use on that platform, the applications you want to build, and all those things. So that is what an IaaS is, infrastructure as a service, basically. So these were the different models that I wanted to talk about. Now, this is the architecture that gives you a clear depiction as in what happens as far as these service models are concerned. Now, you have something called as your SaaS. Now, here, as you see, all you're doing is you're consuming your data, that's it, or using it. Everything else is managed by your vendor, that is your applications, runtime, middleware, OS, virtualization, servers, networking, everything. As far as your PaaS is concerned, your data and applications are taken care by you. That is, you can go ahead, you can build your own applications, you can use the existing platform that is provided to you. And finally, you have your IaaS. Now, what happens here is only the basic part, that is your networking, storage, servers, and virtualization is managed by your vendor, deciding what middleware, OS, runtime, applications, and data that resides on your end. You have to manage all these things. That is, you're just given a box of car, for example, or maybe parts of car. You go ahead and you fix it and you use it for your own sake. That is what IaaS is. To give you another example, think of it as eating a pizza. Now, there are various ways of doing that. One, you order it online. You sit at home, you order the pizza, it comes to your place, you consume it. That is more of your SaaS, that is software as a service. You just consume the service. Next is your platform as a service. Now, when I say platform as a service, you can think of it as going to a hotel and eating a pizza. Say, for example, I go there, they have the infrastructure, as in I have tables, chairs, I have to go sit, just order the pizza, it is given to me, I consume it, and I come back home. And IaaS, now this is where you go ahead and bake your own pizza. You have the infrastructure, you buy it from somewhere or whatever it is, you use your pizza, you put it in an oven, you put spices, all those things, and you eat it. Now, this is the difference between these three services. So let us move further and discuss the next topic, that is the different deployment models that are there. Now, when you talk about deployment models, you can also call them as different types of clouds that are there in the market. We have these three types, that is your public cloud, your private cloud, and your hybrid cloud. Let us try to understand these one by one. Now, as the name suggests, the public cloud, it's available to everyone. You have a service provider who makes these services or these resources available to people worldwide through the internet. It is an easy and very inexpensive way of dealing with the situation, because all you have to do is you have to go ahead and rent this cloud and you're good to use, and it is available publicly. Next, we have the private cloud. Now, this is a little different. Here, you are provided with this service and you can actually go ahead and create your own applications. And since it's a private cloud, you're protected by a firewall and you do not have to worry about various other issues that are there at hand. And next we have our hybrid cloud. Now it is a combination of your private cloud and your public cloud. Say, for example, you can go ahead and build your applications privately. You can use them, you can consume them, you can use them efficiently. When you sense that peak in your traffic, you can actually move it to public. That is, you can move it to the public cloud and even others can have access to it and they can use it. So these are the three basic deployment models that are there for your exposure or your usage rather, and you can go ahead and use those as well. I hope this was clear to all of you. So let us move further and try to understand the next topic, that is different cloud providers that are there in the market. Now, as I've mentioned, what happened was since cloud came into existence, quite a few people went ahead and they bought their own infrastructure and now they rent these services to other people. And when you talk about this infrastructure, there are quite a few people out there who are actually providing these cloud services to different people across the globe. Now, when you talk about these cloud providers, the first thing that should come to your mind is Amazon Web Services, because it is highly popular and it leaves other cloud providers way behind. The reason I'm saying this is the numbers that talk about Amazon Web Services. To give you an example, if you talk about its compute capacity, it is 6 times larger than all the other service providers that are there in the market. Say, for example, if you talk about the other service providers in the market, if their compute capacity combined was X, Amazon Web Services alone gives you a capacity of 6x, which is huge. Apart from that, it's flexible pricing and various other reasons, that is the services it provides and all those things. It is rightly a global leader. And the fact that it had a head start, that is, it started way before many other services that are there in the market, it actually gained popularity. And now we see quite a few organizations going ahead and using Amazon Web Services. Apart from that, we have Microsoft Azure, which is a Microsoft product. And we all know that when Microsoft decides to do something, they expect that they kill all the competition that is there in the market. It is still not in terms with Amazon Web Services or few other service providers that are there in the market, but not very neck to neck. But it is probably the second best when you talk about Amazon Web Services or the cloud service providers in the market. So, yep, it has a lot of catching up to do when you compare it with Amazon Web Services, but it is still a very good cloud service provider that is there in the market. Then we have something called as Google Cloud Platform. Again, a very good cloud provider in the market. Now, why am I saying this? We all know the infrastructure that Google has to offer to you. It is one of the best search engine that is there in the market, and the amount of data they deal with every day is huge. So they are the pioneers when you talk about big data and all those things, and they know how to actually handle this amount of data and how to have an infrastructure that is very good. That is why they have a very good facility, and that leads to it being one of the cheapest service providers in the market. Yes, there are certain features that GCP offers which are better even than Amazon Web Services when you talk about its pricing. And the reason for it is it has various other services that are there. What it does is it helps you optimize various costs. How? It uses analytics and various other ways by which it can optimize the amount of power you use, and that leads to less usage of power. And since you're paying less for power, that is, providers are paying less for power, you end up paying less for your services as well. So that is why it is so cost efficient. Then there are other service providers, that is, we have DigitalOcean, we have Terramark, we have IBM, which is again very popular. But that is a discussion for some other time. As far as these service providers go, these are the major ones. That is, we have Amazon Web Services, we have Microsoft Azure, we have GCP, which are talked about a lot. This was about the basic cloud providers and the basic intro which I wanted you all to have. I hope you all are clear with whatever concepts we've discussed till time. Let's try to understand a little more about AWS. Well, it is a complete software suite or a cloud service provider which is highly secure. It provides you with various compute, storage, database, and n number of other services, which we would be discussing in further slides as well. And when you talk about the market, it is the best, and it has various reasons to be the best in the market. One being its flexibility, its scalability, and its pricing. Other reasons being its compute capacity. Now, why is it so important, the compute capacity? Well, if you talk about the compute capacity, you need to understand one thing. If you take all the other cloud service providers in the market and you combine their compute capacity, that is, you leave out AWS and you take all others into consideration, the space would be somewhere equal to, say, X. And if you compare it with AWS, it is 6X. So AWS has more compute capacity, which is 6 times more than all the other service providers that are there in the market. So that is a huge amount. So these are the reasons that make AWS one of the best in the market. And let's try to find out what are the other reasons about AWS that make it so good. What are the services, features, and its uses basically. So I would be discussing some use cases now. If you're talking about a manufacturing organization, now their main focus is to manufacture goods, but most of the businesses, they focus so much on various other services or practices that need to be taken care of that they cannot focus on the manufacturing goal. Now this is where AWS steps in. It takes care of all the IT infrastructure and management. That means businesses are free to focus on manufacturing and they can actually go ahead and expand a lot. Architecture consulting. Now their main concern is prototyping and rendering. AWS takes care of both the issues. It lets you have automated or speed up rendering as far as prototyping is concerned. And that is why architectural business benefit a lot when you talk about using AWS or any cloud provider. But AWS being the best in the market, again, their services are the best. Media company. Now, as far as a media company goes, their main concern is generating content and the place to dump it or to store it. Again, AWS takes care of all these situations or both these situations. Large enterprises. When you talk about large enterprises, their reach is worldwide. So they have to reach their customers and their employees globally or across different places. So AWS gives you that option because it has a global architecture and your reach can be very wide as far as these points are concerned. Now, advantages of AWS. As I've mentioned, I won't say advantages exactly, I would say features as well. Flexibility. Now, as far as AWS is concerned, it is highly flexible. Now, there are various reasons to support it, and one of the major reasons is it's very cost effective. Let us try to understand these 2 points together rather. Now, when you talk about flexibility, The first concern you should have is you are dealing with big organizations. They have a lot of data that needs to be managed, deployed, and taken care of. Now, when you talk about a cloud provider, if it is flexible, all these things are taken care of. The second thing is it is highly cost effective. Now, when I say cost effective, AWS takes care of almost every aspect. If you are a beginner or a learner, they have something called as a free tier. That means you have sufficient resources to use for free, and that too for one long year. So you would have sufficient hands-on without paying anything. Plus, it has something called as pay-as-you-go model. Now, when I say pay-as-you-go model, what it does is it charges you only for the services which you're using and only for the time being you're using them. Again, that lets you scale up nicely, and hence you end up paying very less. Since you're paying very less, and since you have so many options when you're actually buying its services, what that does is that gives you a lot of flexibility. Scalability. Again, the first 2 points are related to this point. Now, how is that? Now, when I say scalability, what happens is, as I've mentioned, it is very affordable. So you're paying on hourly basis. If you're using a particular service for 1 hour, you'll be paying it only for 1 hour. That is how flexible it is. And what that does is that gives you a freedom to scale up and even scale down. Since it is easy to scale up, it is always advisable that you start with less and then scale as per your needs. Plus, there are quite a few services that are there which can be automatically scheduled. Now, what that means is you'd be using them only when there is an uptime, and in downtime, you can miss those get automatically shut down. So you do not have to worry about that as well. So when you talk about scalability, scaling up and down is very easy as far as AWS goes. Security. Again, now security has been a topic of debate when you talk about cloud services, especially. But AWS puts all those questions to rest. It has great security mechanism. Plus, it provides you with various compliance programs that again help you take care of security. And when you talk about real-time security, even that is taken care of. You can take care of all the suspicious activities that are there, and not you. AWS takes care of all those things, and you're let free to focus on your business rather. So these are the advantages which I feel that AWS adds value to. And apart from that, there are quite a few other points like we have automated scheduling, which I just mentioned. You have various integrated APIs. Now, these APIs, they're available in different programming languages, and that makes it architecturally very strong to switch from one programming language to another. So these are some of the features I feel that make AWS a wonderful, wonderful service provider in the market. So let's move further and try to understand other things as far as AWS is concerned. It's global architecture. When you talk about AWS, as I've mentioned, it is the best service provider in the market. So what makes AWS this popular? One of the reasons is its architecture. Now, when I talk about its architecture, it is very widely spread and it covers almost every area that needs to be covered. So let's try to understand how it works exactly. Well, if you talk about AWS architecture, now the architecture is divided into two major parts, that is regions and availability zones. Now, when you talk about the regions and availability zones, regions are nothing but different locations across the world where they have their various data centers put up. Now, as far as one region goes, it might have more than one data center. And these data centers are known as availability zone. You being a consumer or an individual, you can actually access these services by sitting anywhere in the world. To give you an example, if I'm sitting in some part of the world, say for example, I'm in Japan right now, I can actually have access to the services or data centers that are there in US right now. So that is how it works. You can choose your region and accordingly you can pick your availability zones and use those. So you do not have to worry about anything. To throw some more light on it, you can take a look at this small map, which is the global map, and it shows the different places which has its regions and availability zones. Now, as far as this map goes, I believe it's fairly old and it has been upgraded in recent times because AWS is putting in a lot of efforts to have more data centers or more availability zones as far as their wide reach is concerned. And we can expect some in China as well. So yes, they are actually reaching far and wide. So when you talk about these regions and availability zones, if you take a look at this map, what you can see is you have your region, which is in orange color, and the number that is inside it is the number of availability zones that there has to be. Now, to give you an example, we have Sao Paulo, which says that it has 3 availability zones. So that is how it is. And the ones that are in the green are the ones which are coming soon or the regions that are in progress. And some of these have actually gone ahead and already started or have been made available to people. So Yes, this is how the architecture works, and this is how the AWS architecture looks like. Okay, so let's move further and take a look at the next concept, domains of AWS. Now, when you talk about its domains, the first domain that we are going to discuss is compute. And when you talk about compute, the first thing that should come to your mind is EC2. Now, when I say EC2, it is Elastic Cloud Compute. And what it does is it lets you have a resizable compute capacity. It's more of a raw server where you can host your websites, and it is a clean slate. Now, what do I mean by this? Say, for example, you go ahead and buy a laptop. It is a clean device where you can have your own OS. You can choose which OS you want and all those things. Accordingly, your EC2 is again a clean slate and you can do so many things with it. Now, next you have Elastic Beanstalk, which lets you deploy your various applications on AWS. And the only thing you need to know about this thing is you do not have to worry about the underlying architecture. Now, it is very similar to your EC2. And the only difference between the two is as far as your Elastic Beanstalk is concerned, you can think of it as something that has predefined libraries, whereas your EC2 is a clean slate. Now, when I say predefined libraries, say for example, you want to use Java. As far as EC2 goes, now this is just an example, don't take it literally. You'll have to say, for example, install everything from the beginning and start fresh. But as far as your Elastic Beanstalk is concerned, it has this predefined libraries and you can just go ahead and use those because there's an underlying architecture which is defined. Let me say it again. I just gave you an example. Don't take these sentences literally. So next we have migration. When you talk about migration, you need to understand one thing. AWS has a global architecture and there would be a requirement for migration. And what AWS does is it lets you have physical migration as well. That means you can physically move your data to the data center which you desire. Now, why do we need to do that? Say, for example, I'm sending an email to somebody. I can do that through internet. But imagine if I have to give somebody a movie. So instead of sending it online, I can actually go ahead and give it to someone if that person is means reachable for me. And that way it would be more better for me. My data remains secure and so many other things. So same is with data migration as well. And when you talk about AWS, it has something called as Snowball, which actually lets you move this data physically. Now it's a storage service and it actually helps you in migration a lot. Security and compliance. Now, when you talk about security, we have various services like I have IAM, we have KMS. Now, when I say IAM, it is nothing but your identification and authentication management tool. We have KMS, which lets you actually go ahead and create your own public and private keys, and that helps you keep your system secure. Now, there are quite a few other services as well, but I would be mentioning one or two services from each domain because as we move further in future sessions, we would be discussing each of these services in detail. And that is when I would be throwing a lot more light on these topics. For now, I would be giving you one or two examples, and because I want you all to understand these to some extent, getting into details of all these things would be too heavy for you people because there are quite a few domains and quite a few services that we need to cover. And as we move further, definitely we would be covering all those services in detail. Then we have storage. Now, when I talk about storage, again, AWS has quite a few services to offer to you. We have something called as your S3. Now, S3, it works as a bucket object kind of a thing. Your storage place is called as a bucket and your object which you store in are nothing but your files. Now, these objects have to be stored in their root files, which act as the buckets basically. And then we have something called as your CloudFront, which is nothing but your content delivery network. We have something called as Glacier. Now, when you talk about Glacier, you can think of it as a place where you can store archives because it is highly affordable. Next, we have networking. Now, when you talk about networking, we have services like VPC, Direct Connect, Route 53, which is a DNS. Now, when I say VPC, it is a virtual network which actually lets you move or launch your resources. That is your AWS resources basically. When you talk about Direct Connect, you can think of it as a leased internet connection which can be used within AWS. Next on this list, we have something called as messaging. Yes, AWS assures secured messaging, and there are quite a few applications to take care of that as well. Now we have something called as Cloud Trial, we have OpsWorks, all these things, they help you in messaging or communicating with other parties basically. Databases. Now storage and databases are similar, but you have to understand one difference. When you talk about your storage, that is where you store your executable files. So that is the difference between the two. And when you talk about databases, we have something called as your Aurora, which is something which is very SQL like and It lets you perform various SQL options at a very faster rate. And what Amazon claims is it is 5 times faster than what SQL is. So yes, when you talk about Aurora, again, a great service to have. We also have something called as DynamoDB, which is a non-relational DBMS. And when you talk about non-relational DBMS, I won't be discussing that, but this helps you in dealing with various unstructured data sources as well. Next on this list, we have the last domain, that is the management tools. Now, when you talk about management tools, we have something called as CloudWatch, which is a monitoring tool, and it lets you set alarms and all those things. Hopefully today, when we are done with the demo part, you'd be having at least one part of your CloudWatch covered, because we would be creating alarms using CloudWatch today. So stay tuned for that as well. So this was about AWS and its basics, as in the points which we just discussed, that is what it is, its uses, its advantages, its domain, its global architecture. So yes, guys, what I've done is I've gone ahead and I've switched into my AWS account. The first thing you need to understand is what AWS does is it offers you a free tier. Now, while I was talking about these things, I just rushed through it because I knew that I was going to give you a demo on these things. So, and I wanted to discuss this thing in detail. Now, when you talk about AWS, if you are a beginner, this is where you start. Now, what AWS does is it provides you with its free tier, which is accessible to you for 12 months. And there are quite a few services which we just discussed, which are available to you for free. And when I say free, there's certain limitations on it, as in these many hours is what you can use it for, and this is the amount of memory or storage you can use in total, and all those things, and its capacity and everything. Based on that, you have different instances which you can create and all those things. Now, what AWS does is it gives you these services for free, and as long as you stay in the limits that AWS has set, you won't be charged anything. And trust me, when it is for learning purposes, that is more than enough. And let's quickly go ahead and take a look at these services first, and then there are a few other points which I would like to discuss as well. But firstly, the free tier services. Now, say this is what it has to offer to you: 12 months of free and always free products. When you talk about EC2, which is one of its most popular compute services, 750 hours, and that is per month. Next, you have Amazon Quick Site, which gives you 1 GB of spice capacity. Now, I won't get into the details of these things, as in what spice capacity is and all those things. When you have time, I would suggest that you go ahead and explore these things, as in what do these things do. Today, we are going to focus more on the EC2 part. So for now, let's quickly take a look at these one by one first. Amazon RDS, which gives you 750 hours of your T2 micro instance. Amazon S3, which is a storage, which again gives you 5 GB of standard storage. And AWS Lambda, 1 million free requests per month. So there are some of the videos here actually which would introduce you to these things that would help you get started with how to creating an account and all those things. And this is the other important point which I would like to mention. When you do create an AWS account, the first thing you need to consider is they would be asking you for your credit card details. So how does the login process work? Firstly, you go there, you give in your email ID and your basic details, as in why do you want to use it and all those things. Next, what it would do is just to verify your account, it would ask you for your credit card details. Even the debit card details work. I've actually tried those. So you can go ahead and give your credit card or debit card details. And when you do that, what it does is it subtracts a very small amount from your account. I did this in India and I know that I was charged 2 rupees, which is fairly less. And that was again refunded back to me in 2 to 3 working days. The only reason they cut those 2 rupees was just for the verification purpose that my account is up and running and I am a legitimate user. Now, as long as you stay in the limits, you won't be charged anything. But if you do cross those limits, you'll be charged. Now, you might be worried, as in, what if I do cross the limit? Would I be charged? Yes, you would be. But the fact is, you actually won't go beyond it. And even if you do, you'd be notified saying that you are going about the limit or above the limit. Even when your free subscription ends, you're notified saying that do you want to enter your billing details and do you want to start billing? And if you say yes, only then you'd be charged for the subsequent months. And that is a very stringent process. You don't have to worry about it. That is, you won't be losing out on any money as long as you follow these rules. So if you do not have an account, my suggestion would be you go ahead, you would log into AWS and create your free tier account, which is a very easy and 2 to 3 step process. So guys, I would start this session by talking about what is an instance, We would understand what is AWS EC2 service, which is core for understanding instances in AWS. Then we would talk about different types of EC2 instances. We would understand how instance pricing models work, and we would take a look at a use case, which would be followed by a demo that walks you through all the stuff that we have talked about. So it is a fairly good content and a lot of stuff to study today. So guys, let us just quickly move further and take a look at these things one by one. So first and foremost, guys, we would be talking about an instance. So when you talk about an instance, we have this definition here. Let's try and understand what does this definition has to say first, and then probably I would throw in some light on that. So as far as this definition goes, it says an instance is nothing but a virtual server for running applications on Amazon EC2. It can also be understood like a tiny part of a larger computer, a tiny part which has its own hardware, network connection, operating system, etc. But it is actually virtual in nature. So there are a lot of words here and a lot of stuff has been said. Let me try and simplify this particular definition for you people. So guys, when I say a virtual server running on your application, not on your application, a virtual server that basically hosts your application is what I should say. So what do I mean by this? What do I mean by a virtual instance, a virtual presence of a particular device? Well, guys, when you talk about software development, application development, what you do is you're supposed to build in applications and run those on servers, right? But at times there are a lot of constraints like the space that you use, the resources that you want to use. Say, for example, certain applications run on Windows, certain run on Mac OS, and certain run on your Ubuntu OS, right? So in that case, I cannot always go ahead and have different systems, run different operating systems on them, and then run my applications on top of that, right? Because it is time consuming, exhaustive, and also consumes a lot of money that you invest into it. So what is the solution for that? What if I could have a single device and on top of which I could create virtual compartments in which I could store my data differently, store my applications, run my applications differently? Wouldn't that be nice? Well, when you talk about an instance, that is what it exactly does. You can think of it as a tiny part of a computer. Well, that is what it is trying to symbolize. I mean, you have a system on top of which you can run different applications. And how it works is if you are running an application A in part one and running an application B in part B of your server, these applications have a feeling that they are running individually on that system and there is no other system running on top of it. So this is what virtualization is. It creates a virtual environment for your application to run. And one such instance of this virtual environment is called as an instance. So when you talk about virtualization, it is not something that is very complicated. As you can see in the first image, you can see a man surrounded by various virtual images, something that you see in an Iron Man movie. When you talk about virtualization, it is very simple. It can be a simple computer which is shared by different people, and those people are working quite independently on that server. That is what virtualization is. That is what an instance is. In this image, the second image, each one of this individual would be using a different instance. So this is what an instance is when you talk about virtualization. So guys, let us move further and take a look at some other pointers now. We've understood what an instance is, what virtualization is, to some extent at least, guys. As far as this session goes, I believe this information is enough. If you wish to know more about virtualization, you can visit our YouTube channel and take a look at VMware tutorial. It talks about this particular topic in a lot more detail. So guys, let us move further and try to understand EC2 now. Now, EC2 is an Amazon Web Services compute service. It stands for Elastic Compute Cloud. Now, what do I mean by this? When you say an elastic cloud compute, that means basically it is a service which lets you actually go ahead and carry out computation practice. And when I say elastic, it means that it is fairly resizable and fairly reusable. Once we get into the demo part, probably you'd get a better picture. What do I mean by elasticity? Because it is highly flexible, highly scalable, it is very cost efficient, and it serves a lot of purposes. Now, these are some of the features that I just mentioned, right? Let me throw in some more light on these pointers as well. What do I mean by scalable? Now, when you talk about a cloud platform, one of its best features is it gives you high amount of scalability. That means your applications can scale up and down depending upon the data that you want to use on top of it. So if the traffic increases more, you need more performance. So your application should be able to scale to those needs, right? So that is what cloud computing provides you with. And that is what EC2 also provides you with. When I say an instance, basically what you're doing is you're launching a virtual machine. It is called as instance in terms of AWS. So this virtual machine should be scalable. That means it should scale up and scale down, both in terms of memory, storage, and even in terms of the computation that it is providing. So when you talk about EC2, it is highly scalable. Once we get into the demo part, you would see this. Now, it being scalable and it being cost efficient makes it highly flexible. So that is the third point. Let us try and understand the second point as well. What makes EC2 cost efficient? Now, when you talk about cost optimization, what EC2 does is it lets you scale up and down. I just mentioned that, right? So instead of buying n number of instances or instead of buying n number of services, you can actually go ahead and scale this instance up and down with minimal cost changes. So you're saving money. Plus, apart from that, there are burstable instances. There are various pricing models that EC2 boasts of, using which you can actually save a lot of money. As we move further, we'll be talking about those models as well. So meanwhile, just bear with me. So EC2, well, it is a service which is a computation service and it takes care of following pointers. I mean, it is easily resizable, it is cost efficient, it is highly scalable, and all these features make it highly flexible as well. So guys, let us move further and take a look at some other pointers as well. So what are the types of instances? Now, when you talk about EC2, it is one of the oldest AWS services. So if you talk about the type of instances that are there in the market, well, there are quite a few types of instances that you can deal with. And these are some of the popular ones. Again, once I move into the demo part, I would maybe talk about other instances, but to keep it simple, basically these instances, they have different families. I mean, you have the T series, you have the M series, the C series. Well, basically these series consist of different kind of instances that serve different purposes. To simplify this process, what AWS has done is it has gone ahead and categorized these instances into following types. The first one is your general purpose instance. Now, it is basically suited for applications that require a balance of performance and cost. That means places where you require quick responses, but it is still cost effective. I mean, say for example, the example shown here, email response systems. Now, you require a quick response and there will be n number of responses or n number of emails that would pop in, but you do not want to pay a lot of money for this kind of service. So in this case, you need cost optimization as well, and you need a quick response as well. So this is where your general purpose instances come into picture. Next on this list, you have your compute instance. Now, what are compute instances? These are for applications that require a lot of processing. Now, when you say computation, they have better computation power. That means if there is a lot of data that need quicker computation power, you can use these kind of instances. What is an example? You have your analyzing streaming data. Now, if you know what streaming data is, it is the data that continuously flows in and flows out. That means you are streaming that data. Say, for example, this session, it is being streamed, right? I mean, the information or whatever is happening here, it is going live. So in order to process this kind of data, you need systems that give you good computation power, which are very active and very good in nature. So when you talk about compute instances, they provide you with these kind of services. And that is why if you are dealing with streaming data, if you wish to analyze this kind of data, you can definitely go for compute instances. So next on this list, we have memory instances. Now, what are these instances for? Now, these are the instances that are required for applications that require more memory, or in better terms, more RAM, right? Random access memory. So these are for applications that require good computation power, again, like the previous one. But when you talk about RAM, it is something that resides in your local system, right? So you need instances which have good memory capacity. And what kind of application it serves? Well, you can think of applications that need multitasking, multiprocessing. Say, for example, I need a single system that does fetching data for me as well, process it for me as well, dashboard it for me as well, and then gives it to the end customer as well. So these kind of applications require memory instances. Moving further, guys, we have the storage instances. As the name suggests, these applications are, or these instances are for applications that require you to store huge amount of data. Say, for example, you have large size applications like your big data applications, where the amount of data is huge in number. So you'd be requiring more storage flexibility. In that case, you can opt for instances that are specifically optimized for storage kind of requirements. And then you have your GPU instances. If you know what GPU is, you would understand what it serves. That means if you are interested in graphical kind of work where you have basically heavy graphics rendering, in that case, you can opt for GPU kind of instances, which basically help you serve purposes like 3D modeling and stuff like that. So guys, this was about the different kind of instances. Now let us try and understand what are the different instance pricing models that are out there. So guys, when you talk about pricing, EC2 or AWS in general, it ensures that you can save a lot of money. But normally what people do is they are under the imagination that if you just go ahead and take in cloud, probably you'd go ahead and save a lot of money. Yes, cloud does support applications in such a way that you would spend very less amount, but it involves a lot of planning, guys. So each time you use a particular service, it is very important you understand how does that particular service work. And if you actually plan in the services in that manner, you'd actually end up saving a lot of money. So guys, let us try and understand how the pricing models work when you talk about EC2 in particular. So guys, these are some of the pricing models that EC2 has to offer to you. You have your on-demand, dedicated, on the spot, and reserved instances. Now, let me try and simplify what these instances are and what do I mean by these. Now, when you say an on-demand instance, as the name suggests, it is an instance that you demand and you get it. Now, these instances are made available to you for a limited time frame. Say, for example, I need a particular instance for an hourly basis. So I would be wanting to use that instance for only that duration. So to use that instance for that particular duration, what I do is I actually go ahead and demand this instance. So AWS would give me that instance, but it would work for an hour only. So my prices for that instance would be fixed on that manner. I mean, the fact that I would be using it for one instance or for an 1 hour basically. So I would be charged only for that 1 hour. And once that hour is complete, that instance, it gets terminated on its own. It's similar to renting a flat for 1 month. Suppose if I move to a new city and I'm looking something temporary. Say for example, I'm looking for a hostel or a paying guest kind of a living system, right? So in that case, what I would do is I would upfront go and tell the owner that I would be staying here for a month. You can charge me for a month only. If it is 1,000 more than normal charge, it is fine. But once the month is over, I would like to leave, right? So that kind of service or that kind of instance demand is called as on-demand instances, basically. Dedicated, now guys, these instances are kind of given to a particular organization so that their security is defined better than other. Say for example, if I need to protect my data, I need my data to be privatized. Now understand this thing, AWS or the other cloud platforms are highly secure. Your data is secure no matter whether they are on dedicated instance or not. But what happens is you normally share your space with someone else, data remains private. But there are companies that deal with highly confidential data, and in that case they want that extra assurance as in, okay, I am using a space which is not shared by anyone. So in that case, you have dedicated instances which basically serve your needs like high security and basically an isolation from the other vendors as well. So that is what dedicated instances do. They are costlier, but yeah, they give you that isolation on spot. Now, guys, when I say an on-spot instance, it is like bidding. Say, for example, I am buying a particular share. So I have a particular budget, right? So I might have a budget of $300. So what I do is I go ahead and buy that share and I set in a cap as in, okay, to the max, I can bid for $300 for this share. So if the price goes above $300, I'm not taking that share, right? So if there is a particular instance, you can bid for that instance as in, okay, this is the maximum price that I pay for this instance. So if that instance is available at that price, it is given to you. And if after a particular duration, the price of this instance can change, so it is available to you for a limited period of time. So if you are dealing with data that is volatile and you want to work on that data in real time, so you can opt for this instance. because after a while the price of this instance might change and this instance might be terminated and you might not be able to use it for a longer while. But the thing it does is it is available to you at a cheaper price and at a pricing bid that you put on it. So that is why it is more affordable. But again, it is good for volatile data only. Finally, you have the reserved instance. It is like renting an apartment on a lease for a longer period, right? I mean, suppose if I'm getting a flat on an agreemental basis where I sign an agreement for a year, that means I am reserving this flat for one complete year, right? So nobody else can come and say that, okay, you have to vacate this flat, right? So that is one benefit. And the other thing is you have a fixed set of rent. So if you're taking something for a longer duration, there's a chance that you might end up paying lesser money for that as well. Now, what happens here is when you talk about it from the instance perspective, suppose you know that you would be needing this much configuration for this duration, you can rent that particular instance for that duration, and probably you end up saving a lot of money. Now, when you talk about AWS, it gives you flexibility where you can actually go ahead and upscale, downscale your instances to your needs. You can kind of terminate stuff and move to the next stuff. But if you are certain about certain things, as in, okay, I have to use this no matter what happens for a longer duration, in that case, you can opt for reserved kind of instances, and those are more affordable to you. So guys, these were different types of instances based on the pricing that is there. Now we've talked about general clusterization of instances like the general purpose, the GPU, that was based on their functioning, right? Then we learned about their pricing models as well. Now there is one more type that we need to understand, or one more classification that we need to understand. Let us try and take a look at those as well. So we are classifying instances based on their general functioning. Now what do I mean by this? Well, these are the types. Let us take a look at those one by one first. So when I say burstable instance, we've talked about general purpose instances, right? So what happens is there is a category of general purpose instances which start with a base utilization power available to you. That means if you want to utilize your CPU for a certain amount, burstable instances are good here. Let me throw in some more light as in what am I talking about exactly. Suppose I need a CPU utilization of 20% and I know that. So I can go for burstable instances. What they do is they start with a functioning of 20%. But in case if I'm dealing with data that is not constant, that might change with time. Say for example, if my website experiences more traffic, so I might need more performance, right? So in that case, what burstable instances do is they burst out of their current performance to 100% CPU utilization so that you can get more performance. Now, what happens here is you are charged a particular amount for these instances, and you have certain credits for which you can use the burstable performance. Now, if you do not use the burstable performance, those credits can be used later as well. So you are getting optimized performance as well, and you are saving some money as well in case if there is an urgent traffic that you experience. You have something called as EBS optimized. Now, when you talk about EBS optimized, now these are the applications where basically you are processing data at a higher speed. Say, for example, there is some application where the data is flowing in continuously. So I need quick response, right? So EBS backed up or EBS optimized instances, what they do is they give you high input output processing. And that is why these are good instances to opt for these situations. Cluster networking, basically they form clusters of instances. Now a particular cluster, what it does is it serves one kind of purpose. Say for example, in my application, what I want is I have different sections, and in different sections my first section requires to be processing data at a faster rate. The other one I want it to be storage optimized, so I can define different clusters of instances that serve different purposes here. And then I have the dedicated one. We've already talked about dedicated one. It is more related to the data security part. So guys, these were the different types of instances. I know I've talked about a lot of stuff. Once we get into the demo part, probably this would ease up a little more for you people. I believe you people are with me and you are following this session. So guys, now let us move further and take a look at the use case so that we can just move further and take a look at the demo part as well. For this use case, I've considered Edureka itself. Let us try and understand what could be the possible problems that can be solved by using these instances. Now, Imagine that if Edureka used AWS as their cloud partner and they used the EC2 service. So what kind of problems could be solved by these instances that we just talked about? Suppose we have the first problem where you have to analyze the data of the customer. So what kind of application would you use? Can you guess that for me? I won't be looking at your answers. Let me just quickly go ahead and give you other examples as well so that we can discuss these one by one. Suppose you also have an auto response email system. Now compare these two and let me know which one would you believe would be served better by these instances that we've just talked about. So when you talk about the performance here, guys, when you talk about analysis of data, for the customer's data, it is never constant, right? At times the data is huge, at times it is less. So in this case, I would need burstable performance. So my general purpose burstable performance instances would serve me better, right? Auto response email system, I need quick response, but I do not want to invest a lot of money. EBS optimized instances with IOPS would help me better. Search engine and browsing, I believe it is fairly clear. I'm talking about browsing and search engine, two different things I want to do. I would be opting for clustered network instances, right? And confidential data, well, I would be opting for the dedicated instances here. So guys, this was a very simple use case. So let us move into the demo part and try and understand EC2 a little more, shall we? So guys, what I've done is I've gone ahead and I've signed into my AWS management console. Please forgive me guys, I have a lot of cold today and that is why my voice is little jiggly and echoing. So I hope you people are not offended by that. Moving further guys, this is the AWS management console. You can sign into AWS free tier account and probably avail these services. You can practice a lot of stuff by signing into your free tier account. How do you do that? Just go ahead and look for AWS free tier and sign in with your credit card or debit card. You won't be charged. You have these services for free for one complete year and you can practice most of the services that are there. There is some free tier limit on these services. So check the upper cap as in what those limits are so that you don't get charged. So guys, this is how the console looks like. We are going to go ahead and learn about EC2 here. That is the instance service in AWS. So let's search for EC2 and you would be redirected to this page guys. Now when you talk about EC2, there are a lot of things that you can do. You have Amazon Marketplace where you have AMIs. I will tell you what AMIs are, do not worry. You can just go ahead and launch your instances. You can attach volume to it, you can detach volume storage from these instances. And when I say AMIs, those are Amazon machine images. That means once you create an instance, you can create an image of that instance as well. That means a template of that instance as well. Suppose you have certain applications running on top of that instance, certain specific settings that you've done for those instance, and you do not want to do those settings again and again, you can create images of that instances as well. So let us see what all we can do with these instances. So let us first launch an instance. So guys, once you click on that launch instance button, you would be given n number of options to choose from. You can launch Linux instances, Ubuntu instances, Windows instances, and you can choose the EBS backed up, non-EBS backed up. So there are a lot of choices when you actually go ahead and launch these instances. You can see there's Ubuntu, Red Hat, Microsoft Windows, and there are specific instances specialized in deep learning, some of our server specification. You can see that there are quite a few instances, but ensure that if you are practicing, choose the free tier eligible one. For now, I'm going to go ahead and launch a simple Windows instance. Let's not get into the Ubuntu one because it requires a partition to sign in for that. So let us not do that. So guys, once you click on launch an instance, you can see that you are redirected to this page. Now, if you take a look at the information here, it talks a lot. Now, this instance is general purpose. We've discussed the other families, right? This is one. This one is T2 micro. There are T2, T3 micro and medium and bigger instances as well. The sizes vary, guys. The T2 micro one is free tier eligible. You have T2 nano, you have small, right? So you have medium and other large instances as well. So when you say a micro one, it has one vCPU and 1 GB of memory. Instant storage, it is EBS backed up. And what kind of network performance it gives you? Low to moderate. So I would say configure further. These are some configuration details, what network it is following, what subnet ID it is following. That means it falls under the cloud network, guys. That means your cloud would have a network, and under that network lies your instance, so that its access policies, security policies can be managed. So let it be basic for now. Let us move further. Storage. Now, guys, this is the storage. It is your root storage and 30 GB of space. You can change it if you want, say 100, but let us stick to 30 for now. And guys, you can see these are the types. You have your general purpose, you have your provisioned, magnetic. Now there is one more type of instance, guys, that is HDD kind of an instance. But guys, when you talk about root storage, you cannot attach HDD to it, right? Because root storage is something that is constant. If you wish to have HDD kind of storage, it has to be attached secondary. So if I add new volume here, you can see, and if I search for this, now it gives me an option of cold HDD, right? So that is what, guys, I mean, in order to have this kind of HDD kind of a volume, you need to use secondary storage for it. So let us cancel this for now and just go ahead and say next. You can add in tags, guys, for the simplicity of namesake. Say for example, sample today, and let's just say next. Security group, guys. Security group, what do I mean by this? Well, basically you have a set of policies, as in who gets to access, what kind of traffic do you want to your instance, what kind of traffic do you want to flow out of your instance. So you can create a security group and you can use customized as well. When you create one, this type is RDP. That means it can allow traffic from a desktop or a remote desktop app, and through which I can log into my system. I can add other rules as well. I can add TCP, HTTP kind of rules, and these are the port ranges. You can specify those. For now, I'm allowing traffic from everywhere through RDP, and I can say review and launch. Improve your security, it says, but this is a basic one, guys. You can add in more rules, as I've already mentioned. So let's not do that. Let's say launch. Generate a key pair. Now, a key pair is something that lets you log into your instance. It is a double security for your instance. You do not want your instance to be left insecure, right? So in that case, you need to generate a key pair. You can use an existing one, or you can create a new one as well. So let's just say that I want to create a new key pair. So I say create, and let us say Vishal 34121, and let's just say download. So guys, once you download this instance, what you do is Control X, cut it from here, and I'm gonna go ahead and paste this instance to the desktop, guys. And let's just say paste. Here it is. So the reason I'm doing this is because basically we would be needing this thing, guys. If you lose this key, there is no other way to access your instance. So make sure you keep it safe. And I say launch. So guys, now this process, it takes a minute or two to go ahead and launch your instance. So meanwhile, you'd have to bear with me. So what happens is, once you do actually go ahead and launch this instance, it involves a couple of steps, like basically it does some security checks, some status checks. And while these status checks happen, it takes a minute or two. And once the instance is up and ready, we can actually go ahead and take a look at this instance. So meanwhile, guys, what I'm going to do is I'm going to go ahead and take you to the EC2 part. Now there are three instances that are running, guys. Now this is somebody else's account, so there are quite a few other instances that are running. You can see that there must be some instance here which basically is initializing. So this is the one that we are going to use. This is the ID. Let's not remember that. We know that this is getting initialized. So guys, these are the other instances. This one is stopped. Let us take a look at this instance as well to understand as in what happens. So guys, these are the options that I have, right? So you can actually go ahead and get the password. You can create a template for your instance. What you can also do is you can start, stop. Now this instance is already stopped, so you do not have these options, that is stop, hibernate, and reboot. You can start this instance and probably you can go ahead and do that. Now when you stop an instance, if you want to actually make snapshots, you want to take snapshots, you want to create Amazon machine images out of it, what you do is you stop that instance so that you prevent any activity from happening on that instance, so that you can take an exact snap of it. So that is why you stop an instance when you wish to do these kind of operations. Once you start it again, you can make it function normally at it was functioning. If you are done using an instance, you can terminate it there and there, guys. So these are the options. Instance setting. Okay, so guys, these are the options. You can add tags to it. You can attach, replace IAM rules, that is access management policies, guys. So you have a user access management policies here. You can attach roles to it as well. You can change the instance type, guys. You can click on it and you can go ahead and do that. You can change it to higher versions as well. Now, why do you need to do this? Suppose I'm experiencing a particular traffic and my instance supports that need. But if I move further and in future I need to cater more traffic, what do I do in that case? In that case, guys, I can actually go ahead and update it to a larger version. Unlike your other applications, your on-premise infrastructure, where you have to actually go ahead and have new servers, new data on top of it, here what you do is you just click on this thing and it happens in a couple of seconds. Your instance gets optimized or upscaled to a better level, and that is why it is highly scalable. Guys, what you can also do is you can change termination protection. Now, this is for data security. Suppose if I am using a particular instance and in that case, I accidentally delete it, my data would be lost, right? So what this thing does is it changes or turns my termination protection on. That means if I have to delete this instance, I have to get into the instance, I have to change the policy and then delete it. I mean, I cannot delete it unknowingly, right? So that is why this service helps. Now, while talking about these things, guys, our instance is up and ready. Let us just launch it. I say connect, and it says download remote desktop file, the RDP path that I talked about, right? And I need to get in my password as well, guys, to log in. How do I do that? I click here. I choose the file. For that, I'm gonna go to the desktop. I'm gonna scroll down. There is a file called as Vishal. I open it and I decrypt it. And there you go, guys. My password is here. I can just copy it. So if this is copied, I can launch this remote desktop file. It would ask me for the password. I would say take this and okay. Do you want to log in unsecurely? Yes. And guys, a Windows instance would be launched. It is just like your Windows operating system, but it is running on my existing system, guys. There you can see personalized settings. It is setting up personalized setting for me, and in half a minute or maybe in 10 seconds, my Windows app would be up and running. So just like my Windows device, I have one more Windows device. So I can do something in this device and something else in my normal Windows device as well, guys. So this is what your instance does. It basically creates an instance, a virtual machine for you to work on. I believe by now you've understood what a virtual machine is. So guys, we are done with this part. So let us just close it for now. Let us see if there is anything else that we need to talk about. Now, if I come back here, I've mentioned that you can take snapshots, right? So these are AMIs. What AMI is, it is an image basically. So I can actually go ahead and launch an AMI for an instance that I already have. I can create an image of it. There is a volume here. So my instances are EBS backed up, right? So there is a block storage attached to it. Can I add another storage to it? Yes, I can remove the previous storage and attach a different storage to it. Say for example, this is the storage that I have with me. If I click on it and I go into actions, I can create a snapshot out of it. Once I create a snapshot out of it, I can attach it to the existing instance. So we just launched an instance, right? So if I want to replace the volume that is already attached to it, what I do is I actually go ahead and detach the volume that is already attached. So I would be stopping my instance first. Once I stop the instance, I can come to the volume. Assume that this volume is attached to some instance. So I need to detach it from here. And the snapshot that I've already created, or if I have created one, I can select that and I can attach that to the existing instance. All I have to do is I have to go ahead and create an image here. Once I create an image, it would ask me what can I do with it. It would ask me to actually go ahead and give in the region in which the instance was created. Now, my instance that I just used was created in a particular region. I'm working in Ohio region for now. What do I mean by these regions? Well, basically what happens is AWS has different data centers in different regions of the world. So you can choose the region that is convenient to you, that suits your business needs, right? So I can create instances in those particular regions. So if my instance was in particular region, I need to create a snapshot in that region and then attach that snapshot or that volume to my instance. So guys, I believe by now you've understood a lot of things. You've understood what instances are, how to launch those, how to create those, and how to make those work. So as far as this session goes, guys, I wanted to talk about these pointers. One more important point that I would like to mention here is make sure that you terminate your instances so that to avoid any charges if there are any. Now, this being a free tier account, I don't think there would be a lot of charges, but still I would request you to actually go ahead and terminate the instances even if they don't charge you a lot, because that is a good practice, because there are certain services that might charge you a lot more, guys. So I'm gonna terminate my instances, the ones that I have created today. So let's just say terminate. And in a minute or two, guys, these instances would be terminated from end to end.
Today's session is going to be all about AWS Lambda. So without making any further ado, let's move on to today's agenda to understand what all will be covered today. So we'll start off today's session by discussing the main services in the AWS compute domain. After that, we're going to see why AWS Lambda is as a separate service. We're going to discuss what AWS Lambda actually is, and then we'll move on to the part where we'll see how you can use AWS Lambda using the AWS SDKs. Once we're done with that, I'll teach you guys how you can integrate your SDK with the Eclipse IDE. And in the end, we'll be doing a demo. So let me quickly show you guys how we'll be using AWS Lambda in today's demonstration. So guys, this is a website that I created which is hosted on the local host. Now what this website does is it uploads a file onto the S3 file system. Now once the file is uploaded, it sends me a mail regarding that. Now that mail is generated by AWS Lambda. Now let me quickly show you how that mail actually looks like. So let me upload a file over here. So let file be this. I click on open. And before uploading image, I'll show you my inbox. So as of now, I don't have any emails, as you can see, right? So what I'll do is I'll click on upload image. Now it says S3 upload complete. Now what this website does is it will upload my file, it will rename the file according to the system time so that there is no conflict in the name of the object, right? So whatever file that I've uploaded right now will be uploaded in this bucket. So if I refresh this, you can see that there's a file over here, right? So this file has now been renamed, right? And I also have an email over here which says AWS SES test, right? So if I click on this email, I can see that I have got a mail from this address saying that an object has been uploaded. The name of the object is this, the size of the object is this, the bucket name is this, and it was last modified on 12/31 UTC. All right, so let me quickly compare whether this file name is the same. So it's 748 and it says 748 here as well. Awesome. Now the next cool thing that you can do over here is you can move this file to some other folder. So all you have to do is you will reply to this mail by saying move. You click on send. Now when I send move to this email address that I've configured in my code, what it does is it will basically move this file from this bucket to some other bucket. So let me quickly refresh it and see whether my file has been moved. So as you can see, my bucket is now empty. Now let me go back. So basically my file was there in Eureka demo. Now it will be there in quarantine demo bucket. So as you can see, 748 file has now been moved to the quarantine demo by simply writing a mail over here which says move. So we'll be creating this demo today. Let's move on to the first topic of today's discussion, that is the AWS compute domain. So the main services under this domain are EC2, Elastic Beanstalk, and AWS Lambda. Now among these three, the most important service is EC2. So EC2 is basically just like a raw server. It is like your personal computer that you're working on remotely, right? So it can install any kind of operating system of your choice, which is supported by the AWS infrastructure. And then you can use it in any manner as you want. You can configure it to become a web server. You can configure it to become a worker tier environment, anything. Our next service is Elastic Beanstalk, which is an automated version of EC2. So with Elastic Beanstalk, you don't get the access to the operating system, but you still have a control over the configuration of your system. So you can choose what kind of instance you want to launch, right? So Elastic Beanstalk is used to deploy an application. So basically you just upload your code and your application is deployed on the AWS infrastructure, right? So this is what Elastic Beanstalk is all about. Then we have the AWS Lambda service. So the Lambda service is again an automated version of EC2, wherein you don't get the access to the operating system. With AWS Lambda, you don't even have the choice to choose what kind of configuration you want with your server, right? So with AWS Lambda, you just have to upload your code and it executes. It's that simple. But then why do we have an AWS Lambda service when we have Elastic Beanstalk? So let's understand that. So AWS Lambda, like I told you guys, it is an automated version of EC2, just like Elastic Beanstalk. But then with AWS Lambda, you can only execute background tasks, right? You cannot deploy an application. So AWS Lambda is not used to deploy an application. It is used to execute background tasks. Other than that, like I told you guys, you don't have to choose the configuration in AWS Lambda. You don't have to choose what kind of servers you want. Depending on your workload, the kind of configuration, the server configuration is assigned to you, right? So this is why we use AWS Lambda. But then let's go on to the definition part and see what AWS Lambda actually is. So according to its definition, it's a serverless compute service because you're not choosing the servers, right? You're not choosing what kind of configuration you want in your server. It's a serverless compute service. You just upload your code and your code is executed. It's that simple, right? And also, like it's mentioned in the definition, and I told you guys again and again, it is used to execute background tasks. It is not used to deploy an application. Guys, this is the main difference between Elastic Beanstalk and AWS Lambda. So as an architect, you should know what the use case is and which service will suit it better. So moving on, now we've understood what AWS Lambda actually is and why do we use it, right? So let's move ahead to see how you can use this service. So you can use this service using the software development kits which are provided by AWS. So before moving ahead and understanding how you can use these kits, let's understand what these kits are all about. So the software development kits are basically APIs which are used by developers to connect to the desired service that they want. So it makes the life of the developer easy because he can now concentrate on the logical part of his application rather than wasting time on understanding how he can connect his code to the service which is there on AWS. Right. The other part is that these SDKs are used with IDEs, right? So currently we have only two IDEs which are supported, that is Eclipse and Visual Studio. So today in this session, I'm going to teach you guys how you can connect your SDKs with the Eclipse IDE. So let's do that. So before that, we're going to configure or we're going to code our AWS Lambda function in Java, right? And that is the reason we're using Eclipse. Now, first of all, you have to install Eclipse on your system. Once you do that, this is the Eclipse screen, guys. This is how your Eclipse dashboard will look like. So for installing AWS SDK on your Eclipse, you have to click on Help, and then you'll go to Install New Software. Once you have reached here, you'll enter the website name, that is aws.amazon.com/Eclipse. Once you have entered that, just hit enter and it will list you guys all the SDKs which are available, all the tools which are available. Select all the tools and click on finish, and then it will take some time to download the SDK, but then it will integrate everything into your Eclipse. And then you'll have a button like this over here, right? So with this button, you can actually deploy a new server which is configured according to AWS. So guys, this is how you install SDKs with IDE. Alright guys, so it's time for the demo now. Enough of theory. So what we'll be doing is, our aim is to create an application which will be uploading our files onto the S3 file system. And what our Lambda function here it will be doing is, so like I told you guys, Lambda function basically executes your background task. right? So that we don't want to burden the server on which the website is hosted with this task. We want some other server to execute this task. What is this task? We basically want to get an email with all the details of the file which has just been uploaded on the S3 file system. So that email will be sent by the Lambda server. Now once we get that email, if we reply to that email that the file has to be moved, Lambda will pick up that email, it will read that email, and it will perform the necessary operation. So if we specify move, what it will basically do is it will pick that file, move it to some other bucket, and store it over there. So this is the project that we'll be doing right now. Sounds simple, right? But let me show you the architecture. Let me explain you what the architecture tells you. So basically this is our website. So what our website will be doing is it'll be uploading a file onto the S3 file system. At the same time, it will also be making an entry into the SQS, which is nothing but a simple queue service which queues your data, right? So as soon as your file is uploaded onto S3, S3's bucket is configured in a way to invoke the Lambda function. Now, as soon as the Lambda function is invoked, now Lambda functions are stateless. They don't know anything about what file you have uploaded or what you have done. You have to feed them information. And that is the reason we have updated the entry in SQS of the file which has recently been uploaded, right? So what AWS Lambda will do is it will read this queue and will get the file name and will actually retrieve all the properties from that file name from S3. Now once it has retrieved all the file names, all the properties of that file, it will actually mail me with using the SES service in AWS the details of that file. Now once I receive the details of that file, I have an option to reply to that email, right? Now how will I reply to that email is like this. So I will open the email client on my computer and I will reply to that email. That email will actually go to that address which is actually pointed to my DNS server, and that DNS server will actually redirect that email to SES. Now SES on receiving that email has been configured to invoke the Lambda function. That Lambda function will be invoked. Again, the file will be read from the SQS. That file will be moved to a new bucket, and in the end that message will be deleted by SQS. Now my SQS has been configured like this, that in case I don't reply to that email within 2 or 3 minutes, that message will automatically be deleted from the queue. And in that case, if you try to move that file, you will not be allowed to do so because that file is no longer available in the queue, hence you cannot move it, right? So this is what our project is going to be all about. Now I have already showed you how the project works. So let me quickly delete the project and again show you how it can be configured from scratch, right? So give me a moment. Alright, so everything is set. Now the first thing that I'll be doing is I'll be configuring my S3 to interact with my Lambda function, right? So what I've not done is I've not deleted the Lambda function because there's no point. You just have to click next and your function will be created. What matters is the code. So I have uploaded the code in your LMS with the proper documentation. If you have any doubts, you can actually email me regarding that doubt and I'll clear it for you. So as an architect, your job will be to architect this architecture, not the coding. The coding part has to be done by the AWS developer, but it is a good to know knowledge, right? So that is the reason I've uploaded the code for the website and AWS Lambda to your LMS. Okay, so like I said, I have to configure my S3 so that it can interact with AWS Lambda. Now my website's code is like this, that it'll upload the file to a bucket in S3 called Edureka demo, right? So what we'll be doing is we'll be going to the Edureka demo bucket, which is here. I'll click on the Edureka demo bucket. I'll click on properties. I'll click on events, and let me delete this event right now, right? So I will be adding a notification now. Now let me call this notification as AWS-Lambda, right? Now what I want it to do is whenever the event is a put event, that is an upload event, I want it to send a notification to my Lambda function. So I have to select the Lambda function. So my function should be this one, and I'll click on save. Let me check if everything has been filled. Yes, it has. So let's click on save. All right, so I have one active notifications now. Now you might get an error over here saying that you don't have sufficient permissions. So if you get that error, on the right hand side you'll have a button called add permissions. Just click on that button and everything will happen automatically. Basically those permissions are for your Lambda function. Your Lambda function may not have permissions to get notifications from S3, but once you click on that button you'll get the proper notifications automatically. Right? So this is how you will configure your S3 bucket. Now let's go back to our slide to see what other things we have to do. So we have configured our S3 to invoke our Lambda function once a file is uploaded to S3. Now our Lambda has already been configured to interact with SES through the code, which is, so through the code it will be calling the SES service and will be giving in a mail. Now the next function or the next thing is to configure SES, or before that let's configure our SQS, right? So our SQS is basically our simple queue service, so we have to create a queue in SQS in which our website will be uploading our files, right? So let's do that. Let us go back to our dashboard. So this is our dashboard, guys, and we'll go to the SQS service. We'll click on create new queue, FIFO queue, and that queue has to be named as hello-lambda. And since it's a FIFO queue, you have to give the extension as .fifo. All is done. Let's click on quick create queue. Okay, so my queue has now been created. Now I have to configure this queue so that whenever the message comes in, it gets automatically deleted after 2 minutes, right? So let us configure it. So we'll click on configure queue and we'll set this to 2 minutes. All right, all is done. Let's click on save changes. All right, so my queue has also been configured. Let me go back to my slide. All right, so my SQS has been configured now. So let me configure my SES now. Now this might be a little tricky, so hang on with me. We'll go back to the dashboard. We'll go to the SES service. Now first of all, in the SES service, you actually have to add the email addresses. Now how will you add the email addresses? You will actually have to verify a new email address. Now you have to verify the recipient as well. So since I want to receive the email from the SES service, I'll have to type in my email address, which is hemant@edureka.co, and we'll have to verify this email address. Now I'll receive a verification email on hemant@edureka.co. So let me quickly go back, click on inbox. Now I've got a verification request, right? So I'll click on this verification link. Okay, so my email address has now been configured, has now been verified. So it says congratulations. Awesome. So let me go back to my SES. It says pending verification. Let me quickly refresh it. All right, so it says verified now. Now let's go back to our slide. All right, so guys, we have configured the recipient of SES, but what about the sender, right? So we have to configure the sender as well, because and why do we have to configure the sender? And the sender has to be a domain name that you own, right? You have to own that domain name so that you can send emails via that domain name. Now what I mean by that is, you may say that, okay, why not use the recipient address only? Why not use hemant@edureka.co for sending the email? But our application also receives email, if you would have noticed, right? So for receiving the emails through SES, you have to actually own the domain name. Now since I'm an employee, I don't own edureka.co, right? So what I've done is, I have actually created a domain name. I can get a free domain name from this website, which is my.tk. You can go on this website and create a domain for yourself for free. So basically you will be getting this domain name free for 3 months. All right. I am almost on the expiry date, so I might have to renew it. Okay, but since this is a demo, let me quickly show you. All right, so I have actually created this domain name and I can use this domain name to send or receive emails. Now, what I'll have to do, or how do I configure this in my SES is like this. So you will go to your SES, you see this tab which says email receiving, right? So you'll click on rule sets and you'll have to create a new rule set. Before that, you have to actually verify a domain. You basically have to verify that the domain is actually owned by you. Now how you will do that? You'll click on verify a new domain and you will give your domain name here, which is edureka.tk. Click on verify this domain and you will get these two records over here. Now where will you enter these two records is actually in the DNS server. So the domain name edureka.tk has to point to a DNS server, right? And in that DNS server, you will be putting in these two records. Now, how will you point edureka.tk to a DNS server? So DNS server is basically Route 53, right? So we'll be configuring Route 53 with edureka.tk. Let me show you quickly how you can do that. Let me open my Route 53 service. So this is my Route 53 service. I don't have any hosted zones as of now. So let's click on get started now. Click on create hosted zone. So my domain name is edureka.tk, right? Click on create. Alright, so I have created a hosted zone now in my Route 53. Now what I'll have to do is I'll have to connect this domain to my Route 53. Now how will you do that? You will click on manage domain and you will click on management tools and you'll click on name servers, right? So these name servers have to be updated with the name servers provided you over here, right? So let me quickly show you. So you will copy this, paste it here. Remember guys, don't include the dot in the end, otherwise it will give you an error. So without the dot, copy the name server, right? So I'll first save to and see if it's working. Click on change name server. Alright, says changes saved successfully. Alright, so it's saving the servers now. So let me copy the rest too as well. Alright, so I've copied my name servers. I'll click on change name servers and fingers crossed. Okay, so it says changes saved successfully. Alright, so my domain name is now pointing to Route 53. Awesome. So now in Route 53, I have to include these records. Now how will I do that? Let me quickly show you. So you'll go to Route 53 and you will click on create record set. Now you don't have to type anything here. Just in the type, click on MX and in the value. So as you can see, there's a value for MX over here. Just copy this value and paste it here. Right, this is it guys. Nothing has to be done here. Click on create. Awesome. So I have a MX record now. Now we have to create one more record set and that name has to be like this, right? So I'll copy this part, paste it here. As you can see, now the name is underscore Amazon SES dot edureka dot tk, and as you can see the name over here is the same, right? So this name has to be the same and the type of value is txt. We'll select txt from here and then you have to enter the value. So the value is this. Enter this value over here and click on create. Awesome. So my Route 53 is now configured to actually receive the emails from the edureka.tk domain. Cool. So we'll go back to our SES now, close it. It says pending verification, refresh it. Alright, so as you can see, my domain name is now verified. Alright, so let's just go to the rule sets now. So email receiving we have to configure. So I'll click on view active rule set. There is no rule set, so I'll create a rule. Now I have to specify a recipient, so let me specify hello@edureka.tk. Right, I'll click on add recipient. So my verification status is verified because my domain name is verified now. We'll click on next step. Now what action do you want it to do? Right, so if you receive email on this email ID, what do you want to do? So what we want to do is we want to invoke a Lambda function. Now what Lambda function do you want to invoke? I want to invoke my function 2, and we'll click on next step. So everything seems fine. We'll click on next step again. So it is asking me the rule name. Let me give the rule name as lambda-demo. Click on next step and click on create rule. Okay, so my rule set has now been enabled. Awesome. So I have configured my SES as well. So let me go back to my slide. Alright, so I've configured my SES, I've configured my Route 53, I've configured my AWS Lambda, I've configured my SQS, I've configured my S3, and my website is also configured. Right, so we created a SQS queue, so we may have to change the URL in our code. So let's quickly do that. We'll go back here, go to the dashboard, click on SQS. Alright, so this is our queue and this is our URL. So basically I have named the queue same, so if you do that, sometimes the URL don't change. So let me see if I have to upload the code or not. So I'll go to my Lambda function handler, go to the part where my queue is saved. Alright, let me anyways paste the queue over here. I think it is the same. Yes, it is the same. Anyways, let us save it. This is my function 1, so let me upload the code now. So it's my function and click on finish. Right, so it is uploading the function right now. So meanwhile, let me go to my function 2 and configure in the queue address, which is this. Paste it here, Control S, save it. And once this process is complete, I will upload this code as well. So while this is uploading, let me change the address in my index file as well. This is my website's index file. So I'll go to the queue URL, which is this. I will change it, save it, and close it. Alright, so my website's address has also been done. Alright, so my code is uploaded for this function. Let me upload the code for function 2 as well because we have made change. Upload function to AWS. So it is my function 2, that is my function 2 in Lambda. Click on next and click on finish. Alright, so my code is being uploaded. Let's wait a while so that my code gets uploaded and then we can proceed with our demonstration. Alright, so my code has now been uploaded to both my Lambda functions. Now what I'll do is I will go to my localhost website, click on refresh, and I will upload a file. So let me go back and see what is there in my bucket right now so that it becomes easier for us to verify that a file has been uploaded. So as of now, my bucket is empty, right? There's nothing in my Edureka demo bucket. And my other bucket is quarantine demo. This is the place where my other file will go, right? So let me empty this as well so that we are clear that some object has been added. All right, so this bucket has also been cleared. So we'll go to our local host, we'll choose a file. So let's upload some image. So let it be this image, right? I'll click on open and click on upload image. All right, so it says S3 upload complete. All right, so let me check if a file has been added in my Eureka demo bucket. I'll click on refresh. Awesome, so one file has been added and it's called 149254609 Let me check in my email. So let me check if I got an email. So yes, I've got an email. Let me click on it. All right, so this is the name of the file that I got, which is the same, right? So let me see if there is something in my quarantine demo bucket. So there's nothing there. I'll come back. Now I'll reply to this email as move. So this basically means move my file to some other bucket, and I'm replying it to hello@edureka.tk, right? So now we'll hit on send. So my message has been sent to route 53, which will be sent to SES, which will invoke the Lambda function, which will move my file to the other bucket. So let us check if that is done. So first, let us check if our Edureka demo bucket has been emptied. So we'll click on refresh. All right, so my Edureka bucket has now been emptied. Let's go back and check if anything has been added in my quarantine demo bucket. Alright guys, so my file has successfully moved to this bucket. Let us verify the name. So this is 149254609. Let us check that in the email. So the email that we replied to had the object name as 149254609. So this is the same file, guys. Alright guys, so we have completed our demonstration successfully.
Welcome to this session on Elastic Beanstalk, a web application hosting platform offered by Amazon. So without any delay, let me give you a brief overview of what we will be discussing today. Firstly, we will see what Elastic Beanstalk exactly is, and then we'll discuss certain salient features of Elastic Beanstalk. Moving on, we'll try to understand Elastic Beanstalk a little deeper by taking a look at its components and then at its architecture. And finally, we'll try to deploy an application on Elastic Beanstalk for practical understanding of the concept. So let's get started. What is Elastic Beanstalk? If I have to define Elastic Beanstalk in Amazon terminology, then it is a platform as a service where you can deploy your application which you might have developed with programming languages like Java, .NET, PHP, Node.js, and many others on familiar servers such as Apache, Nginx, Passenger, and Tomcat. The definition which I just mentioned seems to have a lot of technical terms, isn't it? Well, let's try to figure out what Elastic Beanstalk is in simple terms. Alright, let's say you need to build a computer tonight. Well, you have two ways to go at it. First, you can go to a computer warehouse. Computer warehouse is a place where you have different components of computer laid out in front of you. Like you have CPU, motherboards, router, disk drive, modems, and many other components. You can choose whichever component you need and assemble them and form a brand new computer. This is similar to a situation when you try to deploy an application without using Elastic Beanstalk. When you try to develop an application by yourself, you'll have a list of tasks which you need to do. Like you might have to decide on how powerful you want your EC2 instance to be. Then you have to choose a suitable storage and infrastructure stack for your application. You might have to install separate softwares for monitoring and security purposes as well. Moving on to option B, you can always visit an electronic retail store which has pre-configured computers laid out in front of you. Let's say you're a graphic designer and you want a computer which has a modern graphical user interface installed in it. All you have to do is specify this requirement to a salesperson and walk out with a computer of your choice. Well, I personally prefer this option. This is similar to the situation where you're trying to deploy an application using Elastic Beanstalk. When you use Elastic Beanstalk to develop your application, all you have to do is concentrate on your code. Rest of the tasks like installing EC2 instances, auto-scaling groups, maintaining security and monitoring, etc. is done by Elastic Beanstalk. That is the beauty of Elastic Beanstalk. So let's go back and take a look at definition again and see if we'll understand it this time. Well, Elastic Beanstalk is a platform as a service where developers just have to upload their application. Load balancing, auto scaling, and application health monitoring are all handled automatically by Elastic Beanstalk. Now let's try to understand how Elastic Beanstalk as a platform as a service is beneficial to app developer. I'm sure most of you know what platform as a service is, but let's try to refresh what we know. Platform as a service is a cloud computing service which provides you a platform where you can deploy and host your application. Elastic Beanstalk makes the process of app development much more fun and less complex, and I have 5 points to prove that to you. Firstly, it offers quicker deployment. Suppose you're developing an app by yourself, then you'll have to do a lot of tasks by yourself. Like you might have to decide on EC2 instance, choose a suitable storage and infrastructure stock, as well as install auto-scaling groups as well, and then you might have to install separate softwares for monitoring and security purposes. Well, this will take quite a lot of time. But if you have used platform as a service to develop your app, then all you have to do is develop a proper code for your application. Rest will be handled by platform as a service or Elastic Beanstalk in this case, which makes the entire process of app development much more faster. Secondly, Elastic Beanstalk simplifies entire app development process. Like I said, all developers have to do is concentrate on developing a code for their application. Rest, like monitoring servers, storage, network, etc., and managing virtualization, operating system databases is done by Elastic Beanstalk, which simplifies the entire process for a developer. Using platform as a service to deploy application makes entire app development process more cost effective. If you're trying to deploy an app by yourself, then you might have to install separate softwares for monitoring and security purposes, and I'm sure for that you'll have to pay a lot of money, extra money. But if you're using an Elastic Beanstalk to deploy your application, it will provide you all this additional softwares as a package, and you can avoid paying unnecessary operating costs. Also, Elastic Beanstalk offers multi-tenant architecture. By that I mean it makes it easy for the users to share their application on different devices, and that too with high security. When I say high security, platform as a service will provide you a detailed report regarding your application usage, different people or users who are trying to access your application as well. With this information, you can be sure that your application is not under any cyber threat. And finally, platform as a service provides you an option where you can know if the user who is using your application is getting a better experience out of it or not. With platform as a service, you can collect feedback at different stages of your app development, like during development stage, like testing stage, production stage, design stage. By doing so, you'll have a report regarding how your application is performing at every level, and you can make improvements if needed. So this is how platform as a service like AR and Elastic Beanstalk makes it easy for developer to develop an all-around perfect app. Guys, you'll be able to relate to this point when we try to deploy an application using Elastic Beanstalk in the later part of this session. You'll understand how Elastic Beanstalk is beneficial to an app developer. In market, there are quite a lot of application hosting platforms which are providing platform as a service. Let's have a look at few of them. First, we have something called OpenShift. It is a web hosting platform offered by Red Hat. Then you have Google App Engine, which we all know. A Scalingo, it is a platform as a service where you can deploy your application in just 2 minutes. Apparently, it will provide you a production-ready environment where all you have to do is deploy your application code. Then you have Python Anywhere. It is an online integrated development platform and web hosting service as well, but based on Python language. Then you have Elastic Beanstalk offered by Amazon. Moving on, we have Azure App Services by Microsoft and many others. But today, our main focus will be on Elastic Beanstalk, which is a web hosting platform offered by Amazon. Now that you have basic understanding of Elastic Beanstalk, let's go ahead and take a look at few of its features. Mostly, all these features are similar to the ones which we discussed earlier. Like Elastic Beanstalk makes an app development process more faster and simpler for developer. Moreover, all developer has to do is concentrate on developing code. Rest of the configuration details and managing and monitoring details will be handled by Elastic Beanstalk. Also, Elastic Beanstalk automatically scales up your AWS resources which have been assigned to your application by Elastic Beanstalk based on your application's specific needs. But there is one feature which is specific to Elastic Beanstalk. Suppose you have deployed an application using Elastic Beanstalk, but now you want to make changes to the configurations which have been already assigned to your application by Elastic Beanstalk. Though Beanstalk is a platform as a service, it provides you with an option where you can change the pre-assigned configurations like you do in infrastructure as a service. Well, if you remember, if you're trying to use infrastructure as a service to deploy your application, you will have full control over AWS resources. Similarly, Beanstalk also provides you with full control over your AWS resources, and you can have access to the underlying resources at any time. Now, let's try to understand Elastic Beanstalk a little deeper. First, we'll be discussing a few components of Elastic Beanstalk, then we'll have a look at its architecture. Let's see what we have here first. We have something called application. Suppose you have decided to do a project. So what you do, you go ahead and create a separate folder on your personal computer which is dedicated to your project. Let's say your project needs Apache server, SQL database, and a platforming software like Eclipse. So you install all the softwares and store them in the folder which is dedicated to your project. So that will be easy for you to access whenever you need all the softwares. Similarly, when you try to deploy an application on Elastic Beanstalk, Beanstalk will create a separate folder which is dedicated to your application. And in AWS terms, this folder is what we call an application. If I have to define folder or application in technical terms, then it is a collection of different components like environments, your application versions, and environment configuration. Let's try to understand each of these components one by one. We have something called application version. Suppose you have written a code, stored it in a file, and deployed this code on Elastic Beanstalk, and your application has been successfully launched. But now you want to make certain changes to the code. So what you do? You go ahead, open the file, make changes to it, save it, and then again deploy it on Elastic Beanstalk. Elastic Beanstalk again successfully launches your application. So you have two versions of your application now. It's just a copy of your application code, but with different changes. And Elastic Beanstalk will provide you with an option where you can upload different versions of your application without even deleting the previous ones. Then we have something called environment. Environment is a place where you actually run your application. When you try to launch an Elastic Beanstalk environment, Beanstalk starts assigning various AWS resources like EC2 instances, auto-scaling groups, load balancer, security groups to your application. The point which you have to remember is, at a single point of time, environment can run only a single version of your application. But Elastic Beanstalk will provide you with an option where you can create multiple environments for your single application. Suppose I want a different environment for different stages of my app. Like I want an environment for development stage, one for production stage, and one for testing stage. I can go ahead and do that, create a different environment for different stages of my application. And suppose you have same version or different version of your application installed on all these environments, it's possible to run all these application versions at same time. I hope that was clear. Well, you'll understand them practically when we try to deploy an application in the later part of the session. Then we have something called environment tier. When you try to launch an Elastic Beanstalk environment, Elastic Beanstalk asks you to choose among two environment tiers, which are web server environment and then you have worker environment. If you want your application to handle HTTP requests, then you choose web server environment. And if you want your application to handle background tasks, that is where a worker environment comes into picture. I'll show which to choose, either web server or worker environment, and how to work with them when we'll try to deploy an application in the later part. And lastly, we have something called environment health. Based on how your application is running, Beanstalk reports the health of your web server environment, and it uses different colors to do so. First, gray indicates that your environment is currently being updated. Let's say you have installed one version and now you're trying to upload different version. Well, it's taking a lot of time. So that time it shows gray color. It means your environment is still under updating process. Then you have green, which means that your environment has passed the recent health check. Then you have yellow, which means that your environment has failed one or more checks. And red, failed 3 or more checks. Moving on, let's try to understand the architecture of Elastic Beanstalk. Like I said earlier, when you try to launch an Elastic Beanstalk environment, Beanstalk asks you to choose among two different environment tiers. Firstly, we have web server environment. Web server environment usually handles HTTP requests from clients, and it has different components. Firstly, we have something called environment. You know what environment is? It's a place where we actually run your application, and Beanstalk provides you with an option where you can create multiple environments. And the main point is, at a point of time, this particular environment can run only one version of your application. Moving on, we have something called Elastic Load Balancer. Let's say your application is receiving a lot of requests. So what Elastic Load Balancer does is, it distributes all this request among different EC2 instances so that all the requests are handled and no request is being denied. What actually happens is, when you launch an environment, a URL is created, and this URL in the form of CNAME is made to point Elastic Load Balancer. CNAME is nothing but an alternate name for your URL. So when your application receives request, all these requests are forwarded to Elastic Load Balancer, and this load balancer distributes these requests among EC2 instances of autoscaling group. Then we have autoscaling group. Well, if your web server is trying to handle a lot of traffic and it's having a scarcity of EC2 instances, then autoscaling group automatically installs few EC2 instances. Similarly, if traffic is very low, then it automatically terminates underused EC2 instances. Then we have EC2 instance. So whenever you try to launch an Elastic Beanstalk environment, Beanstalk will assign your application with a suitable EC2 instance. But the software stack, like the operating system, the servers, and different softwares which are supposed to be installed on your instance are decided by a device called container type. For example, let's say my environment has an Apache Tomcat container. So what it does, it installs Amazon Linux operating system, Apache web server, and Tomcat software on my EC2 instance. Similarly, depending on your application requirements, it installs different software stack on your EC2 instances. Then we have a software component called Host Manager, which runs on every EC2 instance that has been assigned to your application. This Host Manager is responsible for various tasks. Firstly, it will provide you a detailed report regarding performance of your application. Then it provides instant level events. It monitors your application log files as well, and it monitors your application server. You can view all these metrics, log files, and create various alarms on CloudWatch monitoring dashboard. Then you have security groups. Security group is like a firewall to your instance. Not anybody can access your instance. It's just for the security purposes. So Elastic Beanstalk has a default security group which allows client to access your application using port 80. You can define more security groups if you need. And then Elastic Beanstalk also provides you with an option where you can define a security group for your database for security purposes. Moving on, we have something called worker environment. First question that comes to our mind is, what is worker? Well, suppose your web server has received a request from client, but on the way, while it's trying to process the request, it has come across tasks which are consuming a lot of resources and taking a lot of time, because of which it's quite possible that your web server might deny other requests. So what it does, it forwards these requests to something called worker. This worker handles all these tasks on behalf of web server. So basically, worker is a process that handles background tasks which are time intensive and resource intensive. And in addition, if you want, you can use worker to send email notifications, to generate metric reports, and clean up databases when needed. Let's try to understand why we need worker with the help of use case. So I have a client. He has made a request to web server, and the web server has accepted the request, and it starts processing the request. But while it's processing the request, it comes across tasks which are taking a lot of time. Meanwhile, this client has requested or sent another request to web server. Since web server is still processing the first request, it denies second request. So what is the result of this is, the performance and the number of requests accepted by your web server will drastically decrease. Alternatively, let's say a client has made a request and your web server has accepted it and it starts processing the request. And again, it comes across tasks which are taking a lot of time. This time what it does, it transfers or it passes all these tasks to worker environment. And this worker environment will handle all these tasks. And request 1 is successfully completed. Meanwhile, if it receives a second request, since it has completed processing request 1, it will accept request 2. I hope the scenario was clear. Well, all we are doing by installing worker environment is we are avoiding spending a lot of time on single request here. Now you know what web server environment is and worker environment is, and why do we need worker environment. But there has to be some way so that this web server environment can pass on this task to worker environment. Let's see how. So you have your web server environment. It has received a request, and while processing, it has encountered tasks which are taking a lot of time. So what it does, it creates an SQS message. SQS is a simple queue service offered by Amazon. And this message is then put into SQS queue. And the different requests are arranged based on priority in the SQS queue. Meanwhile, when you're trying to install worker environment, Elastic Beanstalk installs something called daemon. What this daemon does, it pulls SQS message from SQS queue. And then it sends this task to web application which is running on worker environment. As a result or as a response, this Beanstalk application handles all this task and responds with an HTTP response option. So this is how the entire process of handling tasks, transferring and then handling tasks goes on. So you have a client. He has made a request to web server, but the web server is encountered with tasks which are time consuming and resource consuming. So it passes this request to SQS queue. And when you try to install worker environment, there's a daemon which pulls out all these messages or tasks from your SQS queue. And then this daemon sends all this tasks to your application. Application resolves all this tasks and then it responds with a HTTP response option. So this is how your two applications communicate. I think that was a lot of theory. Don't worry, we have arrived at the fun part of session where we'll be trying to deploy an application using Elastic Beanstalk. Here, by doing or by creating an application on Elastic Beanstalk practically, you'll understand different concepts, its architecture, and different environment ties and all this. So let's go ahead. So this is my AWS management console. And if you want to take a look at all the services, then you have all the services here. But we're mainly concerned with Elastic Beanstalk, which I've recently used. So it shows the all recently used resources or services here. So I'm going to choose that Elastic Beanstalk. And this is my Beanstalk console. If you're trying to deploy an application for first time, this is the page where you land. When we scroll down, it says that I can deploy an application in 3 easy steps. All you have to do is select a platform of my choice, then upload an application code if I have one, or use a sample application code, and then run it. Let's see if it's as easy as it says here. So go ahead and click on Create New Application option here. It'll ask you for application name and description. I'm going to name my application as Tomcat app. Then description as my new web app. And then I'm going to click on this create option. See, when I try to create an application, it has created a separate folder which is dedicated to my application. And in that folder, we have different components. As you can see here, I have my environment, then I have application versions. And if I've saved any configuration, it will show all the saved configurations here. Now let's go ahead and create an environment. On the right side, you see an actions option and you click on that, you get different choices. You can just select create environment here. So again, it's asking you to choose among two different web environment tiers. You have web server environment and worker environment. In web server environment, your application handles HTTP requests from clients. Then you have worker environment, where your application will process background tasks like time intensive and resource consuming tasks. In this demo, I'm going to work only with web server environment. You can go ahead, explore and create worker environment once you understand how to deploy an application on Elastic Beanstalk. So I'm going to click on the select option here. It will take me to a page where I'll have to give a domain name or in technical terms a URL to my application. You can give any URL of your choice and see if it's available. So let's say my Tom app and let's see if it's available. It says the domain name is available. Then description, I'm going to give it the same as before. So my new web app. Then when I scroll down, it asks me for a platform of my choice. There are different options. You have Go, then you have .NET, Java, Ruby, PHP, Node.js, Python, Tomcat. And if you're trying to deploy an application on the platform which is not here, you can configure your own platform and deploy it on Elastic Beanstalk. It provides you an option. Here you can see there's a custom platform here. So I'm going to choose Tomcat platform for my application. And since I'm not any kind of developer, I'm just going to go ahead and use the sample application provided by Amazon. But if you have any application code, if you have created or developed some code, you can store that in a file and upload here. It says you can upload your code. Then you have a zip. You need to convert your file to zip or WAR file and then upload it here. So I'm going to just select sample application and then click on create environment here. So it's going to take a while for Elastic Beanstalk to launch my environment. Though it's not as much time as it would have taken me to develop entire application by myself. While Elastic Beanstalk is trying to launch environment, let's discuss some points. In the earlier part of the session, we discussed some benefits of Elastic Beanstalk. Firstly, I said that it fastens your process of developing an entire app. So it's true, doesn't it? All I did was select the platform of my choice. Rest is done by Elastic Beanstalk itself. So thereby it's saving a lot of time. Similarly, it simplifies the process of app development. Again, all I did was select a platform of my choice, like installing EC2 instances, security groups, auto scaling groups, and assigning IP addresses. Rest is done by Elastic Beanstalk. I even mentioned a point where I said that it'll provide Elastic Beanstalk provides you with an option where you can change the pre-assigned configuration. We'll explore that once the environment is created. Let's go ahead and see what Elastic Beanstalk is doing. It says that it has created a storage for my environment where S3 bucket so that all my files where I have my application code are stored there. Then it has created a security group as well, an Elastic IP address. Then it says it's launching an EC2 instance. So you see, it's as easy as that. All you have to do is select a platform of your choice. Rest is handled by Elastic Beanstalk. And later on, if you're not satisfied, if you want to change some configuration, you can go ahead and do that. Here, look at this. This is the IP address or domain name which I assigned to my app. It says new instance has been added. And in addition, it's showing each task while it's doing. Isn't that cool? You'll know what your environment is currently doing. So it's still taking a while. So it says it has installed and added instance to my application and my environment has been successfully launched. It has finished almost all the tasks. It should have taken to environment page now. So this is my environment page, or you can say a dashboard. First, you have environment health here. It says green. It means that my environment has successfully passed the health check. Then it shows the sample version of your application. Since I've used the sample application, it's saying sample application here. Since I've chosen Tomcat as my platform, it has installed suitable infrastructure stack like Amazon Linux, and you have Java 8 programming language. Let's go ahead and explore this page. First, we have something called configurations here. Like I said, though it is a platform as a service, it provides you with an option where you can change configuration. So you will have full control of your resources. First, we have something called instances here. When I click on modify option, you can see that Elastic Beanstalk has assigned micro instance to my application. If I want, I can go ahead and change it to different instance based on my application requirement. Scrolling down, I have CloudWatch monitoring. If I want detailed monitoring, then I can go for 1 minute. If I want basic monitoring and not so detailed monitoring, then I can choose 5 minutes here. Then I have an option of assigning storage to my application as well. It says we have magnetic storage, general purpose, and provisioned IOPS as well. When we scroll down again, we see different security groups. I can just click on that and the security group will be added to my application. So once you've made the changes, you can click on apply option here. Though I haven't made any changes, I'm just going to click here. So now Elastic Beanstalk is trying to update my environment. So it's showing gray color here. If you recollect, I mentioned during the earlier part that gray indicates my environment is being updated. Okay, let's go back to configurations. We did have a look at instances. Then you have something called capacity. Apparently, Elastic Beanstalk is assigned a single instance to my application. If I want, I can go ahead and change to auto scaling groups. You have an option called load balancer. You can click on that here. And you can set the minimum and maximum number of instances that your auto scaling group can install as well. Then if you have chosen a load balancer option earlier, then a load balancer would have been enabled here. Then we have monitoring details, which provides you with two options, enhanced monitoring and basic monitoring. And when we scroll down, you can see a streaming to CloudWatch logs option here. So if you want your log files, you can view them on CloudWatch dashboard as well. You can set the retention period according to your choice. And suppose you want your application for some private purpose, then you can generate a private VPC for your application. Similarly, you can add or decrease the amount of storage as well. So by explaining all this, what I want to say is your hands are not tied. You can make changes to configurations if you want. Then we have logs option. If you want to have a look at the last 10 lines of your log files, then you have an option. It says last 100 lines. Then if you want full log files, then you click on that. It will provide you a file in download format. You can just download it. Then we have health option here, where it provides the health of your AWS resources. Basically, it shows EC2 instance here. It says it's been 7 minutes or 6 minutes since my EC2 instance has been installed. Then you have monitoring, where it shows different monitoring details like CPU utilization, network in, network out. If you want, you can go ahead and create an alarm with alarm option here. Suppose you want a notification to be sent to you when the CPU utilization or when the number of EC2 instances are scarce in your auto-scaling group. Then you have events here. Events basically are nothing but it's a list of things which has happened since you started launching an environment. When I go down, it says, we have seen earlier on the black screen, the same things are replied here. So it says create environment is starting. Then we saw that EC2 instance has been installed, security groups, elastic IP address. So basically it shows all the events that has happened from the time Elastic Beanstalk has started to launch your environment until the time you terminated the environment. So that's it. Then you have tag files. You can assign different key values as well. Let's go back. This is a sample application which I've tried to use. Now let me try to upload and deploy a new application version here. Okay, I'm gonna go to documentation here. I'm interested with Elastic Beanstalk. I'm gonna select on that and then developer guide. Click on getting started here. When you scroll down and deploy a new application version here, based on your sample application, you have different versions of your application. Since I've selected a Tomcat as my platform, I have a Tomcat zip file here. I have already downloaded that. So I'm just going to upload the file there. So let's go back and it says upload and deploy. But let's go back to our folder. Then there's an application versions option here. So it gives you deploy and upload option separately here. I'm just going to upload first, then we'll deploy it. Version label, new version, and upload the file. I have it here, zip file. I'm just going to attach the file and then click on upload option. The new version of my application has been uploaded, but it's not been deployed yet. So when I go back here, you can see that I can still see the same version which was there before. Now let's go back and deploy it. Okay, I'm going to select this and then I'm going to click on deploy option and select deploy here. Let's go back to environment and check. So my environment is being updated. So again, the gray color here. Once it's updated, it will show the new version name here. It is uploaded. So as you can see, it's showing the version name of my new version, application version. Like I said earlier, both my application versions are there. I haven't deleted any. You don't have to delete your application versions when you create a new one. Similarly, you can upload multiple versions of your application. Going back, actions option. Then you have load configuration, which will definitely load your configuration. Then you have save. You can save this configuration. Suppose you want to create an application with same configurations. Again, you don't have to start from the beginning, from creating application, environment, all that. You can just save the configuration and use for the other application or other environment of your application. Then you can clone your environment as well, rebuild the entire environment and terminate as well. So here I have saved configuration. If I have saved this configuration, the configuration would have been listed here, and like that configuration I can use when I'm creating a new environment. Okay, just let's see if I've explored all the options. Environment. Well, I forgot to show you one most important thing. When I click on this URL, it takes me to a page where it shows that my application has been successfully installed. Well, that's it. So now you know how to deploy an application using Elastic Beanstalk. Though I have used the sample application here, you can go ahead and upload a code of yours if you have any and try it out. Well, all the options here seems to be user friendly, so you will know what to do. It seems to be easier process. You will understand it better when you try to deploy an application by yourself.
So first and foremost, I would start by talking about what cloud storage exactly is. Then we'd move further and understand some of the myths that surround cloud storage. We'd also discuss certain cloud storage practices, and we'd understand how different cloud storage service providers work. Finally, I would finish things off with the demo part where I would be talking about how cloud storage services work on Amazon Web Services. So I hope this agenda is clear to you guys. So let's not waste any time and quickly get started then. So what exactly is cloud storage? Now, first and foremost, let me tell you what prompted me to actually go ahead and take this session. Well, recently I had been interviewing and where I asked people what did they know about cloud computing, and they told me that cloud computing is a place, or it is a place online where you actually store data. I mean, to some extent I agree. Yes, cloud computing helps you store data, but that is not the definition on the longer run. So that is why I thought that we should actually go ahead and have this session so that we can discuss some of the myths that surround cloud computing and cloud storage in particular. So guys, let's start with the basic definition first. Storage, well, it is something that is made available in the form of service which is connected over a network. So guys, this is a very basic definition, and to throw some more light, I would like to actually go ahead and give in certain examples as well to specify what does this definition mean. But to some point this definition is correct. It says that it is nothing but a storage which is available as a service which is connected over a network. Now again, you might wonder, as in this is what people told me in the interview, right? I mean, it is a place where you store data. So yes, cloud storage to some extent, yes, this is what it is. But when you talk about cloud storage, it is a lot more than this basic definition. Let's try to understand what all does cloud storage exactly has to offer to you people. Well, first and foremost, as I've already mentioned, it is storage. It can let you store emails, media. Now when I say media, you can store in different kind of media, whether it's your images, whether it's your videos, or maybe other kind of files. It also lets you hold services as well. Yes, we are living in the world of internet right now, and there are various services, websites that are online, and this data can be stored by using cloud platform. And finally, I'm sorry guys, finally it is nothing but the backup. Now when I say backup, guys, we're talking about large enterprises that let you back up the data, and they're using cloud platform to do that. But again, it still holds the same point, right? I mean, when I say emails, media, services, backup for large organizations, I mean, it is still a simple storage. No. Now let me tell you what it does. When I say backup for large organizations, we are referring to a lot of pointers here. Data coming in from different sources, the way it is processed, the way it is integrated and stored into a particular storage, how it is handled, and what all can you do with it. Now when you talk about a cloud storage, it actually takes care of all these things. That means it's not a redundant or a dead storage where you just take your data and put in your data. You can think of it as smart data storage. So to understand that, let's talk about cloud computing a little. So what cloud computing does is it lets you have this data on their platform, and it is a platform where it has n number of services that lets you compute or process this data to suit your business needs. Now it can be using machine learning, big data, finding out certain patterns using Power BI tools, or not Power BI tools, BI tools, and also do a lot of other things like maybe use a cloud platform where the data can be used for marketing purposes, maybe building IoT bots and stuff like that. So this is what a cloud computing platform does. It basically lets you use different sources and use this particular data to do multiple or different kinds of things. So when I say a cloud storage, it basically ensures there is a mechanism that in first place it stores data and lets you perform some of the actions that you can actually perform on this data. So as we move further, I would be discussing quite a few pointers that support this claim or this definition of mine. So let's just move further and try to understand a little more pointers or some other pointers that talk about cloud storage. But to keep it simple, it is a storage that lets you do a lot of things with your data. Primary reason being storing the data, and the other reasons being processing it or managing it also. So let's move further and take a look at the next pointer. So what are the myths that surround a cloud storage? Well, when you talk about the myths, this is what some people had to say, that cloud computing is suitable only for large scale organizations. No, this is not true. Let me give you an example. Recently what happened was, one of my friends, he actually happened to format his mobile phone, and he lost all the images and all the data that was there on that phone. So the problem was he never backed that data up on any drive, neither on Google Drive or anywhere. So he lost the data. So he came to us and he told us that this is what happened. So we told him that probably he should have backed it up maybe on Google Drive. So next time he did that, and again, he being used to losing his data, he lost his data again. So he again comes up and he's like, I've lost the data. So we reminded him that he had his data stored on the Google Drive. So when you talk about Google Drive, it is nothing but an online storage where you actually make a copy of your data. So he made a copy of his data and he could actually get that data back. So when I say cloud storage, it gives you
a simple application or a simple service where you can actually go ahead and just put in your data, just like Google Drive, where you can put in your data as well. So it is not limited to large scale organizations only. If even you are a single individual where you just need to store your data, you can use cloud storage. Now there are various cloud service providers that actually meet or cater different cloud computing needs. So based on that, the cloud storages might get complicated and might give you more functionality. But even if your need is as basic as storing data, don't worry, cloud computing or cloud storage is for you as well. Now if you talk about small scale businesses, yes, these days the amount of data that is generated is huge, and that is why what happens is, even for small scale organizations, you need a place where you can store your data and somebody can manage that data for you so you can focus on your business goals. So this is where cloud storage comes into picture for even small scale businesses as well. So if you ask me, yes, large scale organizations are suitable for cloud computing, or only large scale organizations are suitable for cloud storage. This is a myth. Complexity with cloud, guys. Now what does this term symbolize? People normally assume that having their private infrastructures makes it easier for them to actually go ahead and put in their data. That is not true. The fact that people are used to certain methods or methodologies, they feel comfortable with it. Whether cloud is complex or not, I would say it is not. Why? Because if you get used to certain services, you would realize that storing or moving your data to cloud is actually a lot more easier than your normal infrastructures, or your previous or traditional infrastructures is what I would say. So whether cloud is complex, I would say no. As we move into the demo part, probably we would be talking about this pointer, or once I give the demo, probably you would have a clearer picture how easy it is to actually move your data to cloud. Not eco-friendly. Now this might sound out of the blue. I mean, you might wonder, this is not a sociology session, so where did this point come in from? I mean, not eco-friendly. Yes, what people assume is the fact that the large amount of data is being stored on these platforms. So we have huge amounts or huge numbers of data centers which are big in size, and they consume a lot of electricity. So there is power wastage, electricity wastage. Well, that is a myth again. First and foremost, the fact that we are getting a centralized storage somewhere, that means most of the data would be stored there. So yes, you're automatically saving out on your power consumption when you talk about it from a global or an eco perspective. The other thing is, I would not want to point out a particular cloud service provider, but when you talk about GCP, that is Google Cloud Platform, they normally provide their cloud services at a very affordable price. Now, why is that? The reason for that is, they've actually put in a lot of effort into the research part, where they've researched a lot on how they can actually minimize the cost. And how did they do it? They basically ensured that the amount of power that is consumed by their resources, they've tried and optimized that amount to a minimum amount, so that they are charged less, and in a way you are charged less. So if they're optimizing that particular process, obviously you're consuming less amount of electricity. So whether it's eco-friendly, definitely it is eco-friendly. Zero downtime. Again, there's no such thing as zero downtime. Now the fact that I'm talking about cloud storage does not mean that I tell you that it has zero downtime and you're completely secure. No, there is a possibility that there might be a downtime. The fact that cloud ensures that this downtime is very less, now that is a plus point. What cloud also does is it ensures that there is a disaster recovery, and there is always a backup of your data or your resources. So even if something goes down for a very little time, I mean, normally it happens for a very less time if it does happen, and it happens very rarely, but even if it happens, care is taken that nothing harms your resources or your data. So zero downtime, no, that is not true, but definitely downtime is taken care of when you talk about cloud storages. There is no need of cloud storage. Okay, this is one of the biggest myths. Whether people agree or not, if you go back like 10 years from now, probably people did not know a lot about cloud computing, but with time, people are actually moving to cloud. And if you take a look at recent statistics, they would agree as well. I mean, people would be wanting to switch to cloud in near future, and the reason for that is, there are quite a few services, quite a few facilities that cloud gives you, and that is why people are moving to cloud. And if you do move to cloud, you'll be using cloud storage inevitably. So yes, that is going to happen. And if you think that there is no need for cloud storage, definitely in near future, I would assure you that even you would be moving to cloud. So guys, these are some of the major myths. There are some other myths as well. As we move further, do not worry, we would be discussing that as well in some other pointers. So let's just go ahead and talk about some of the benefits of using a cloud storage for data storage, or basically using cloud for data storage. So what are the benefits of this thing? Now I purposely kept this pointer for the later half, and I first discussed the myth because these pointers would definitely help you understand some of those myths better. Now your cloud platform is customer friendly. What do I mean by this? Well, first and foremost, when you talk about cloud storage, what you're able to do is you're able to scale up your storage, scale down your storage, keep it secure, monitor it, and you can ensure that there is constant backup taken of your data. So when you talk about it from a security perspective, it is secure as well. Plus, what cloud service providers do is they've had so many services that are there in the market. You talk about any popular cloud service provider, they have a lot of services that are made available. What do these services do is they ensure that your functioning on cloud platform is very smooth, and same is for cloud storage as well. You can utilize various services which ensure that your functioning or your working on cloud becomes easy. Again, which I've been reiterating for a while now, that I would be talking about these in future slides. Don't worry, as we get into the demo part, you would understand how user friendly these cloud platforms are. Security. Now again, this is an important point. When you talk about cloud platforms, cloud storages, are they secure or not? Definitely they are very secure, and there was a time when people believed that these platforms were not secure to a greater extent, and that doubt was understandable. I mean, if there is something that is new in the market, you tend to doubt that. But if you talk about cloud platforms, these platforms are actually more secure than your on-premise or your traditional architectures which people are used to using. The reason for this is, if you talk about cloud service providers, let's talk about AWS, that is Amazon Web Services in this case. What it does is it gives you a shared security model. Now what do I mean by this? You have service level agreements where you and your customer, or maybe the customer and the AWS providers, they basically come to a term where they decide as in what kind of security or what kind of principles are to be implemented on the architecture, and you can take control, as in you can decide what accesses do you want to give to the vendor and what are the accesses you want to keep to yourself. So when you do combine this approach, it ensures that security is at the optimum, and you get to be, or you get to take control of your security as well. So yes, if you talk about cloud storage being secure or not, yes, it is very secure. To name some, we have S3 in AWS. It is highly durable and it is highly reliable. So when you talk about disaster recovery and durability, it is almost up to there. And as I've already mentioned, not everything is 100% when I talked about the downtime, or yeah, the downtime part. So yes, not everything is 100%, but when you talk about security and durability, when you talk about S3 in particular, it is 99 point some 6 or 7 times 9, that is 99.9999999 times durable. So that does make your system very secure. Another benefit, guys, it is pocket friendly. Now if you talk about cloud service providers, whether it's storage, whether it's compute service, database services, all these services, you can actually go ahead and use these services for rental basis. It's just like paying for your electricity. I mean, if you're using a particular service, you'd be paying for that service for the duration you use that service, and you'd be paying only for the resources that you've used. So it is pay as you go kind of a model where you pay only for the resources you use and only for the time duration you use. So whether it's pocket friendly or not, yes, it is pocket friendly. And as you move further, I mean, if you're using more storage, the cost again, it cuts down to a greater extent. So it is already cheaper, and if you decide to scale up, it would be more cheaper, or it would be cheaper is what I should say. So yeah, these are some of the benefits. Now if you talk about cloud computing and storage, again there are other benefits like, as I've already mentioned, durability, scalability, and various other benefits, but these are some core ones. I would not want to get into the details because I wish to keep everyone on the same page for people who have been attending this session for the first time, and for people who probably know a bit about cloud computing. Again, guys, if some of the terms that I'm talking about in this session, you feel that these terms are fairly new for you and I'm probably going at a faster pace, I would suggest that you actually do go ahead and check into the other sessions that we have on our YouTube channel, because we've talked about a lot of stuff there. I mean, other cloud services, what cloud computing is, what cloud service providers are, what are different service models, and quite a few other videos and sessions, to be honest. So I would suggest that you go through those sessions as well. And I'm sure that by now many of you might have been wondering as in whether this session would be recorded and a copy of it would be available to you people or not. Not worry, most of our sessions they go on YouTube, so probably a copy of it would be there on YouTube, and if not, you can actually share your email IDs as well. If it does not go on YouTube, somebody would share a copy of the session with you people. So guys, if I'm happening to go a little faster than what you're expecting, do not worry, you'd be having a copy of this as well. But for now, just try to keep up with the pace that I am going with, and I'm sure that by the end of this session we all would be good. So guys, what are some of the cloud storage practices that you should take care of? Now, these are the practices that should concern somebody who is planning to move to cloud. Again, if you are a newbie and you're just here to practice, we are not talking about you in particular, but these pointers are important for you as an individual as well. But I'm talking about it from more business perspective or more industrial perspective. So if your organization is planning to move to cloud, definitely these are some of the practices or pointers that you should take care of. So first and foremost, scrutinize SLA. So as I've already mentioned, you have SLAs where your service providers or your vendors basically come to a term where you actually go ahead and decide on particular rules, as in, okay, these are the terms and these are the services as a vendor I would be providing you people, and you as a customer, you agree to certain terms, as in, okay, this is what you would be giving us and this is what we would be paying you. So there are certain pointers that you should consider while you're actually signing your SLAs. One thing that you need to understand is, when they say that you would be, this is the base charge, try to understand how the charges would be when you decide to scale up and stuff like that. Other thing that you need to consider is, I've talked about downtime, right? So normally you have SLAs where people talk about the stuff that there won't be an outage which is more than 10 minutes. So yes, I mean, this sounds fairly good, right? So in an hour's time, this is a hypothetical example. Do not consider that there would be a downtime of 10 minutes. This is for your understanding. Let's assume that there's a downtime of maybe 10 minutes in an hour's time, which is too high for now, but let's assume that. So what a service provider would claim is, if there is a downtime once, probably this is what the charge would be. But if it goes down after that, probably you get some more concession discount and those kind of things. So if there is an SLA where you say that it is 10 minutes, and what if there were two downtimes of 99 minutes in an hour? And that is fairly close, right? So you've been robbed of your right. So that is what I'm trying to say. I mean, if you do actually go ahead and have particular SLAs, make sure that you consider in right points that suit in your business as well. Follow your business needs. Again guys, storage, as we move further, we would be discussing what are the different kinds of storages. So when you talk about cloud service providers, they provide you n number of storages, or n types of storages is what I should say. So depending upon the business you're dealing with, the kind of data that is generated, you should be able to choose a proper storage for your requirements. I mean, whether you're dealing with real-time data, whether it's stationary data, archival data, based on that, you should be able to actually go ahead and set up your cloud storage. Also, you need to understand, as in, okay, this is the data I would be putting in, and these are the integrations I would be needing because I'm using these kind of tools. So are those compatible with my cloud platform? So probably you need to consider these pointers as well. And if you follow these rules, probably your business would end up saving a lot of money. Now, there have been use cases where businesses have actually gone ahead and saved lakhs of dollars, thousands of dollars. So yes, considering these pointers, understanding your business also becomes important. You need to ensure that the security which you are actually managing or monitoring is defined properly. I've already mentioned that if you talk about cloud service providers, they let you have an SLA where you both come to a similar agreement. So understand the security, what are the accesses that you have, what are the accesses you want to give, what kind of data are you dealing with, and based on that probably you can come to terms when you're actually moving to cloud. Plan your storage future. What we are trying to say here is plan the future of your storage. Again, do you need to scale up in near future? What are the peak times that you can expect and stuff like that? So when you initially actually set your storage up, probably you would be in a much better position to scale up. I'm not refraining from the fact that cloud providers are already scalable, but just to be secure, you can do that. When you talk about cloud providers, mostly they give you an option of scaling right away or instantly, but still having an understanding of how much storage you need, where you're gonna move in like 2 years, 3 years time, probably having an understanding of all those things would definitely hold you in a much better position. Be aware of hidden costs. Again guys, I've talked about the first SLA, right? So it is similar to that. Understand what you're paying for, how much are you paying for. It is a pay as you go model, but having an understanding of which services would cost you how much would help you in forming proper SLAs or having proper policies for your storage. So these are some of the do's and don'ts of cloud storage, guys. Again, if you need more insights on different services as well, we have a video or a session on YouTube which is called as AWS best practices. You can take a look at that as well, where we talk about different services and how can you actually perform certain tasks which would ensure that you are in the best possible position. So guys, we've talked about quite a few things. We've understood what cloud storage is. We've understood what are the benefits, what are some of the myths, and what are some of the practices that you should take care of. Now let's take a look at some of the different cloud service providers that provide you with these services. And once we are done with it, then probably we would move into the demo part. So guys, there are quite a few cloud service providers which also provide you with storage services. We have Google Cloud Platform, which is one of the leading ones. DigitalOcean, probably it's everywhere, whether you search for internet ads, companies, it's there. Terramark, again, this is a popular cloud service provider. IBM is there in storage or in cloud for a very long time, guys. Now if you go way back, I happened to attend a session where I believe it was AWS and some reInvent session where I did not remember the name of the speaker, but that person made a very valid point. He said that in 1980s he remembered or he happened to visit a facility. I believe it was IBM's. I'm not sure whose. I think it was IBM's. So he said that they had this huge machine which was for storage. I mean, it looked very cool in 1980s, a huge machine, and it was very costly. It was like somewhere around thousands of dollars, and the storage space was 4 MB. Yes, for 4 MB the cost was thousands of dollars. So you can understand how far storage has come, how far cloud has come. And yes, IBM, it has been there. I mean, it has been there since then. So if you talk about IBM, if you talk about Google Cloud Platform, these are principal cloud service providers. Then you have Microsoft Azure. Now if you talk about current market, I mean, if you go by the stats alone, Microsoft Azure and AWS, these are the leading cloud service providers. AWS is way ahead of all the other cloud service providers. I'm so sorry. But if you talk about Microsoft Azure, it is actually catching up with Amazon Web Services, and recent stats show that Microsoft Azure is doing fairly well. So yes, these are some of the popular cloud service providers, and more or less all of them have good storage services as well. But as I've already mentioned, Amazon Web Services is one of the best in the market, and in today's session we would be understanding some of the popular cloud services that Amazon Web Services has to offer to you. And when I say popular services, I would be focusing on storage services specifically. So guys, let me switch into the console and we can discuss some of these services there and directly move into the demo part. So yes guys, I hope this screen is visible to you people. this is how the AWS management console looks like. So again, for people who are completely new to cloud platform, let me tell you that what Amazon Web Services or most of the other cloud service providers do is they give you a free tier account. What they're trying to say here is you use our services for free for a short duration of period, and if you like, then go ahead and buy our services. So these services are actually made available to you for free for one complete year. Yes, there are certain limits or bounds on these services, so if you exceed those limits you would be charged, but if you stay in the bounds or limits you won't be charged. And if you talk about exploring these services, these limits or free tier services are more than enough. So again guys, if you are completely new, you should come here, that is Amazon Web Services Management Console, create a free tier account. It is a very simple process. Put in certain details, where you work, why do you want to use these services, your basic details, and then probably you would have to enter your debit card or credit card details. Don't worry, they won't charge you, but this is for the verification purpose. And again, if you're worried about whether you would be charged or an amount would be minus from your credit amount, that or your credit card, that does not happen guys. AWS gives you notifications saying that okay, you've been using these services and probably you might be overusing some of your services. Also, you can set in alarms where if you reach a particular limit, after that you can actually go ahead and ensure that there is an alarm so that you do not exceed the free tier limit. So yes, once you do have an account, you can avail all these services that are here guys. So let's just go ahead and take a look at the console a little and just jump into the storage services right away. So when you click on this icon here, storage guys, or services rather, you get access to all these services. As I've already mentioned, AWS provides you quite a few services. There's somewhere around 100 services guys, and they cover different domains. You can see the domain names at the top: compute, robotics, analytics, business applications, storage, you have management and governance, security, identity management, and all those services guys. So there are n number of services, whether it's migration, whether it's media services, you have services for almost everything. So guys, we would be focusing on the storage services. Before we go there, this is one thing. Probably you can select a region where you want to operate from. That is, you want to create your resources in this particular region. You can always have this option of using it. So what is a region guys? Your data is based in a data center, right? I mean, your data is copied somewhere. So if you are using those resources, probably your data would be fetched from that particular location. So you can choose a region probably which is close to you if you like, or if your business is located somewhere else, probably you can choose that region as well. So you need to go through the list of regions that are available and accordingly make a decision. Now this being a simple demo guys, I would be sticking to Ohio basically. So let's just go ahead and jump into the cloud services part, and let's talk about storage in particular. So guys, if you take a look at the storage services that are here, you can see that these are the storage services that AWS has to offer to you. We have S3, we have EFS, you have FSX, you have S3 Glacier, Storage Gateway, and AWS Backup. Let me just try and throw some light on some of these services, and probably we would just go ahead and get into the demo of one or two of these services at least. So guys, when you talk about S3, it is simple storage service. So that is SSS. Now this storage is basically object bucket kind of a storage. I mean, your container where you put in your data, where you store your data, is called as bucket, and your data or your files are basically stored in the form of objects. Let's just go ahead and quickly create a small bucket. This would be a very small introduction to this service. Let's just go ahead and do that. So when you click on this icon guys, that is S3, it redirects you to the S3 console guys, where you can actually go ahead and create a bucket. I've mentioned the pointer that there are certain services that make your job very easy with cloud service providers, and when you talk about storage services, it is no different. I mean, there are services which ensure that your job is fairly easy. So let's just go ahead and see how easy it is to work with S3. If you wish to create a bucket guys, if you wish to create a container, it is very easy. Just go ahead and click on create bucket and give it some name, say sample for today maybe. Guys, I'm very bad at naming conventions, but please forgive me for that. Again, the names here should be unique. I mean, if the name is taken somewhere else, probably you cannot rename. I mean, you cannot use that name again. So yes, ensure that your name is unique, and probably guys, you should try and name your buckets in such a way that those are more relatable. Say for example, if you have a bucket for maybe creating a particular application, so maybe bucket for that application or something like that, so that you have a hierarchy, and in that way you can assign IAM users or access to those buckets in a particular order, because you would not want all your users to have access to that bucket, right? So naming convention becomes very important. So just go ahead and say next. Keep all the versions, guys. Versioning becomes very important. Again, let's not get into the details, but let me give you a small idea what happens here. Versions, that means each time my buckets get updated, probably I would want a version or a copy of it, and I would want the latest one. So when I version it, it maintains those copies, and if I need to go back, I can actually go back to a particular level or a benchmark which I set the previous time. In this case, let's stick to basic one, and I do not want any logging details either, so just next. Again guys, there are certain public accesses which have been given, so permissions and access, we would talk about that, do not worry. For now, just say next, and I would say create a bucket. And guys, the bucket is already ready. I mean, my container is already ready, so I can just go ahead and probably open this bucket and put in a file if I want, and that too is very easy guys. I say upload, and if I'm connected to my local system, I just say add files. Let's pick this random file which uses this name, and I say upload. And there you go guys, the file is already there. I mean, we've created a bucket, a container, we've put in our files. It's as simple as that. Permissions, as I've already mentioned. Now let me talk about this point. I skipped this point, right? So let's discuss this a little. So guys, security is something that you can handle, so you would decide, or you need to decide, what are the users that need to access a particular bucket. Suppose your organization has different people working on different teams. I mean, you have somebody who is a developer, there's somebody who's working on maybe the administrative part, or maybe on the designing part. So for particular bucket, you have particular data, so you can decide who gets to access what. So setting in policies becomes important. You can create your own policies as well. Initially we saw that certain public accesses were restricted to this bucket. I said let's skip that for now. So when I say that public access is restricted, that means not any public policy can come in and dictate terms here saying that use this policy. Why? Because there is a restriction. This is a private bucket and not anyone can use it. So guys, when you talk about S3 in particular, you can create buckets, you can have backups, you can have your EBS backups also moved here. You can move your data from here to Glacier. We would be talking about Glacier, do not worry. You can have your Elastic Beanstalk applications, your PaaS applications, and the data can be stored in your S3 buckets. You can have your CI/CD pipelines, and the data can be moved again to the S3 bucket. Now this is highly durable and highly reliable source of storing data, and it gives you fast retrieval of data as well. Let's go ahead and try to understand some other services as well, guys. So when I come back here and I see EFS, Elastic File Storage, or system rather. So here basically in this storage you can store files. Yes, we are talking about data that is in the form of files, and if you wish to connect it better with the network, you can go for EFS as well. Guys, then you have something called as S3 Glacier. Yes, we talked about S3, right, where data is durable and it can be accessed very quickly. S3 on the other hand lets you store archival data. Let me tell you what archival data is first. So guys, when you talk about archival data, basically what happens with archival data is you're dealing with a data that you do not need to use every day. Let me give you an analogy. I'm not sure whether you would be able to relate to that. So guys, your birth certificate. Now I belong to India, and we've been taking up a lot, but we still have a lot of data that is in the form of papers. Even if you go to hospitals, at times you request for a birth certificate, it might take days for you to get that birth certificate. Why? Because there is some person who will be going through all those documents and giving you that document. This is just an example, do not relate it like very seriously, but yeah, so it might take a couple of days, right? So, and the birth certificate thing, I mean, I might not need birth certificate every day. It might be once in a decade that I might go to a hospital and probably request that particular birth certificate, right? So this is a kind of data probably which I do not need regularly or in real time. So I can compromise a little on the fact that if the person is giving me that data in 2 days time, it's okay, because that does not cost me anything. I can wait for 2 days maybe. But that's not the case. At times you need the data to be retrieved very quickly. So if that is the case, you should store it where? In S3. But if you're fine with this delay, probably you would want to store it in Glacier. Why? Glacier normally takes a longer while to retrieve your data. But the advantage of Glacier is it is profitable because it is very affordable compared to S3. S3 is already affordable, you can check in for the prices, but if you have archival data which you won't be using every day, you can store it here. And the fact that it takes a longer while, it won't cost you, it won't cost you in that perspective of accessing your data in real time, right? So if the data is something that is not needed regularly, you can move to S3 Glacier, right? So what happens is S3, you can actually move in all your data, and then if you realize that there is certain data which you do not need every day, just move it from S3 to S3 Glacier, where the data is stored in archival form, and it does not cost you a lot. So again guys, I won't be getting into the demo of S3 Glacier. We have a session on S3 Glacier, or Amazon Web Services Glacier rather, and to do that what you need is you need probably a third-party tool which makes it easier for you to retrieve the data. So I won't be getting into the stuff where I download that tool and show you how it works. It's very simple. Just like we created buckets here, you create vaults there, and you probably move in your data and you can retrieve that data. But again, it takes a longer while to retrieve that data. So it is similar to S3 but little different. So yeah, that is S3 Glacier. We've understood what EFS is and what S3 is. Then again guys, you have some other services as well here. If I scroll down, you have your storage gateway, you have your AWS backup as well. So what are these things and what do these things do? Well, storage gateway and AWS backup, basically backup, as it says, you can have backup of your data and you can like save it from going down and stuff like that. When you talk about storage gateway, these are services that let you move your data from on-premise atmosphere or your infrastructure rather to cloud. So if you already have data that is on your existing on-premise or infrastructure rather, you can actually move that data to cloud as well. So there are services to help you do that, and those services are your storage gateway services. So guys, we've discussed some of these services. There is something else which is called as elastic block storage. Now elastic block storage, what it does is it lets you create volumes, snapshots and copies of the volume that is attached to your instances. Let's go ahead and take a look at how this works. I mean, there are a lot of pointers to talk about it. So as I move further, I would be discussing those pointers while I also show you how to do it. So guys, when I say EBS or elastic block storage, what it does is it lets me attach some kind of volume to my instance. Now instances, let me tell you what instances are first. Now when you talk about cloud services, they give you compute services where you can spawn instances or spawn temporary servers or servers where you want to host your data. Now each time I won't be going ahead and buying a new machine, right? Instead, what cloud does is it, and what happens? Yes guys, okay guys, I'm not sure whether there was a lag while you were going through this session. What happened is, let me tell you what happened. My connection, the streaming connection to my software which I'm using to stream this session did go down a minute back, and it shows now that it is connected. So I would like to know whether I'm audible to you people or not. If yes, then we can continue with this session guys. Okay, I'm guessing we are fine, so I'm just gonna go ahead and continue with the session. I was talking about instances, let me talk a little more about it. So when I talk about these servers that are ready to use, basically these servers are something that you can use and you can have some memory attached to it. So what we're gonna do is we're gonna go ahead and launch one instance and understand how memory or how storage works with it. So to do that, we're gonna go ahead and just launch that particular service. It is called as EC2, which is a compute service guys. So here I can actually go ahead and create servers or launch instances in simple words. So let's just go ahead and launch a particular instance. Now I have the freedom of launching both Linux based, Windows based, Ubuntu based kind of instances. So you have the freedom of choosing what kind of instance do you want. This being a simple demo, guys, I'm gonna stick with the Windows instance. I'm not gonna show you how to deal with that instance because I've done that in previous sessions. You can take a look at some of those sessions as well, guys. Let's just go ahead and launch this particular session, or this particular instance rather. Now guys, this is a Windows instance, and okay, not this, let me launch some basic one. This is also free tier, guys, but yeah, I would want this. Make sure that your instance is EBS backed. So guys, your backing up works in two ways. You can back it up on S3, you can back it up on EBS, that is elastic block storage. Now elastic block storage is important. Why? It lets you create images and volumes. What are those? We'll talk about that once we create this instance. So ensure that for now it is EBS. So if I click on, okay, this is the thing. If I click on this icon, it would give me details what kind of instance I'm launching. When I say T2 micro, it is a small instance which has one CPU and 1 gigabytes of memory for now. And I can just go ahead and say next. Okay. Some of the other details, whether you want a VPC or not, let's not discuss that. And then you get into the storage part, guys. This is the device to which I'm attaching my root volume. So this is the path rather. So I need to focus on this. It is SDA1, guys. That is /dev/SDA1. You need to remember this when you create new volumes. And the types of volumes that you can attach to your instance are these. You have general purpose SSD, provisioned IOPS, and magnetic. Magnetic is something that is getting outdated, probably might be replaced. So these are the few ones. You also have some other kind of volumes that you can attach, but the point that you need to remember is when you talk about having a primary volume, in that case you have only these options because these are bootable, guys. So there are certain other volumes that you can attach. If I attach a secondary volume, you see the options are more. I have HSD for throughput optimization, and then I have cold HSD as well. But this is a basic thing. We're not gonna get into the details of that. We would skip that. So guys, all I'm trying to say is this is the device, this is the size, and probably this is the type of instance or volume, sorry, is that would be attached to my instance. So let's just go ahead and say next, add tags. For now, let's not add anything. And then let me say configure the settings. So guys, when I launch an instance, it says that security is not optimum, but it's okay. I mean, you can assign the ports you want to when you use it for a higher security purpose. And then this is important, guys. For your each instance, you need a key pair, which is a secret way of logging in, or a secure way of logging in, not secret, a secure way. So this is a second place authentication. Once you're logged into your account, you would be needing a key pair if you wish to use this instance. So make sure you create one and you store that one as well. If you have one which you can use, probably you can do that. Else you can just create one. Say new key. I say download. Guys, once you download it, keep it safe somewhere. It is stored in the form of .pem file. So do that. And then I say launch an instance. So guys, once this happens, if I just go back to the EC2 dashboard, probably I can see that there is an instance which is running. For now it is 0. Why? Because guys, my instance is still getting launched. It takes a couple of minutes or 1.5 or 1 minute probably to launch an instance. The reason for this is probably a lot of things happen in the background. I mean, certain network is associated. If you talk about an instance, it needs to communicate with other instances, right? So in that case, probably you need to have a network that lets all these instances connect. So a network is set here basically, and probably all the storage volume is attached, and a lot of things happen. That is why there are certain status checks that your instance needs to go through, and hence it takes a minute or so to launch this instance. So if you take a look at this, the status checks, it says that it is initializing. So if you refresh it, probably it happens at times. So let's just try our luck, see whether it's, no, it's still initializing, but guys, we can see the volume that would be attached to it. So let me just come here and rather go here. If I click on volumes, guys, there is a volume that is attached to it. So there is a 30 GB volume. So there is a volume that probably has a size of 30 GB. So it is here already and it is in use, so it would be attached to my instance once it is up and running. So the point I'm trying to make here is what elastic block storage does is it lets you manage all these things. Now there are two ways to manage these things. Either you create a copy of this volume, disable this volume, and then attach the next one, or probably you can directly scale your existing volume or make changes to it right away. So what elastic block storage does is it lets you manage the storages. So again, let me tell you how it works. So when I create an instance, probably it is created in a particular region, right? So in that particular region, say for example, now I'm based in India, so I have a data center in Mumbai. So my instance would be created at that data center, and probably the storage for it would also be there. So there is no latency when I try to use that storage. So this is what EBS does. It lets you manage that particular storage. So how it works is I can create a copy of it. So what this copy does is it serves two purposes. So next time, if I wish to make changes to that storage, I can do that. If this particular storage or volume goes down, I have a backup copy. Again, I can create snapshots as well. Now what snapshots do is basically they let me replicate my instance and the volume that is attached with it. So instead of creating an instance again and again with, if I've defined certain properties for my instance, I do not have to worry about defining those properties again and again. I can just create a snapshot, or I can rather create an EMI out of it, which I can store and use it next time if I want to spawn a similar instance. So this is where EBS helps in. It lets you have backups of all these storages. It lets you create copies of it, so even if something goes down, you can work on the copy that you have. So guys, by now our instance would be created. Let's just go ahead and take a look at it. It says it is running, guys, and we've already taken a look at the volume. Let's just create a copy of this volume. To do that, I'm going to go to the actions. My instance is selected already. I can just go to modify and make changes to this volume right away, which is an easier way, but I'm going to show you how it can be done the other way as well, how it used to work previously. So I can just say that create a snapshot, details, sample, and I say create. So guys, a snapshot is created. If I come here, I can take a look at the snapshot. Again, it is pending. Might take half a minute for the snapshot to get created. So I can just come here and replace or refresh rather. These things at times take a little while. So guys, we would be creating a copy of it. Probably we would be detaching the volume that we've created and it is attached to our instance, and we would replace that with the copy that we are creating now. So once this thing is done and created, we can do that. For some reason it's taking a longer while today. Let's hope that it gets done quicker. Okay, it's still processing. Let's bear with me, or just bear with me meanwhile this happens. Again guys, if I was too fast and if I missed out on certain things, I would like to tell you that you can go through our other sessions on YouTube and probably you'd be in a much better state to understand what has happened here. Again, there was an outage where, not outage, my software did not work properly, the streaming software, and probably there was a lag of a minute or two. So I'm hoping that you all did not miss out on anything that was happening. Meanwhile, just hope that this snapshot gets created quickly. It is still pending and this is irritating at times when it takes a longer while. It's completed guys. Our snapshot is ready. I can just go ahead and say create a volume out of it which I wish to attach. So guys, there are certain details that we need to do. So for that, let's just go back first. Let's go back to the instance that we have. And let's see where the instance is created guys. So as you can see, if you come here, it would give you the details of the place where the instance is created. So it is US East 2C. So when you create a volume, a volume, it is necessary that you create it in the same region, guys, because as I've already mentioned, the benefits of having it in same region is that you can attach it to your existing instance and it saves you from various latencies. So yep, let's go back to the snapshots part and say create a volume of it. I say create, and then I probably, let's say I want more storage, guys, let's say 90. Okay, this is general purpose, it is two-way, so let's go to 2C. If I'm not wrong, it was 2C. Let's just go ahead and create it in 2C and say create volume, close. So guys, our instance is, or our volume is created successfully. Again guys, now you can take a look at it from this perspective. I have my snapshot here, right? So this snapshot says 30 GB. That does not mean that the snapshot which I took, its size is 30 GB. It says that it was created from an instance whose size is 30 GB. So there's a difference between these two things, guys. Understand that as well. So I have a volume which is based in availability zone 2C. I have an instance which is here, and it again is an availability zone 2C. So we can attach to it. Let's just again go back to the volumes part. So guys, I have two volumes. I created this one and this is attached to my instance. Let me just try and remove this first. Detach volume. Okay, it's giving me an error. Try to understand why this error is there. Guys, my instance is already running, so I cannot directly remove this volume from here. For that I would have to select this instance, go to instance state and say stop. So it stops working for now, and once it does, I can attach the volume. So for now what you can see is there are these volumes here. It is in use, right? So once the instance stops, it would be available and won't be in use. So I can replace it with this instance. So it is stopping. It hasn't stopped yet. So guys, do not worry, we would be done with the session very soon, and once we are done, probably you all would be free to leave. I believe that this session has taken longer than my normal sessions, but yeah, there was a lot of stuff to talk about. We talked about the complete storage services that AWS has to offer to you people, hence this session was so long. So let's just quickly go ahead and finish the stuff. Okay, it has stopped. So guys, I can now go ahead and remove the volume or detach this volume and go ahead and attach the other one. So if I say detach, it would detach. Yeah, see, both are available now. Let's try to attach this volume and say attach volume, search. This is the instance, guys, which we've created, and you need to give in the device details, which was slash what were the details. Let's just go back and take a look at the details that we're supposed to enter in here. So guys, you need to give in the path that we talked about, which is the drive that we've discussed, right? So that is the path that you need to enter, and then you actually go ahead and say sda1 slash, and probably you'd be more than good to go. So this is the other thing, I do not remember the other part. So you need to go ahead and put in these details here. If you put in these part details, guys, you can just go ahead and attach your volume right away, and this volume would get attached to your instance. So this is how it works, and you can actually go back and do other things as well. So if I just come here, I have this instance. So what you have to do is you have to actually go ahead and click on this thing. For now it's not working, but if you just come back here or to the volume part, so if you just go to the volumes part, which we were at in the previous slide, you can actually go ahead and attach the volumes. Now here you go. If I just go to instances, probably go back and I say EC2 again. Yeah, if I come back to volumes, guys, you can attach the volumes that are there, you can delete those, and you can do a number of changes that you wish to do. So just go ahead and attach these volumes and you'd be more than good to actually go ahead and launch your instances or manage the storages that are there. Again, the only thing that I missed out on is the path. I told you to note the path, the device name, right? You just have to go ahead and enter in the device name here, and if you enter in the device name while creating your volume or attaching your volume, your instance would get attached to that, or your volume would get attached to that instance right away. So yes guys, this pretty much sums up today's session. We've talked about quite a few things here, guys. We've talked about S3 services, we've talked about EBS in particular. We've understood like how to detach a volume, how to attach one. I just did not show you how to attach the volume, but you can do that. The reason I'm not showing you that is I probably lost out on the device name here, which normally comes in here. So before you deactivate your device, make sure that you have this name, and when you do launch or attach your volume to that particular thing, all you have to do is you just go to the volumes part, and probably when you say attach to a particular instance, put in that device name there, and your instance would be attached, or your volume would be attached to your instance, and you can just go ahead and say launch or just start this so-called instance again, and you'd be good to go, guys. So as far as this particular session goes, guys, these are the pointers I wanted to talk about. I hope that I've talked about most of these pointers and I've cleared all your myths or doubts that were there.
So guys, when you talk about S3, now it is a simple storage service which is simple or easier to use in real sense. It lets you store and retrieve data which can be in any amount, which can be of any type, and you can move it from anywhere using the web or internet. So it is called as storage service of the internet. What are the features of this particular service? It is highly durable, guys. Now, why do I call it durable? It provides you durability of 99.999999, some 11.9. Now, when you talk about that amount of durability, it is understandable how durable this service is. What makes it this durable? It uses a method of checksum where it constantly uses checksums to analyze whether your data was corrupted at a particular point. And if yes, that is rectified right away. And that is why this service is so durable. Then it is highly flexible as well. As I've already mentioned, S3 is a very simple service, and the fact that you can store any kind of data, you can store it in any region or any available region is what I would mean by the sentence. It makes it highly flexible to store the data in this particular service, and the fact that you can use so many APIs, you can kind of secure this data in so many ways, and it is so affordable. It meets different kinds of needs, thus making it so flexible. Available. Is it available? Yes, definitely it is very much available. As we move into the demo part, I would be showing you which regions basically let you create these kind of storages and how can you move and store data in different regions as well. So if you talk about availability, yes, it is available in different regions, and the fact that it is so affordable, making it available becomes all the more easy. Cost efficient, yes. Now to start with, we normally do not get anything for free in life, but if you talk about S3 storage, AWS has a free tier which lets you use AWS services for free for 1 complete year. But this happens in certain limits. Now, when you talk about S3, you can store 5 GB of data for free, at least to get started or get used to the service. I believe that is more than enough. And what it also does is it lets you have somewhere around 20,000 get requests and somewhere around 2,000 put requests as well. So these are something that let you store and retrieve data. Apart from that, you can move in 15 GB of data every month outside of your S3 service as well. So if you're getting this much for free, it is definitely very much affordable. Also, it charges you on pay-as-you-go model. Now, what do I mean by this? Well, when I say pay-as-you-go model, what we do here is we pay only for the time duration that we use this service for, and only for the capacity that we use this service for.
So that is why as you move along, if you need more services, you would be charged more. If you do not need more amount of the service, you won't be charged to that greater extent. So is it cost efficient? Definitely it is. Scalable? Yes. That is the best thing about AWS services. Most of them are scalable. I mean, you can store huge amount of data, you can process huge amount of data, you can acquire huge amount of data. If it is scalability that is your concern, you do not have to worry about it here, because even this service readily scales to the increasing data that you need to store. And the fact that it is pay as you go model, you do not have to worry about the cost factor as well. Is it secure? Definitely it is. Now you can encrypt your data. You have various bucket policies as well that let you decide who gets to access your data, who gets to write data, who gets to read data. And when I said you can encrypt your data, you can actually go ahead and encrypt your data both on client side and on your server side as well. So is it secure? I believe that answers the question on its own. So guys, these were some of the features of Amazon S3. So guys, now let us try to understand how does S3 storage actually work. Now it works with the concept of objects and buckets. Now bucket, you can think of it as a container, whereas an object is a file that you store in your container. These can be thought of as AWS S3 resources. Now when I say an object, basically object is your data file. I've already mentioned that you can store any kind of data, whether it's your image, whether it's your files, docs, whatever it is. These are nothing but your data, and this data comes with metadata. When I say an object, it is combination of your data plus some metadata or information about that data. What kind of information? Basically, you have the key, that is the name of the file that you use, and version ID is something that tells you which version are you using. As we discuss versioning, probably I would talk about version ID a little more. But meanwhile, I believe this is more than enough. Your objects are nothing but your files with the required metadata. And the buckets, as I've already mentioned, these are nothing but containers that hold your data. So how does it work, guys? Well, what happens is basically you go ahead and create buckets in regions and you store your data in those regions. How do you decide what buckets to use, what regions to use, where to create the bucket and all those things? Well, it depends on quite a few factors. When I say I have to create a bucket, I need to decide what region would be more accessible to my customers or to my users, and how much cost does that region charge me, because depending upon the region your cost might vary. So that is one factor that you need to consider. And latency as well. I mean, if you put your data in an S3 bucket that is far away from you, fetching it might cause high amount of latency as well. So once you consider these factors, you can create a bucket and you just store your objects. When I said version ID key, actually your system automatically generates these features for you. So for you, it is very simple. Create a bucket, pick up your object, put it in it, or just go ahead and retrieve the data from the bucket whenever you want to. So I believe this gives you some picture about what S3 is. Now let me quickly switch into the demo part and let me give you a quick idea or quick demo as to how S3 works, so that it is not too much theory for you people. So guys, what I've done is I've actually gone ahead and I've switched into my Amazon Management Console. Now, as I've already mentioned, AWS gives you a free tier for which you can use AWS services for free for 1 complete year. Mine is not a free tier account, but yeah, if you are a starter, you can create a fresh account. You just have to go ahead and give in certain details. All you do is you just go to your web browser, search for AWS free tier and sign in with the required details. They would ask you for your credit card or your debit card details. Enter any one of those for the verification purpose. And you can actually go ahead and set up alarms as well, which would tell you as in, okay, this is the limit to which you have used the services. And that way you won't be charged for access of data usage or service usage. Having said that, guys, this is about creating an account. I believe it is fairly simple. You can create an account. Once you create an account, guys, this is the console that would be available to you. What you have to do is you have to go ahead and search for Amazon S3. If you search S3 here, it would kind of redirect you to that service page. So guys, as you can see, this is the company's account probably. Somebody uses it in the company and they have their buckets that are already created. Let's not get there. Let us just go ahead and create our own bucket and just go ahead and put in some data into it. It is fairly simple, guys. I've already mentioned it is very simple to use kind of service. All I have to do is click on create bucket and enter in name for some bucket. Guys, now this name is unique. It is globally unique. Once you enter a name for the bucket, you cannot use the same name for some other bucket. So make sure you put in valid name. And the fact that I use the term global, something reminded me to be explained of. So guys, as you can see, if I go back here, I want you to notice this part. So guys, when you are into the management console or you open any service, by default, the region is North Virginia. Okay, so if I create a resource, it would go to this region. But when I select the service that is S3, you can see that this region automatically goes to global. That means it is a global service. It does not mean that you cannot create bucket in particular regions. You can do that, but this service is global is what they're trying to say. So let us just go ahead and create the bucket. Let us call it today's demo. You cannot use caps, guys. You cannot use some symbols. So you have to follow the naming convention as well. Today's demo. Sorry, I'm very bad at naming conventions, guys. I hope it is okay. Let it be in US East. You can choose other regions as well, guys, but for now, let it be whatever it is. So I'm gonna stick to North Virginia. There are 76 buckets that are being used. Let us just say next. Bucket name already exists. So this was already taken, guys. See, so you cannot use it. Let's call it, say, Ramos bucket 13113. Okay, do you want to keep all the versions of the object? We will talk about what versions are. Okay, guys. Meanwhile, you just bear with me. I'm just going to go ahead and create a bucket. Create a bucket. And there you go, guys. I'm sure Ramos bucket should be here somewhere. Here it is. If I open it, I can just go ahead and create folders inside it, or I can directly upload data. So I say upload, select a file. Let's just randomly select this file. It is Van Rossum, founder of Python, basically. Let's just say next, next, next. And the data is uploaded, guys. You can see the data being uploaded, and my file is here for usage. So guys, this is how object and bucket kind of stuff works. You can see that this is the data that I have. If I click on it, I would get all the information. What is the key? What is the version value? For now, let's not discuss version, but this is the key or the name of the file that I've uploaded. So it is fairly clear, right, guys? So let us just quickly switch back to the presentation and discuss some other stuff as well. Now guys, another important topic that is to be discussed here is S3 storage classes. Now we've discussed how the data is stored or how buckets and objects work. But apart from that, we need to discuss some other pointers as well. As in, how does AWS charge me, or what kind of options do I have when it comes to storing this data? So it provides you with three options, guys: standard, infrequent, and glacier. Let me quickly give you an explanation to what do these storage classes mean and what all they offer to us. When I say standard, it is the standard storage which gives you low latency. So in case if there is some data that needs to be fetched right away, you can actually go ahead and use standard storage. Say for example, I wish to go to a hospital for certain kind of checkup. So in that case, my details would be entered in. And the fact that I'm getting myself checked in a hospital or diagnosed in the hospital, what happens is this data is important, and if it is needed right away, it should be available. So this kind of data can be stored in your standard storage where the latency is very less. The next we have infrequent access. Now what do I mean by that? Now in this case, my latency period has to be low because I'm talking about data that I would actually need anytime if I want to. But when I store this data for a little longer duration, all I want is this data to be retrieved quickly. Say for example, I get a particular report or a particular test done. So in that case, I would actually go ahead and submit my details, or say for example, my blood samples, but I need this information maybe after 3 days. So what happens is, in this scenario, I would want to store this data for a longer term, but the retrieval should be faster here. In the first case, that was not the case. If I needed that data right away, and if I wanted it to be stored for a very short duration, I would use standard. But if I want to store it for a longer duration and I want a quick retrieval, in that case, I would be using infrequent access. And finally, I have Glacier. We have already discussed this. Here, your retrieval speed is low and the data needs to be put in for a longer duration. And that is why it is more affordable. If you take a look at the stats that are there in the image above, you can see that minimum storage duration is nothing for standard. For infrequent, it is 30 days, and for Glacier, it is 90 days. If you take a look at latency, it is milliseconds, and 4 hours. So that itself explains a lot of stuff here. So what are storage classes and what do they do? I believe some idea is clear to you people. Again, as we move into the demo part, we would be discussing this part as well. And we would also discuss expiration and transition that supports these terms. But let us move further and try to understand something else first. Versioning and cross-region replication. Now guys, when I say versioning, I'm actually talking about keeping multiple copies of my data. Now, why do I need versioning and why do I need multiple copies of my data? I've already mentioned that AWS S3 is highly durable and secure. How is that? Because you can fix the errors that are there, and you can also have multiple copies of your data. You can replicate your data. So in case if your data center goes down, a copy of it is mentioned or maintained somewhere else as well. How is this done? By creating multiple versions of your data. Say for example, an image, I store it in my S3 bucket. What happens here is there is key, the name is same, image, and version is some 33333, right? Now take a look at the other image. If I actually go ahead and create a copy of the first image, its name would remain same, but its version would be different. So suppose both of these images, they reside in one bucket. What these images are doing is they are having multiple copies or giving me multiple copies. Now in case of image, not a lot would change, but if I have doc files or data files, in that case, versioning becomes very important, because if I make changes to particular data, if I delete a particular file, a backup should always be there with me. And this is where versioning becomes very, very important. What are the features of versioning? By default, versioning is disabled when you say, or when you talk about S3, you have to go ahead and enable this versioning. It prevents overwriting or accidental deletion. We've already discussed that. You get non-concurrent version by specifying version ID as well. What do I mean by this? That means if I actually go ahead and create one more copy of the data and store it, so the latest copy would be available on top. But I can go to the versions option, put in the ID that belong to the previous version, and I can fetch that version as well. So what is cross-region replication? Now guys, we've discussed versioning. Let us talk about another important topic, that is cross-region replication. Now when you talk about S3, basically what happens is you create a bucket in a region and you store data in that region. But what if I want to move my data from one region or from one bucket in one region to other bucket in other region? Can we do that? Yes, cross-region replications let you do that. So what you do is you basically go ahead and create a bucket in one region, you create another bucket in another region, and probably you give access to the first bucket to move data from itself to the other bucket. So this was about versioning, this was about cross-region replication, and I believe we've also talked about storage classes. Let me quickly switch into the demo part and discuss these topics to little more detail. So guys, moving back, what we have done is we've actually gone ahead and created a bucket already, right? When you talk about what was the name of the bucket, it was Remos, if I'm not wrong. Yep. So if you click on the bucket name, Remos, what it does is it basically shows you these details, guys. Now you can see that your versioning is disabled, right? So if I click on it, I can actually come to this page and I can say enable versioning. That means a copy of the data that I create is always maintained. So if I go to Remos bucket, or I just move back, okay, this interface can be a little irritating at times. You have to move back and forth every now and then. So guys, there is a file which we have stored. You can just take a look at this date first. It says that it is 2:35. That was the time when the object was moved. Let me just say that upload the same file. This was the file we uploaded. I say next, 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 upload. So guys, this file is getting uploaded. You can see the name of the file is still same. We have only one file here. Why? Because it was recently modified at 245. From 225 to 235, it got changed to 245. So it is fairly clear, guys, what is happening here. Your data is getting modified. And if you wonder as in what happened to the previous version, don't worry. If you click on this show option, you can see that both of your versions are still here, guys. This was created at 235 and at 245. So this way, data replication and data security works much better. So you can secure your data, you can replicate your data. So in case if you lose your data, you always have the previous versions to deal with. How does the previous version thing works? So guys, what happens is if I delete this file, what Amazon S3 would do is it would set a marker on top of this file. And once I delete it, if I search for that ID won't be available. Why? Because the marker has switched to the next ID now. So whatever I want to do, I can do with the next ID as well. So guys, one more thing that you also need to understand here is what happens to the file. I mean, I've actually deleted a file, but a version is there with me. Can I delete all the versions? Yes, you can specify the ID and you can delete all the versions that you want. You can also do one thing, that is you can set a particular life cycle for your files. When I say life cycle, you can decide as in, okay, now I have a file in standard storage. We've discussed these storages, right? Standard storage, infrequent, and glacier. What you can do with your lifecycle management is you can decide as an, okay, for a particular time duration, I want this file to stay in standard. Maybe after a while, I want to move it to infrequent, and after a while, I want to move it to glacier. Say, for example, there is certain data which was very important for me, but having used that data, I don't want to use it for next few months. So in that case, I can move to the substitutes or to the other storage classes where probably I won't be needing to use that data for a longer while. And doing that, I won't be paying for this data as I used to pay for the standard, because standard is the costliest of the three. So let us quickly see, can we do that, or how does it work at least? If I just go back, this is my file. I can actually just go ahead and switch to management. In that, I have the option of life cycle. If I click here, there is no life cycle. Add a life cycle. You can add a life cycle rule as well, guys. New, let me call it new, and let me say next. It asks me what do I want to do. You can add rules in lifecycle configuration to tell Amazon S3 to transition objects to another storage class. There are pre-request fees when using lifecycle to transition data to any other S3 or S3 Glacier storage. So which version do I wish to use? Current, I can say yes. Add transition, and I can select transition to this tier when after 30 days. And if I say next, it would agree. Expiration, you can select other policies as well. So guys, when I say transition, first thing what it does is it tells me what time to transition to which storage class. And expiration, it tells me when does this expire. So I can decide when to clean up the objects and when not to. Let's not do that for now. Let's just say next. Next. So guys, what will happen here is after 30 days, my data would move to standard 1A storage. So you can actually go ahead and decide whether you want to move to Glacier. In that dropdown, you had more options as well. I did not show you that, but it is pretty understandable. You can move to Glacier as well. So this is about life cycle, guys. One more thing, you have something called as replication. You can add replication as well if you wish to replicate your data. Cross-region replication. I believe, guys, I do not have access to do that because I'm using someone else's account for now. But let me just give you some idea as to what you can do to replicate your data. You can just go ahead and click on Get Started. So replication, to remind you people, it is nothing but a process of moving your data from bucket in one region to other bucket in some other region. So for that, I need to select a source bucket. So let us just say that this is the bucket that I have. Next. Now guys, in my case, I haven't created the second bucket. What you can do is you can just go ahead and create one more bucket. Once you create the bucket, you can select the destination bucket. For now, let us just say that this is a bucket that has been created by someone else. I'm not going to transfer data here, but let's just select this for the demo sake. This is the bucket that I have. See, it says that bucket does not have versioning enabled. This is very important point, guys. I showed you how to enable versioning, right? If you select the bucket, there is an option on the right side saying versioning. You can actually go ahead and enable versioning there. So once you enable versioning, you would be able to use this bucket. Do you want to change the storage class for the replicated objects? If you say yes, it would give you the option of selecting what storage class do you want to select, right? If you don't have to. You can say next. You have to enter an IAM role. If you do not have any, you just say create a role and then the rule name. In this case, I do not have any details about this and I don't want to create a role because this account does not belong to me. Sorry for that inconvenience, but you can actually go ahead and select create a role and just say next. And I'm sure that you can actually go ahead and your bucket starts working or your cross-region replication starts working. What happens after that is once you store your object in a particular file, you can actually move that object, not in a particular file, in a particular bucket. You can move that data from that bucket to the other bucket. And a copy of your data is maintained in both the buckets that you use. So this is what cross-region replication is, guys. I believe that we've discussed what are storage classes, we've discussed what is cross-region replication, and we've discussed versioning in general. Let us quickly move back to the presentation and discuss the remaining topics as well. So guys, I've switched into the presentation part. Till time we've discussed how cross-region replication works, we've discussed how versioning works, and we've seen how to carry out that process. The other important topic that we need to focus on is we've known like how to create versions, how to move data from one place to the other. But the thing is, what if I have to move data from a particular location to a location that is very far away from me and still ensure that there is not too much latency in it? Because if you're moving data from one location to a location that is far away from you, it is understandable that it would take a longer while. Why? Because we are moving data from internet. So the amount of data that you move and the further you move, it should take a longer while for that. So how do you solve that problem? You have S3 transfer acceleration. You can do that by using other services as well. We discussed Snowball and Snowmobile as well, but they physically move the data, and at times it takes n number of days to move your data. With S3 transfer acceleration, that is not the issue because it moves your data at a very fast pace. So that is a good thing. So how can you move your data at a faster pace by using S3 transfer acceleration? Now guys, let us first understand what it is exactly. So what it does is it enables fast, easy and secure transfers of files over long distances between your client and S3 bucket. And to do that, it uses a service called as CloudFront and the edge locations it provides you. As I move further, I would be talking about what CloudFront is. Do not worry about it. First, let us take a look at this diagram. So normally, if you are moving your data or directly uploading your data to a bucket that is located at a faraway distance, I mean, suppose I'm a customer and I wish to put my data into an S3 bucket, which is located maybe a continent away from me. So using internet, it might take a longer while. Instead, what I can do is I can use transfer acceleration. So how is it different? Now guys, there is a service called as AWS CloudFront. What it does is it basically lets you cache your data. When I say cache your data, that means you can store your data at a location that is in the interim or that is close to your destination. Now this service is basically used to ensure that data retrieval is fast. Suppose I'm searching for a particular URL. What happens is when I type that URL, a request is sent to the server, it fetches the data and sends it to me. So if it is located at a very far location, it might take long while for me to fetch the data. So what people do is they analyze as in how much requests are coming from a particular location. And if there are frequent and a lot of requests, what they do is they set up an edge location close to that particular region. So you can put your data, you can cache your data on that edge location, and that data can be fetched from that edge location at a faster rate. So this is how edge locations work. What transfer acceleration does is it basically puts in your data at the edge location so that it can be moved to your S3 bucket at a quicker pace. And that is why it is fast. So guys, this was about S3 data acceleration. Let us quickly move into the console part and try to understand how S3 acceleration works. So guys, I've switched into the console. S3 acceleration or data transfer acceleration is a very easy thing to do. I do not remember the bucket name. I think it was Remos something. Okay, if I select this and open it, I can actually go to the properties part. Guys, there are other things that you might want to consider. You can come here and take a look at those as well. For now, I'm just gonna say go ahead and enable transfer acceleration. It is suspended. I can enable it. It gives me the endpoint as well, and I say save. So guys, what this means is if I'm putting my data into this bucket, it would be transferred very quickly, or I can use this bucket to transfer my data at a quicker pace by using data transfer acceleration by S3. Again, guys, I missed out on one important point. The fact that we have been talking about buckets and stuff like that, there is something important that I would like to show to you people. First, let us just go back and disable this part. I do not want it to have the transfer acceleration thing going. I just wanted to show it to you people how it is done. I just say go back to suspended. And one more thing, guys, if you once you actually enable the transfer part and if you upload a file, you can see the difference in the speed. The problem is you need a third-party tool to do that. So you can actually go ahead and download a third-party tool as well. And using that, you can actually go ahead and see how it works. Having said that, I was talking about buckets in general. So let us just go back and go to Remos again. There you go. And I'm gonna copy the ARN. I'll tell you why. I've copied the ARN. Now, when I open this bucket, guys, we have quite a few things. Permissions, I talked about security, right? So you can decide public access as in who gets to access your bucket. So guys, you can actually go ahead and decide who gets to access what kind of buckets. Say for example, here in your block public access, you can decide who gets to access what data publicly. For that, you have access control lists. Using these ACLs, you can actually decide who gets to access how. Other thing you can do is you can just go ahead and create a bucket policy and decide who gets to access your bucket or who gets to put your data, delete your data, and do all these things. Let us just go ahead and create a policy. Now you can write your own policy or you can just use a policy generator, which again is a third-party tool. So I want to create a bucket policy for my S3. So let's just say S3 bucket policy. And what kind of effect I want? I mean, do I want someone to access my system or do I want to deny someone from accessing my system? I can decide that. So let's for now just say that I want to deny someone from doing something. And what I want that someone to do is to deny a particular thing for that person for all the objects. I mean, I do not want that person to access any of the objects that is there. So what I say is star. That means nobody should able to do anything to any of the objects that are there in this bucket. So it says star service Amazon S3. What action I want? I want to prevent someone from deleting an object. There you go. And this is the ARN. That is why I copied it. It should be followed by a / and a star. Add a statement. And I say generate policy. So guys, the policy has been generated. I just have to copy it. If I copy this thing and I go back to the console, if I paste it here, I can say save. It's saved. I'll save it again just to be safe. So guys, we have actually gone ahead and let me just go ahead and again go to Remos. So guys, now there is an object here. Let me just try and delete this object. If I just go to the actions part here and I say delete, see the file is still here. Is it the other version? No, it's not deleted. See, there's an error here. If I click on it, it says 100% failed. Why? Access denied, because I do not have the access to delete the object right now. Why? Because I've created a bucket policy, guys. So that is what bucket policies and ACLs do. They let you make your objects or your data more secure. And as you saw in the option, there are quite a few options that you have at your disposal, which you can choose from, which you can mix and match and decide as in, okay, this is what I want to do. I want to probably give someone an access to delete a bucket. I want to give someone an access to do this or do that. So guys, this was about S3 data transfer acceleration. And we've also seen how you create a bucket policy, how you attach it to your bucket and stuff like that. Now, let me just go back and kind of brush up this session or finish this session up with a use case so that you can probably understand the topics that we've discussed a little more. First, let us go back to the use case, guys. So guys, I've switched into my presentation console again, and we would be discussing IMDb Media. Now, for people who watch movies, they might know what IMDb is. It is a website that gives you details about movies. They tell you what are the movies that are nice. If you probably select or type a particular movie name, they would give you details about it, as in who were the actors, how was the movie, how was the review, a short snippet explaining you what the movie is about, its genre and stuff like that. Plus they have their own ratings to kind of gauge in the customers even better, as in IMDb being a popular site. And when they say that this movie is this person good or liked by these many people, people normally believe it. So they have that score as well. So if you talk about a website that basically deals with movies, you understand the number of movies that are released worldwide. And if most of them are present here on IMDb, that means that database is huge. But we are talking about data that is being processed in great numbers, great amounts. I mean, when you talk about the data that is here, what is happening here is you have n number of movies that are being released. So if someone searches for a particular movie, it has to go through the database and that data has to be fetched to him right away. So how do you deal with the latency issue? Well, this would answer a lot of questions, or it would sum up a lot of topics that we've discussed here. Let us go through this use case probably. So what happens here is, in order to get the lowest possible latency, all the possible results for a search are pre-calculated with a document for every combination of letters in the search. What this means is, probably based on the letters, you have a document that is created and it is traversed in such an order that all the data is scanned letter-wise. When you actually go ahead and put forth a query, what happens is, suppose if there is a 20-character letter or a word that you put in, So there are somewhere around 23 into 1030 combinations that are possible. So your computer has to go through these many combinations. What S3 does is it basically lets you store the data that IMDb has. And once IMDb has stored that data, they use CloudFront again. We have discussed what CloudFront is. They use CloudFront to store this data to the nearest possible location so that when a user fetches this data, it is fetched from that location. So what happens is basically when these many possibilities or combinations are to be dealt with, it becomes complicated. But in practice, what IMDb does is it basically uses analytics in such a way that these combinations become lesser. So in order to search for a 20 character letter, they basically have to go through 150000 documents. And because of S3 and CloudFront, you basically can distribute all the data to different edge locations and to buckets within hours. And since we are talking about huge amount of data, it is more than terabytes. It is like hundreds, thousands of terabytes of data. So we can understand how much data are we talking about. And S3 actually features or serves a number of such use cases or requirements. So guys, I believe by now you've understood what S3 is. Let me give you a quick sum up or a quick walkthrough as to what we've studied, because we've talked about a lot of topics, guys. First, we started with the basics of different storage services. We've understood storage services like EFS, EBS, storage gateway. We've talked about Glacier. We've talked about Snowmobile, Snowball, and then we moved to S3. S3, we talked about buckets. We talked about objects. We talked about versioning. We understood why versioning is needed so that we can basically replicate our data, prevent it from deletion, prevent it from corruption. We also talked about a cross-region replication where you can move data from one region to the other. We talked about how we can move data faster by using S3 data transfer acceleration. And then we also took a look at basics like what are the storage classes, what are the bucket policies, how to create bucket policies, and we also discussed an important topic called as transition and expiration, where if your data expires, it is deleted. If your data needs to be transferred to different stages, you can do that as well. So all these topics were discussed, and we also discussed some important features. And finally, we finished this session up with a use case.
So networking domain basically offers three kind of services: the VPC, Direct Connect, and Route 53. Let's discuss each one of them. So VPC is a virtual private cloud. So it's a virtual network. If you include your all your AWS resources that you have launched inside one VPC, then all these resources become visible to each other or can interact with each other once they're inside the VPC. Now, the other use for VPC is that when you have a private data center and you're using AWS infrastructure as well, and you want your AWS resources to be used as if they were on your own network. In that case, you will establish virtual private network, that is a VPN connection to your virtual private cloud, in which you have included all the services that you want on your private network. You will connect your private network to the VPC using the VPN, and then you can access all your AWS resources as if they were on your own network. And that is what VPC is all about. It provides you security, it makes communication between the AWS services easy, and it also helps you connect your private data center to the AWS infrastructure. So guys, this is what VPC is all about. Let's go ahead onto our next service, which is Direct Connect. So Direct Connect is a replacement to an internet connection. It is a leased line, a direct line to the AWS infrastructure. So if you feel that the bandwidth of internet is not enough for your data requirements or your networking requirements, you can take a leased line to the AWS infrastructure in the form of the Direct Connect service. So instead of using the internet, you would now use the Direct Connect service for your data stream to flow between your own data center to the AWS infrastructure, and that is what Direct Connect is all about. Nothing much further to explain. Let's move on to our next service, which is Route 53. So Route 53 is a domain name system. So what is a domain name system? Basically, whatever URL you enter has to be directed to a domain name system, which converts the URL to an IP address. The IP address is of the server on which your website is being hosted. The way it functions is like this. You buy a domain name, and the only setting that you can do in that domain name, or the setting which is required in that domain name, are the name servers. right? Now these name servers are provided to you by Route 53. These name servers that Route 53 provide you are to be entered in the settings of that domain name. So whenever a user points to that URL, he will be pointed to Route 53. The work in the domain name settings is done. You have to configure the Route 53 now. Now that your request has reached Route 53, it has to be pointed to the server on which your website is hosted. So on a Route 53 now, you have to enter the IP address or the alias of the instance to which you want your traffic to be directed to. So you feed in the IP address or you feed in the alias and it's done. The loop is now complete. Your URL will now get pointed to Route 53 and Route 53 in turn will point to the instance on which your application or website is being hosted. So this is the role which Route 53 plays. It's a domain name system. So it basically redirects your traffic from your URL to the IP address of the server on which your application or website is hosted. Alright guys, so we're done with the networking domain.
In today's session, we would be understanding what AWS CloudFront is. But before we do go ahead and understand what CloudFront exactly is, let's start by taking a look at today's agenda first. First and foremost, I would be talking about what AWS exactly is. We'd also understand why do we need AWS CloudFront and what it is exactly. Then I would talk about how content gets delivered using Amazon CloudFront and what are its applications. Finally, I would finish things off with the demo part where I would be talking about AWS CloudFront distributions. Having said that, let's not waste any time and jump into the first topic of discussion, that is, what is AWS? Well, AWS stands for Amazon Web Services, which is a leading cloud service provider in the market. And it has the highest market share when you talk about any cloud service provider. Now, what Amazon Web Services does is it provides you with 70 plus services, and these services are constantly growing. To name some of these services, we have something called as your computation services, your storage services, your database services, and all these services are made available to you through cloud. That means you can rent all these services and pay only for the services that you use and only for the time duration you use these services for. If you want to know more about how AWS works exactly, I would suggest that you go through the videos that we have on YouTube. We have quite a few videos on YouTube which talk about AWS in particular. All you have to do is you have to go to our YouTube channel and type Edureka AWS and you'd be having all the videos that are related to AWS. But that is not the discussion for today. We are here to discuss what CloudFront is, and I would like to stick to that. So coming back to CloudFront, when you talk about AWS, you have some services. Now what AWS does is it offers you various infrastructure as services and even platform as services. Now these services are made available to you in the form of infrastructures or platforms where you can actually go ahead and host your applications or websites. So when you do go ahead and host these applications online, what your cloud provider has to worry about is the way data is fetched. Because if you have a website online, now that website would be visited by quite a few people and they would be requesting particular content or data, right? So in that case, that data has to be made available to your customers. So how does it happen exactly and how does AWS make it happen? To understand that, consider this scenario. Suppose you are a particular user and you're trying to visit a particular website, and imagine that that website is based somewhere at a very far location. Suppose you're based somewhere in USA and that website, its server actually hosts or is based in Australia. Now, in that case, when you make a request for particular object or particular image or maybe content, now your request is sent to the server that is in Australia and then it gets delivered to you. And in this process too, there are quite a few interrelated networks that deal which you are not aware about. The content directly gets delivered to you and you have a feeling where you feel that you type in a particular URL and the content is directly made available to you. But that is not how it works. Quite a few other things happen in the interim. And due to that, what happens is the data that gets delivered to you, it does not get delivered to you very quickly. Why is that? Because you'd be sending in a request, it would go to the original server, and from there the content is delivered to you. Now, if you are based in USA, the situation would be convenient if the data is delivered to you from somewhere close by. Now, when you talk about a traditional system where you are sending a request to somewhere in Australia, this is what happens. Your data or your request is sent to the server based in Australia, and then it processes that request and that data is made available to you, which gets delivered to you. But if you have something like CloudFront, what it does is it sets in an intermediate point where your data actually gets cached first. And this cached data is made available to you on your request. That means the delivery happens faster and you save a lot of time. So how does AWS CloudFront exactly do it? Let's try to understand that. Well, when you talk about AWS CloudFront, what it does is first and foremost, it speeds up the distribution process and you can avail any kind of content, whether it's static or dynamic, and it is made available to you quickly. What CloudFront does is it focuses on these 3 points. One is your routing, two is your edge locations, and three is the way the content is made available to you. Let's try to understand these one by one. When you talk about routing, I just mentioned that the data gets delivered to you through a series of networks. So what CloudFront does is it ensures that there are quite a few edge locations that are located close to you. And the data that you want to access, it gets cached so that it can be delivered to you quickly. And that is why the data that is being delivered to you is more available than in any other possible case. So what happens exactly and how does this content gets delivered to you? Let's try to understand this with the help of this diagram. Suppose you are a user. So basically what you would do is you would send in a request that needs to reach a particular server. Now in this case, what happens is first your request, it goes to an edge location and from there to your server. To understand this too, you have to understand two scenarios. First and foremost, suppose you are based in USA and you want to fetch a particular data that is based in Australia, you would be sending in a request. But what AWS does is instead of sending that request directly to your server, which is based in Australia maybe, it has these interim edge locations which are closer to you. So the request, it goes to the edge location first and it checks whether the data that you're requesting is already cached there or not. If it is not cached, then the request is sent to your original server. And from there, the data is delivered to the edge location. And from there, it comes to you. Now, you might wonder, as in, this is a very complex process. And if it is taking these many steps, how is it getting delivered to me quicker than in normal situation? Well, think of it from this perspective. If you do send in this request directly to the main server, again the data would flow through some network and then it would be delivered to you. Instead, what happens here is at your edge location, the data gets cached. So if you request it again, it would be delivered to you quicker. If it is requested by anyone else, it would be delivered to them quicker. Plus, how edge locations work is when you do send in this request and when the edge location fetches this data from your so-called original server, in that case too, when the first byte it arrives at your edge location, it directly gets delivered to you. And how does this content exactly get stored here? Well, first and foremost, what happens is what your edge location has is it has some regional cache as well. Now, this cache would basically hold all the content that is requested more frequently in your region. Suppose a website has some n number of content, and out of it, some content is kind of requested a lot in a particular region. So surrounding that region, the closest edge location would have a regional cache which would hold all the content that is more relevant for those users so that it can be frequently delivered to these users and can be made available to them quickly. In case if this data gets outdated and it is no longer being requested, then this data can be replaced with something else that is requested more frequently. So this is how CloudFront works. What it does is it creates a distribution and you have some edge locations through which you can actually request that data faster. So what are the applications that CloudFront has to offer to you? Now, I won't say applications. Instead, I would say some of the benefits of using CloudFront. Let's try to understand those one by one. First and foremost, what it does is it accelerates your static website content delivery. We just discussed that. That means if you're requesting a particular image or something like that, it gets delivered to you quicker. Why? Because it is cached at your edge location and you do not have to worry about any latency issues. Next, what it does is it provides you various static and even dynamic content. Suppose you need some video or a live session or something like that. Even that gets delivered to you quickly. I just mentioned that when you request a particular thing, when the first byte it arrives at your edge location, your CloudFront starts streaming that to you or start delivering that to you. Same happens with your live streaming videos as well. you'd be getting that streams instantly without any latency whatsoever. Encryption. Now, when you do access this content, what AWS CloudFront does is it lets you have this so-called domain where you put in HTTPS and you get secured data. So you already have one layer of security, but it also lets you add another layer of security by giving you something called as encryption. By encrypting your data or by using your key value pairs, which is the same, you're actually ensuring that your data is more secured and it can be accessed privately as well. Customization at the edge. Now, what do I mean by this? Now, there is some content that needs to be delivered to the user or to the end user. If the customization it happens at the server, again, it might be time consuming and there are quite a few drawbacks of it. Say, for example, I need a particular content and it needs to be processed or customized at the very last moment. So these things can be done at the edge location as well, thus helping you save time, money, and various other factors as well. And finally, what it does is it uses something called as Lambda Edge, which again lets you deal with various customizations and lets you serve your content privately. So these were some of the applications or uses of CloudFront. What I'm going to do now is I'm going to switch into my AWS console and I'm going to talk about AWS CloudFront distributions and how can you go ahead and create one. So stay tuned and let me quickly switch into the console first. So yes, guys, what I've done is I've gone ahead and I've logged into my AWS console. Now, for people who are completely new to AWS, what you can do is you can actually go ahead and create a free tier account. You have to visit AWS website and search for free tier. You would get this option. Just create an account. They would ask you for your credit or debit card details probably, but they won't charge you. A minimal amount is charged and that is reverted back to your account. That is for verification purpose. And after that, what AWS does is it offers you certain services which are made available to you for free for one complete year. That is, as long as you stay in the limits or the specified limits which AWS has set. So those limits are more than enough to practice or to learn AWS. So if you want to go ahead and get a proper hands-on on various AWS services, I would suggest that you do visit their website and create this free tier account. Once you do have that account, you have all these services that are made available to you. As I just mentioned, there are 70 plus services, and these are the services that are there, which you can actually go ahead and use for different purposes. Our focus today, however, is creating a CloudFront distribution, which we just discussed in the so-called theory part. I would be repeating few topics here too while we do go ahead and create our CloudFront distribution. Now, as I've already mentioned, we want to fetch data or fetch a particular object, and if that is placed at a particular edge location, that would be made available to me. So what we are doing here is imagine that our data is placed at a particular original server. In our case, let's consider it as an S3 bucket. Now, S3 is nothing but a storage service with AWS, that is simple storage service rather, that is SSS, and that is why we call it S3. So what we are going to do is we are going to go ahead and create an S3 bucket. In that, we would be putting in certain objects and we would be accessing that by using our CloudFront distribution. So let's just go ahead and create a bucket first. You can see we have S3 in my recently used services. You can just type S3 here and that would be made available to you. You can click on it and your simple storage service opens. You would be required to go ahead and create a bucket. This is how you do it. You click on create and you give it some name, say maybe bucket, use small letters, bucket for AWS demo maybe, and I would give in some number 000. I say next, next, next. I need a basic bucket, so I won't be putting in any details. Do we have a bucket here? Ah, there you go. We have a bucket here. And in this bucket, what I'm going to do is I'm going to put in some content that we can actually request for. So let's just go ahead and create an HTML file and put in maybe an image or something. So I have a folder here. In that folder, I have a logo of Edureka. I would be using that logo and I would want to go ahead and create an HTML file which I can refer. So I would open my notepad and I would write a simple HTML code. I won't get into the details of how to write an HTML code. I assume that you all know it. If not, you can use this code. So let's create a head file basically, or a head tag rather. Let's say demo tag maybe. And I close this head tag. I need some body in here, right? So let's say, let the body be say, welcome to Edureka. And I and the body here, and I save this file. I say save as. Where do I want to save it? And save it here, and I would save it as, say, maybe index.html. I say save. It probably got saved somewhere else. Let me just copy it and paste it here. I've done that. This is the file. Now we have these files. Let's upload it to our S3 bucket. Come here, I say upload. I want to add files. So add files. Where do I go? I go to the F folder. I go to demo and I select these two files and I say upload. There you go. My files are here and I say upload. Small files, so should not take a long time. 50% successful, 100% successful. There you go. You have these two files. Now we have our S3 bucket and we have two files. This is our origin server. Now I need to create a distribution and use it. To do that, I would click on services and come here and I would search for CloudFront. There you go. And I say create a distribution. So I click on this icon. Now you have two options. First one is something that lets you have your static data moved in or moved out. Or if you want to live stream your data, you should go for this option, but that is not the case. We would be sticking to this thing. I say get started. I need to enter in a domain name. So it gives me suggestions, and this is the first one which I just created. Original path is something that you can give in for the folders from where you want to access the data, but mine directly resides in the bucket. There are no extra folders, so I don't need to enter anything. Original ID, this is what I have here. Basically, I can use this, or I can just go ahead and change the name if I want to, but I would let it stay the way it is. Restrict bucket access, yes, I want to keep it private, so I say restrict and I create a new identity. And there you go, I have a new user created here. Apart from that, grant read permissions on bucket, yes, update my bucket policy accordingly is what I would say. Then I would scroll down, customer headers and all. I don't need to put in these details. How do I want my data to be accessed? The protocol policy. I would say redirect HTTP to HTTPS so that it is secured. If I scroll down, I have some other options as well. Cached HTTP methods and all those things. Do I need to change these? Object caching, can I customize it? Yes, I can, but again, I would be using the by default one. If you want to, you can customize it. Smooth streaming, no, these are some of the things that you need to focus on. If you have some streaming data, you can put in details accordingly, but we are not doing that. What is the price class that you want to choose? You have some options here which you can pick from. I would be going for the default one. And then I just scroll down and I say create a distribution. So your distribution is getting created now. And this process might take a longer while. If you click on this thing, you'll realize that it is in progress and it takes somewhere around 10 to 12 minutes for this distribution to get created. So meanwhile, I'm going to pause this session and I would come back with the remaining part once this distribution is completed. So bear with me for that while. So there you go. The distribution has been deployed. The status is deployed here. So we can actually go ahead and use this thing. Now we have a domain name here which I can use and I can just enter it here and we would be redirected to the page. And what happens here is you would be actually given access to this page through the edge location. That means you're not going to the server. Instead, the data is being cached to you from your distribution or your edge location rather. So you enter this website and you hit the enter button. There's an error. It shouldn't have been. Oh, I know what just happened. When you do go ahead and create your so-called distribution, in that you actually have an option of selecting a by default file, which I did not. So I'll have to give in an extension here saying slash index.html. And if I hit the enter button now, it should redirect you to the demo tag, which says welcome to Edureka, right? So this was the HTML file that we created. And we also had a PNG file, which we wanted to access. The name was logo.png. Okay, this is funny. This should not happen. Why is this happening? Let's take a look at it, whether we have that file there, because if it was there, we should be able to access it. And what was my bucket? This was the one. Oh, this has happened. When I uploaded that file, it got saved with this extension .png. So if I come here and I type .png here, there you go. You have that object delivered to you through your so-called distribution.
this session, we will be discussing about Amazon CloudWatch. So without any delay, I'll walk you through the topics which we will be discussing today. Firstly, we will see what Amazon CloudWatch is and why do we need it. Then we'll discuss certain Amazon CloudWatch concepts. Moving on, we'll take a look at two most important segments of Amazon CloudWatch, which are Amazon CloudWatch events and Amazon CloudWatch logs. And finally, to make this all more fun and interesting for you, I've included a demo as well. So let's get started. First, let us try to understand why we need cloud-based monitoring with a couple of scenarios. In our first scenario, consider that you have hosted a messenger app on cloud and your app has gained a lot of fame, but lately the number of people using your application has gone down tremendously and you have no idea what the issue is. Well, it could be due to two reasons. Firstly, since your application has complex multi-tier architecture, monitoring the functionality of every layer by yourself will be a difficult task. Don't you think? And secondly, since you're not using any kind of monitoring tool here, you wouldn't know how your application is performing on cloud. Well, one solution for that is to employ a monitoring tool. This monitoring tool will provide you insights regarding how your application is performing on cloud. And with this data, you can make necessary improvements and you can also make sure that your application is in par with today's customer needs. And definitely after a while, you'll notice that the number of people using your application has increased. Moving on to our next scenario, let's say your manager has assigned you with a project and he wants you to make this project as cost effective as possible. So as you can see in this project, you're using 5 virtual servers which perform highly complex computations. And all these servers are highly active during daytime. That is, they handle most traffic during daytime. But during nighttime, the servers are idle. By that I mean the CPU utilization of these servers during nighttime is less than 15%. And yet, as you notice here, in both the cases, you are paying same amount of money. You have to notice 2 points here. Firstly, all your virtual servers are underused during nighttime. And secondly, you are paying for the resources which you're not using. And this definitely is not cost effective. So, one solution is to employ a monitoring tool. This monitoring tool will send you notification when these servers are idle and you could schedule to stop the servers on time. So guys, this is one way to make your project most cost effective and avoid paying unnecessary operating costs. Let's consider another scenario for better understanding. So let's say I have hosted an e-commerce website on cloud and during sales season, many customers are trying to access my website, which is definitely a good thing. But for some unfortunate reason, application downtime has occurred. And you guys have to remember that I'm not using any kind of monitoring tool here. So it will be difficult for me to identify the error and troubleshoot it in reasonable amount of time. And it's quite possible that in this period, my customer might have moved on to different website. So you see that I've lost a potential customer here. So if I've had a monitoring tool in the situation, it would have identified the error in earlier stages itself and rectified the problem. Well, I could have easily avoided losing my customer. So I hope guys with help of these use cases you were able to understand as to why we need cloud-based monitoring. So let me just summarize what we've learned till now. We need monitoring firstly because it provides a detailed report regarding performance of your applications on cloud. And secondly, it helps us to reduce unnecessary operating costs which we are paying to the cloud provider. Moreover, it detects problems at earlier stage itself so that you can prevent disasters later. And finally, it monitors the user's experience and provides us insights so that we can make improvements. So well guys, in this session, we will be discussing about one such versatile monitoring tool called Amazon CloudWatch. Amazon CloudWatch basically is a powerful monitoring tool which offers you a most reliable, scalable, and a flexible way to monitor your resources or applications which are currently active on cloud. It usually offers you with 2 levels of monitoring, which are basic monitoring and detailed monitoring. If you want your resources to be eligible for basic monitoring, all you have to do is to sign up for AWS free tier. In basic monitoring, your resources are monitored less frequently, like say every 5 minutes, and you're provided with a limited choice of metrics to choose from. Whereas in detailed monitoring, all your resources are monitored more frequently, like say every 5 minutes, and you're provided with a wide range of metrics to choose from. But if you want your resources to be eligible for detailed monitoring, You'll have to pay a certain amount of money according to AWS pricing details. Now, let's have a look at few monitoring services offered by Amazon CloudWatch. Amazon CloudWatch, firstly, it provides a catalog of standard reports which you can use to analyze trends and monitor system performance. And then it monitors, stores, and provides access to system and application log files. Moreover, it enables you to set up high resolution alarms and send notifications if needed. And Amazon CloudWatch also sends system events from AWS resources to AWS Lambda functions, SNS topics, etc. So if you have not understood any terms which I've used here, don't worry, we'll get to know more about these terms as we progress through the course of this session. Earlier, I mentioned that Amazon CloudWatch allows administrators to monitor multiple resources and applications from single console. These resources include virtual instances hosted in Amazon EC2, databases located in Amazon RDS, data stored in Amazon S3, elastic load balancers, and many other resources like auto-scaling groups, Amazon Cloud Trail, etc. So guys, now let's try to understand Amazon CloudWatch a little deeper. Firstly, we'll have a look at few Amazon CloudWatch concepts, and then I'll explain you how Amazon CloudWatch actually operates. So it's metric. A metric represents a time-ordered set of data points that are published to cloud. So what I mean by that is, suppose let's say you have three variables x, y, and z, and you have created a table which has values of x with respect to y over a period of time. In this scenario, the variable x which you have been monitoring till now is a metric. So you can think of metric as a variable which needs monitoring. Next we have dimensions. Let's consider same variables x, y, and z. Previously you had created a table which has values of x with respect to y. Now let's create another table which has values of x with respect to z. So basically we have two tables which describe same variable x but from two different perspectives. These are nothing but dimensions. So basically a dimension is a name value pair that uniquely identifies a metric. And Amazon CloudWatch allows you to assign up to 10 dimensions to a metric. Then you have statistics. Previously we had created two tables which had values of x with respect to y and as well as z. You can combine data from these tables like to create a chart or maybe plot a graph for analytical purposes. This combination of data is nothing but statistics. Statistics are metric data aggregations over a specific period of time. Then you have alarm. Let's say you have been monitoring this variable x for some time now and you want a notification to be sent to you when the value of x reaches certain threshold. All you have to do is set an alarm to send you notification. So basically, alarm can be used to automatically initiate actions on your behalf. Now that you have clear understanding of concepts of Amazon CloudWatch, let's see how Amazon CloudWatch operates. Amazon CloudWatch has complete visibility into your AWS resources and applications which are currently running on cloud. So firstly, it collects metrics and logs from all these AWS resources and applications. And then by using these metrics, it helps you visualize your applications on CloudWatch dashboard. Moreover, if there is some sort of operational change in AWS environment, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective action, like maybe it sends you a notification or it might activate a Lambda function, etc. And finally, it provides you real-time analysis by using CloudWatch Metric Math. So if you're wondering what CloudWatch Metric Math is, it is a service which integrates multiple CloudWatch metrics and creates a new time series. And you can view this time series on CloudWatch dashboard as well. So working this way, Amazon CloudWatch provides you with system-wide visibility. It even provides you actionable insights so that you can monitor your application performance. Moreover, it allows you to optimize resource utilization if needed. And finally, it provides a unified view of operational health of your AWS environment. So I hope that by now you know what Amazon CloudWatch is. So now let's try to understand how Amazon CloudWatch works with help of a demo. So guys, this is my AWS console. Let's say AWS Management Console. And the services which you can see on the screen are the services offered by Amazon AWS. But in this demo, we're going to use only few services. Let's say CloudWatch, and then you have EC2 and a service called Simple Notification Service. And when I click on EC2, it takes me to EC2 dashboard where you can see that I have 4 instances which are currently active. You know that here in this demo, I'm supposed to get a notification saying that CPU utilization of my instance is less than 25%. For me to receive a notification first, I'll have to create a topic and subscribe to it with my email ID. So let's explore a service called Simple Notification Service, where you can create a topic and subscribe to it. Once you reach SNS dashboard, click on topics option on the navigation pane and click a create new topic. Give your topic a name. Let's say CW topic and give the display name as well. Let's give the same name and click on create topic option here. You can see that I've successfully created a topic. Now click on the topic which you have created and select actions and subscribe to topic option. Well, I want notification to be sent to me in form of email. You have different options as well in form of Lambda function or JSON, etc. But I'm going to choose it as email and give my email ID, which is here, and then click on create subscription option. So now whenever AWS console wants to send me a message, it will send to the email ID which I used to subscribe the topic. Now let's go back to CloudWatch dashboard. So guys, this is my CloudWatch dashboard and you can see different options on navigation pane. Firstly, I have dashboard where I can view all my metrics at same place. Then you have alarms, which shows the list of alarms which you have configured. And then you have events and logs, which we'll be exploring later. Our topic of interest is the last one, which is metrics. Select the metrics option here and then choose EC2 and then per instant metrics. When you do that, a list of metrics will be shown to you like network out, CPU utilization, network packets in, network packets out, and various other metrics for various resources which are currently active on your cloud. So, but we are interested only with CPU utilization. So I'm going to type that here. Well, it shows the list of instances which are active on my cloud. And I'm going to choose Windows 2 instance and then click on graph metrics option here. Okay, let's select Windows 2 only. And then on the right side, you can see you have a alarm button. When you click on that, a dialog box will be open where you can configure your alarm. Firstly, let's give alarm a name. Let's say low CPU utilization and a brief description as well. Let's say lower than 25%. Lower than 25% CPU utilization. Now I'm going to set the threshold, which is less than 25% in this case. And on the right side, you can see a period option. If your resources are eligible for basic monitoring, this period option by default is 5 minutes. And if your resources are eligible for detailed monitoring, it's usually 1 minute. And when you scroll down, you can see a send notification to option here. So select the topic which you have previously created. That will be C topic in my case, and then click on create alarm. Well, there is some error. Okay, it says there's an alarm already with this name. So let's give it another name of my instance. Now let's try again. And when you click on this alarm button and click on refresh option here, it says that I've successfully created a alarm. Here you can see that low CPU utilization of my instance. And when you click on that, it shows you all the details like description, threshold, and what action it is supposed to take when alarm is configured and all the details. So guys, try it out. It'll be easy for you to understand CloudWatch console much better. Okay guys, now you know what Amazon CloudWatch is, what it does, and the way it operates. But to understand the capability of Amazon CloudWatch completely, we should be aware of two important segments of Amazon CloudWatch, which are CloudWatch events and CloudWatch logs. So let's discuss them one by one. Firstly, we have Amazon CloudWatch events. Consider the scenario. Let's say I've created an auto-scaling group, and this auto-scaling group currently has terminated an instance. So you can see this as some sort of operational change in AWS environment. When this happens, Amazon CloudWatch becomes aware of these changes and responds to them by taking some sort of corrective actions. Like in this case, it might send you a notification saying that your auto-scaling group has terminated an instance, or it might activate a Lambda function which updates the record in Amazon Route 53 zone. So basically what Amazon CloudWatch events does is it delivers a real-time stream of system events that describe change in your AWS resources. Now let's have a look at few concepts related to CloudWatch events. Firstly, we have event here, An event indicates change in AWS environment, and AWS resources generate events whenever the state changes. Let's say you have terminated an active EC2 instance. So the state of this EC2 instance has changed from active to terminated, and hence an event is generated. Then you have rules. Rules are nothing but constraints. Every incoming event is evaluated to see if it has met the constraint. If so, the event is routed to target. Target is where the events are handled. Target can include Amazon EC2 instances or a Lambda function or an Amazon SNS topic, etc. Now let's try to understand Amazon CloudWatch events better with help of use case. In this use case, we are going to create a system that closely mimics the behavior of dynamic DNS. And for those who don't know what dynamic DNS is, let me give an example. Let's say you want to access internet at home, then internet service provider assigns you an IP address, but since internet service provider uses different kind of online systems, this IP address keeps changing, because of which it might be difficult for you to use this IP address with other services like webcam, security camera, thermostat, etc. So this is where dynamic DNS comes into picture. What dynamic DNS does is it assigns a custom domain name to your home IP address, and this domain name is automatically updated when IP address changes. So basically, dynamic DNS is a service that automatically updates a name server in domain name system. And Amazon offers you with a similar kind of service called Amazon Route 53. So in this use case, we are going to update Amazon Route 53 whenever an Amazon EC2 instance changes its state. Now let's see how the use case actually works. This use case precisely works this way. So whenever an EC2 instance changes its states, Amazon CloudWatch event becomes aware of these operational changes and it triggers a Lambda function. This Lambda function uses different kind of information regarding the instance like its public and private IP address, and it updates a record in appropriate Route 53 hosted zone. So let's say you have an EC2 instance and you have terminated the instance. So Amazon CloudWatch events become aware of this and it triggers a Lambda function. And this Lambda function deletes the record from Amazon Route 53. Similarly, if you have created a new instance, again Amazon CloudWatch events become aware of this and it triggers a Lambda function, and this Lambda function creates a new record in Amazon Route 53. I hope you have understood what Amazon CloudWatch events is and what it does. Now let's discuss how Amazon CloudWatch events works with help of a demo. So in this demo, we will schedule to stop and start EC2 instances with help of Lambda function and CloudWatch events. So let's go ahead with demo. So guys, you can see that I have 4 instances which are currently active. First, I'm going to create a Lambda function which is going to stop my Windows 2 instance. And you guys need to know that for Lambda function to do that, we need to assign permission. So Amazon provides you with a service called IAM, which is Identity and Access Management, where you can assign permissions. When you search for IAM in the tab, it shows you the service. Select that, and on IAM dashboard, on the navigation pane, you can see a policies option here. Select that and click on create policy option. First, it's asking you for a service here, which will be EC2 in our case. Click on EC2 function, then actions, which will be to start and stop my EC2 instances. So let's search for start instance. Well, a predefined function is already there, so you can choose that. Then you have stop instance. Again, select that. And then I want this to be eligible for all the resources, so I'm going to choose all resources here and click on review policy option. Let's give our policy a name, that is to start and stop EC2 instances, and description as well, a brief description, let's say to start and stop instances. And now click on create policies. It's taking a while. So I've successfully created a policy here. Next, we have to assign this policy to Lambda function. So click on roles here, then click on create role, choose Lambda function here and click on next permission. Search for the policy which we have created earlier, that is to start and stop. I found the policy, select that and click on next review option. It's asking for a name. Let's give a name. Start, stop instances and click on create role. I've successfully created a role. So what we have done here is we have assigned permission for Lambda function to control EC2 instances. Now let's create a Lambda function. You can search for Lambda in the search tab and there click on create function. Give your Lambda function a name. Let's say to stop instance. and select the role which you have previously created and click on create function. You can see that I've successfully created an Lambda function. And now I'm just going to copy the code to stop EC2 instances here. I'm going to select this and paste it over here and make sure to save it. As you can see here in this function, it asks for instance region and instance ID. So let's configure the details. Let's give it as stop instance. And here you'll have to insert instance region and ID. Instance region and instance ID. Now we'll have to copy the instance region and ID of the instance whichever we need. So let's go to EC2 dashboard here. Now let's say I want my Windows 2 instance to be stopped. This is the instance ID which I'm going to paste it over there. Similarly, instance region now. Well, in this case, I'm choosing Windows 2 instance. You can choose whichever instance you want to stop. Once you're done that, you click on create option here. Test the configuration details. When you scroll down, you can see the execution results here. It says that my instance has been successfully stopped. Let's go and check in the EC2 dashboard. Here on the EC2 dashboard, I'm going to refresh it. And you can see that my Windows 2 instance has successfully stopped. Now we'll create another Lambda function which will restart this function. Again, the same, search for Lambda function in the search tab and click on create function option. It asks for a name, so let's say start instance, and choose the role which you have previously created and click on create function. Again, you'll have to paste the code to start the instances over here and click on save option. Let's try to configure this. Let's name it as start instance. And again, it asks for two attributes which are instance region and ID. Now all we have to do is copy the instance region and ID here like we did earlier. Let's go to EC2 dashboard and copy the instance ID and region. Well, you guys can see that here my Windows 2 instance has been successfully stopped. Now I'll copy this and paste it over there. Similarly, instance region as well. And click on create option. Now test the configuration. And when you scroll down, you can see that my instance has successfully restarted. In the EC2 dashboard, I'm going to refresh this. Well, my Windows 2 instance is on its way to get restarted. Till now, I've used Lambda function to start and stop my instances. But now I'm going to automate this process with help of Amazon CloudWatch. So let's go to CloudWatch dashboard here. Well, it's taking a while to load. Then choose events option and click on create rule. So here we're going to schedule to stop my instances every day at 6:30 p.m. and to restart this instances every day at 6:30 a.m. So click on schedule. If you want to know more about cron expressions, you can visit Amazon documentation. So let me show you. It has 6 fields. Firstly, it's minutes, then you have hours, then day of month, day of week, and year. We're concerned only with minutes and hours because we want our instances to be start and stopped every day, every month. So let's give the details. So if you're going to create a rule to stop the instance, let's say 6:30 in the evening, 30 minutes and 18, which is nothing but 6 p.m. And then rest all, you don't have to mention anything. When you give a proper cron expression, sample timings will be provided to you. You can see here the rest of the sample timings. And now let's add a target function, which is Lambda function in our case, and select on stop instance function and click on configure details. Give your rule a name. Let's say stop my EC2 instance, and description to stop my EC2 instance at 6:30 p.m. every day, and click on create rule here. You can see that I've successfully created a rule to stop my instance every day at 6:30 p.m. Now let's create another rule to restart this instance every day at 6 a.m. in the morning. Again, the same. Choose the schedule here and cron expression, which will be 6 a.m. in the morning. Again, the sample timings are shown here. Then let's add target function, again lambda function, and select the function that is to start instance and click on configure details. Let's name it as start my EC2 instance and description as to start my EC2 instance every day at 6 a.m. and click on create rule. So now we have successfully created two rules to start and stop the EC2 instances at 6:30 p.m. and 6:30 a.m. respectively. So what we have done is we have saved our time here. We have automated the process of stopping and starting EC2 instances. So try it on yourself. It'll be easier for you to understand. So guys, now let's discuss our next topic, which is Amazon CloudWatch logs. Have you guys heard of log files? Well, log files are nothing but detailed record of events that occur when you're using your AWS environment. You can view your log files on your on-premise server as well. Search for an app called Event Viewer. Select the app and click on Windows Logs and select Systems. A list of log files will be shown to you. When you choose a particular log file, all the details regarding that log files will be shown, like the number of keywords, the login time, number of hours the file has been logged onto, and various other details. Similarly, you have log files created when you use AWS environment as well. So you can consider these log files as a data repository. Most of the metrics are generated from these log data. So whenever a metric is generated, a part of data is extracted from this log data. So you're designing metrics according to your like by choosing a part of data from this log data. So basically these log files are what you call a primary data storage place. And Amazon CloudWatch logs is used to monitor, store and access log files from AWS resources like EC2 instances, CloudTrail, Route 53, etc. Let's try to understand CloudWatch logs better with help of some features. Firstly, you can use Amazon CloudWatch logs to monitor your application and system log files. Let's say you have made a lot of errors while trying to deploy your application on cloud. In this scenario, you can use CloudWatch logs to keep track of your errors and send a notification to you when the error rate increases certain threshold so that you can make avoiding errors again. Then you have log retention. By default, logs are kept indefinitely. But CloudWatch provides you with an option where you can set the period between 10 years to 1 day. Then you have log storage. You can use CloudWatch logs to store your log data in highly durable storage. And in case of system errors, you can access raw log data from this storage space. And then you have DNS queries. You can use CloudWatch logs to log information about the DNS queries that Route 53 receives. Now let's have a look at few concepts regarding CloudWatch logs. Firstly, we have something called log event. So log event is just a record of activity that has occurred in AWS environment. It's straightforward. Then you have log stream. A log stream is a sequence of log events that have same source. Then you have something called log group. Log group defines group of log streams that has same monitoring and access control settings. By default, you have to make sure that each log stream belongs to one or the other log group. Guys, now let's try to understand CloudWatch logs better with help of this use case. In this use case, we are going to use Amazon CloudWatch logs to troubleshoot the system errors. You can see that I have 3 instances here and a CloudWatch agent which is monitoring all these 3 instances. So what CloudWatch agent does is it collects custom level metrics from all these EC2 instances, and then all these metrics and logs collected by the agent are processed and stored in this Amazon CloudWatch logs. Amazon CloudWatch logs then continuously monitors these metrics, as you can see here. By then, you can set an alarm which will send you notification when some sort of error occurs in the system. So whenever you receive a notification saying that some sort of error is there in your system, you can access the original log data which is stored in CloudWatch logs to find the error. So this is how you can use Amazon CloudWatch logs to troubleshoot the system errors. So basically you are having a look at original data so you can solve your problems faster and quicker. So this is it, guys.
Today in this session, we're going to discuss about the service AWS CloudFormation. So without wasting any more time, let's move on to today's agenda. So we'll start today's session by discussing why CloudFormation is actually needed in the first place. Once we're done with that, we'll move on to the what of what is CloudFormation actually. After that, we'll be discussing what things are needed to get started in the CloudFormation service. Now, among those things, you have a JSON document. So we'll be learning how to create a JSON document. So before that, we'll be seeing the structure of a JSON document. Once we learn the structure, we'll see how a JSON document actually looks like. So we'll see how a sample JSON document looks. And in the end, we'll be doing a demonstration. So in the demonstration, we'll be doing two demos. The first one will be a really simple one, and the other one will be a little advanced. Let's move on to the first topic, that is why AWS CloudFormation. So why do we need CloudFormation? So for example, you have an application. Now most of you guys know that and we have done this in the previous sessions as well, that we created an application, right? Now that application is actually dependent on a lot of AWS resources. Now if we were to deploy and manage all these resources separately, it will take up a lot of time of yours, right? So to reduce that time or to manage all these resources, what if I told you have a service? Yes, you got that right. So you have a service called AWS CloudFormation. So using AWS CloudFormation, you can manage and create and provision all these resources at a single place. Now, this is what CloudFormation does. But now, what is CloudFormation exactly? So a CloudFormation is basically a service which helps you model and set up your AWS resources so that you can spend more time on your application rather than setting up and provisioning these resources, right? So basically it's a tool using which you can create your applications quickly. Also, you can create templates in AWS CloudFormation. Now, how do you create templates? Basically, you would be using the CloudFormation designer. You'd be putting in all the resources that are needed. You would be defining the dependencies of these resources, and then you'll be saving this design as a template, right? Now, what will you do with this template? This template can be used to create as many copies as you want, right? Say, for example, you have a use case wherein you want your application in multiple regions for backup purposes, right? So if you want that, you won't be implementing or you won't be creating each and every resource one by one in each of the regions. What you can do is you will create it at one place in CloudFormation, have that template in your hand and deploy that template in the other regions as well, right? So what will this do? So first of all, your replication will be very precise, right? So there won't be any changes in the copies that you have made. Second of all, you'll be doing that quickly because you don't have to do the process all over again. You just have to click a button and that template will be provisioned or will be launched in that region. So this is what AWS CloudFormation is all about. It makes your life simpler by handling all the creation and the provisioning part, right? So this is what is AWS CloudFormation. Now, how do we get started in CloudFormation? Since it's a very useful service, how can you as a user use this service? So let's move on. So for using the CloudFormation service, first of all, you need a JSON script. Now, why do you need a JSON script? Because you'd be creating a template, right, in the CloudFormation designer. You'd be using the drag and drop option and filling in the AWS resources, right? Now, when you'll be doing that in the backend, it'll actually be creating a JSON script. Now, what you can do as a user is if you're good in JSON, you can create your own JSON script. Otherwise, you can use the CloudFormation designer to create a template. Now, for creating a template, like I said, you need a JSON script. Now, what is a JSON script then? So a JSON script is basically a JavaScript object notation file, which is an open standard format. That means it is human readable. So you can read it as well as the computer. So if you don't need the programming knowledge for this, what you as a user would be doing is you would be designing your template in the CloudFormation designer, and that will automatically create a JSON script. You can do it the other side as well. Like I said, you can create your own JSON script and feed it in the CloudFormation designer. So this is how CloudFormation works. This is how you'll be using AWS CloudFormation. But then how can you learn the JSON script? So it's very easy. So basically you have to follow a structure in the JSON document. What is this structure? So that structure is like this. You'll be creating the following fields. So the first field will be the AWS template format version. So this will basically contain version of your template. Next up is the description. So description is a text only file or is a text only field wherein you'll be describing your template in words, right? So if I'm a user and I want to know what your JSON does, without reading your JSON script from beginning to end, I can read the description in simple English and understand what your JSON script will do, right? Then you have the metadata. So metadata will basically contain the properties of your template. Then you have the parameters. So any values that you have to pass to the template will be included in the parameters. Next comes mappings. So mappings would basically include the dependencies between your AWS resources. Then comes conditions. So conditions are basically the conditions that you'll be giving to your template when the stack will be created or while the stack is upgraded. So if your stack is being created or your stack is being updated, these conditions will be looked onto. Then comes outputs. So whatever outputs your template will provide or your creation or stack will provide will come in the outputs header. Then you have the resources field. So resources field will basically include all the AWS resources that you want to include in your infrastructure, right? Now, if you look carefully, you actually will be only dealing with the resources part, right? Because you will just be populating in the resources and creating the dependencies, right? So basically you'd be populating the resources part, and that is what it was all about, the resources part, right? Now, this is theory. Now, how does a JSON document actually look like, right? A JSON document looks something like this. So like I said, you'd be working on the resources field, right? So you'd be including the resources field, and in that, say so this JSON document is all about, if you had noticed, it's about S3, right? So you are basically including an S3 bucket, and in the type you'd be specifying the type of service that will be including this bucket, right? Like in this example, a JSON document doesn't know what service you're talking about. So you'd specify the name of the bucket, and inside the braces you'll be specifying which service. So over here you'll be specifying the S3 service. Don't worry, I'll be showing you guys this JSON document in a moment, but before that you should understand how a JSON document is structured, and this is what we're doing right now. Now guys, this is the CloudFormation dashboard. Now you have to create a stack over here, right? And for the creation of a stack you require a template. So first we'll design a template and then we'll create a stack. So this is my CloudFormation designer. Let's go back to our slide and see what we actually have to do. So this is our first demonstration. Herein we'll be creating a S3 bucket from CloudFormation. So we'll be designing a template around that for first, and then we'll be deploying this code, right? So let's do that. So let's go to our CloudFormation window now. So we have to create a S3 bucket. So we'll scroll down to the S3 service. So here is the S3 service. We'll click on the S3 service. We'll click on bucket and drag it over here, right? So this is our S3 bucket, guys. Now you can edit the name of the template over here. You can name it as Edureka CF. That means Edureka CloudFormation, right? So you specified that. Now this is your JSON code. Now you can compare the JSON code, guys. Let me make it a little bigger for you guys. Yeah, so this is the JSON code, guys. Now I didn't code this JSON script, right? I just dragged and dropped this bucket over here in CloudFormation and it automatically generated the script. Comparing it with the code that we have in our presentation, let's see. So we have resources. Yes, we have resources. We have the name of your bucket part. So basically this is the name of your bucket. And then it's a type wherein you'll be specifying the S3 service. So you have type and you're specifying the S3 service over here. Alright, so if you want to change the name of the bucket, we can do that over here. Let's specify it as Edureka CF. Alright, so we are done. This is it, guys. This is all you have to do. So now for running this in CloudFormation, all you have to do is click on this icon, create stack. Now this will lead me to this page, which is the create stack page. Now it has automatically uploaded this template to the S3 bucket and it has specified the URL here, right? You will click on next. You'll specify the stack names. Let's specify it as Edureka CF. Right, so you don't have to specify anything here. Let's click on next. Click on create. So you'll be seeing the events on this page. Let's refresh this. So it says create in progress, right? So my template is now being created into a stack, and that stack will have the AWS resource in it, which is the S3 bucket, right? So I think the time is enough. Let's refresh it and check if our stack has been created. So it's still in the creation phase. Let's wait. All right. So now it shows me that the create is complete. Alright guys, so let's go to our S3 service and check whether we have that bucket that our AWS CloudFormation created for us. So we'll go to the S3 service. And here it is guys. So this is the bucket that we created, alright? So you can see the time, it's March 28th, 2017. Today is March 28th, 2017, and the time is 7:05 and the time is 7:07 here. Alright, so this bucket has just been created by CloudFormation. So guys, like I said, it is very easy. It is easy to understand and to deploy as well. You basically just have to create a template and that is it. AWS CloudFormation will do the rest for you. And the cool part is that you can replicate the template as many times as you want, right? So it will save you the time. Okay, this demonstration is done. So we have created an S3 bucket using CloudFormation. Let's see what our second demonstration is all about. So now we'll be creating an EC2 instance in which we'll be deploying the LAMP stack, which means in that EC2 instance, you'll be installing Linux, you'll be installing Apache, you'll be installing MySQL, and you'll be installing PHP as well, right? So let's see how will we do that. So for our second demonstration, we will again go back to the CloudFormation console. We'll click on create stack. Now we have to launch a LAMP stack. So a LAMP stack is basically a sample template in AWS, right? So we can select the sample template and we'll click on view or edit template in designer. So a LAMP stack is basically an EC2 instance with Linux, Apache, MySQL and PHP installed onto it, right? You can see in the designer that you have only specified an EC2 instance and you've attached a security group to it. So you need the security group obviously because you have to connect to this EC2 instance, right? Now a LAMP stack is basically a web server, remember? Now let's see the template for this LAMP stack. So we discussed the structure of a JSON document, if you guys remember. So the first part was the AWS template format version, then you have description, then you have parameters. So parameters, if you guys remember, it is basically the values that you'll be passing to the template, right? Now if you're creating a LAMP stack, you'll be needing the database name, you'd be needing the database password, you'd be needing a lot of things, right? If you're installing MySQL, you'd be needing the username, you'd be needing the password. So all of that you can feed in here in the parameters. So you can specify the key name. So if you are connecting to the EC2 instance through SSH connection, you'd be needing a key pair, right? So you'll be specifying the key pair here. Then you'll be specifying the DB name and the other details. Now how will that look when you'll be creating a stack? So let's do that. We'll click on this icon which will now create a stack automatically. So you'll be prompted on this page, click on next. Then you will reach this page wherein you are feeding the entry, right? So you would specify the stack name. So this is by default. So stack name, so we'll be specifying the stack name first. So let us stack name be LAMP demo. And then we move on to the parameters part. So whatever you specified in the JSON parameters field will be reflected over here. So we specified DB name over here. So it is asking me for the DB name. So let's give it as Edureka and let's give the DB password as something. Can DB2 password, DB user as Edureka. Instance type as t1.micro. Why t1.micro? Because if you guys noticed in the template, we didn't specify a virtual private cloud. That is a VPC. Now all the instances which are launched these days, of which all the new instances which are there in EC2 are to be by default launched in a VPC. But since we are creating a JSON file and we didn't specify a VPC, you have to select an older version of your EC2 instance. So let it be T1. So T1 is an older version. It runs without a VPC as well. And then you have to specify a key name. The key name would basically be used to create a SSH connection to your instance, right? So our key pair was edureka_a. We'll select that and we'll click on next. Now SSH location is basically your IP address if you want to specify. I don't want to specify it, so we'll click on next. You don't have to enter anything over here. Click on next, confirm and click on create. Now is happening in the background is it is picking up that JSON file and is creating a stack for us. Launch an EC2 instance. It will then install Linux onto that. It will then install Apache, MySQL, and then in the end a PHP installation. So what we will do, once it says that the creation is completed, We will go and check if everything has been installed on our server by creating an SSH connection, right? So let's wait until this stack is complete. Alright guys, so as you can see in the events that the creation is now complete. So let's check that if our installation has been correct. We'll go to the EC2 instance. Now this is our instance which has just been created. We can check that it's been created on March 28th, right? So today is 28th. Alright. So now let's connect to this instance. So for that, we'll have to copy the IP address. This is the PuTTY software. For those of you who don't know how to connect to EC2, you'll be pasting your IP address here, right? And then you have this private file, right? So this is of the PEM extension. But the PuTTY software needs a PPK extension. So you have to convert this PEM file to PPK. That can be done using the PuTTYgen software. So this is the PuTTYgen software. So I'll be dragging this file here. Okay, it doesn't work. So we'll click on load, go to downloads, click on all files, select my PEM file, click on open, click on OK, and then click on save private key. So let's name it as edureka _a, click on save. So my file has been saved. We'll close it, go back to our PuTTY software. You have entered the IP address here. You'll click on SSH, click on authentication, click on browse, go to your PPK file, click on open, and click on open here. So now you'll be connected to your SSH, through your SSH to your EC2 instance. So any Linux installation on your AWS infrastructure, the login will be EC2-user. Alright, so you're in. Let's see if we can connect to our MySQL installation. So MySQL-edge, so it is on localhost -p port number 306, and then the user that we gave was edureka, and the password was this. Okay guys, so we are in. So that means we successfully created the edureka username which we specified in the JSON script. That works well. And then you specified, okay, we also specified that we need a database, right? So let's see if it is showing our databases or our databases have been created as well. Okay, so it has a database called edureka, right? So the JSON script worked well. Now the thing here to notice is that how granularly you can configure your JSON file, right? First of all, it launched an EC2 instance, then it installed Linux, then it installed MySQL, it configured its settings, and inside MySQL it gave you a database, right? So this is awesome guys. So this gives you the whole control of AWS just through JSON script, right? And this is the power of CloudFormation. Now if you want this infrastructure or whatever you have created right now to be replicated again to some other instance, that can be done with a single click of a button, right? And it is actually pretty awesome because if you were to install this LAMP stack on a server or on AWS, again, if you launch a EC2 instance with a Linux OS, installing Apache, MySQL and PHP may take time. It actually takes time because you have to open the console, you have to open the terminal, you have to enter the commands, and depending on your internet speed, you will install all those packages. So this is neat. It does everything for you automatically, right? So guys, this is what CloudFormation was all about. So I'll close this session. Let me go back to my slide. All right. So guys, we are done with the LAMP stack demo. Today's session is going to be on autoscaling and load balancer. So today I'm going to tell you how you can autoscale your resources so that they become highly available. And this is what we are going to do today. All right, so with that guys, let's start with today's session with the agenda for today. So guys, this is what we are going to do today. First, we're going to see what are snapshots and AMIs. So these are basically the entities using which you will be auto scaling your resources. So once you know what are snapshots and AMIs, we'll move on to why do we actually need auto scaling and what is auto scaling exactly. After that, we're going to see what is a load balancer, and towards the end we'll be doing a hands-on, which is going to be very interesting because I don't think there's a demo out there which can show you the kind of demo that I'm going to show you today. All right, and if you think about it, guys, if you're thinking about moving to the cloud industry, auto scaling and load balancing are the very important topics in this in this domain, right? So you should know about them. So if you have been so if you don't know about them, please pay attention today because you're going to gain a lot of knowledge today. All right, moving on, guys, let's start with the first topic, which is snapshots and AMIs. So let us see what are those. So I guess most of you are aware of what an EC2 instance is. So for those of you who are not, an EC2 instance is just like a raw server. It's a fresh piece of computer that you have just bought. It's just like that, all right? So on that computer, you can choose any operating system that you want. So once you have the operating system, you can install any kind of software on it. All right, so you have to install every time you launch a new an EC2 instance, you have to install all the required softwares on it. All right, but there's a workaround. What if you want a specific configuration of EC2 instance? Say you want 5 EC2 servers which are exactly like this, like each other, right? So one way of doing that would be to launch a new instance every time, install the required packages every time, and going about it, right? The other way of doing it would be to actually create an image of once you will be configuring your EC2 instance, and after that you'll be creating an image of your EC2 instance, and then using that image you can actually deploy 4 more EC2 servers. All right, so this image is basically what is an AMI. So AMI, which is an Amazon machine image, is nothing but an executable image of your already existing EC2 instance, right? But before an AMI can be created, there's a thing called snapshot. Now, what are snapshots? Snapshots are nothing but the copy of the data, the copy of the data that you have on your hard drive. So basically, if you have your C drive, right, and you want to copy your C drive, you copy your C drive onto some external drive, so that becomes a snapshot. But if you can boot from that external drive so that to your whole operating system comes up on some other machine, then it becomes an AMI. So this is basically the difference between the two. A snapshot is not a bootable copy, an AMI is a bootable copy that you have. All right, so I hope you got the difference between what is an AMI and what is a snapshot. So I'll repeat it again, and you use an AMI to basically replicate an EC2 instance again, so that you don't have to do the configurations all over again. Right, so now you'd be wondering, we were to talk about what is auto scaling, what is load balancing, why do we need AMIs? But be patient, you'll be clear with everything with the session. All right, moving on, guys, let's now discuss why do we need auto scaling. Now before that, guys, now the way I'll be going through this session is I'll be explaining you each topic and then I'll show you it in the AWS console. All right, so we just discussed what are snapshots and what are AMIs. So let me quickly show you how you can configure or how you can create an AMI of an already existing EC2 instance in the AWS console. So give me a second. I'll just go to my browser and my AWS console. So guys, this is my AWS console. I hope it's visible to you. So the first thing that you'll be doing is you'll be going on to your EC2 console. All right, so in your EC2 console, you will have all your servers that are running right now. Right, so for the sake of simplicity, I've already deployed 2 servers, which are server 1 and server 2. Now I have configured them both with Apache so that they can they can host a website, right? So let me quickly show you how the website actually looks like. So if I'll go to this particular IP address of server 1, this is in path server 1. Right, so this is how the website looks like. Right, similarly for my server 2, if I go into my server 2, this is how my server 2 will look like. Here it is. All right, so these are my two servers. Now what I want is I will create an exact copy of these servers so that they can be replicated. All right, so when I say replicated, everything from softwares to this website will be copied onto an image, and that copy or that image, when I will deploy it, it will be deployed inside one more EC2 server in which I don't have to do anything. This website will be there. I just have to go to the IP address and I can see this website. All right, so now what I'll be doing is I'll be creating an AMI of both these servers. So let's create an AMI for server 1 first. I'll select the server 1, I'll go to actions, I'll go to image, I'll click on create image, and all I have to do is give an image name for it. So let me give the name as live server 1. Right, this is my image name. I'll click on create image, and that is it. It takes in your request for creating an AMI and it does that. Right, pretty simple. Now similarly, I'll be doing it for server 2 as well. I'll select server 2. I'll go to image, I'll create an image, and I'll name the image, say, live server 2. So once I've done that, you can see the images in your AMI tab. So if you look at over here in the images section, you can look at AMIs. If you go to your AMIs, you can see there are two images which are just being created, which are in the pending state as of now, and they are live server 1 and live server 2. Now using these images, you can create any kind of server that you can create the exact same server with just a click of a button. All right, you don't have to configure anything much. All right, so this is how you create an AMI. Pretty straightforward, guys. Let's move on and discuss why do we need autoscaling now. So you learned how to create an AMI. Let's go ahead and understand autoscaling and see how they are connected to AMIs. All right, so say you have an application, you have a website, and every machine, now this website is hosted on some server, guys, right? And servers are nothing but machines. Now every machine has its limitation, right? For example, say this machine is say around 8 GB and say i5 processor. So say it can host around 100 people, right? Only 100 people can come to this website and easily navigate inside the website. But if more than 100 people comes in, this computer or this server becomes slow. All right, so say there are 100 people as of now and they are trying to access your website, and they can easily access it. Now your website becomes a hit overnight. All right, and now a lot of people are trying to access your website, which makes your server overburdened. Now, in this scenario, you can do only one thing, that is deploy more servers and distribute the traffic equally among those servers so that the requests can be handled. All right. Now, this thing is a manual task, and manual is a big no in the IT world, guys. So we invented a service called autoscaling, and using autoscaling, what happens is it actually analyzes the kind of load which is coming in, right? And it deploys the servers according to that. So say around 300 people are coming in, and it sees that you need 3 servers to handle those kind of requests. It'll do that automatically. Right, and that is where your AMI comes in, guys, because the new servers that you'll be launching, those new servers have to be taken out of some template, right? So the first server has to be the exact copy of the the second server has to be the exact copy of server 1. The third server as well has to be the exact copy of server 1, right? And that is where the AMI comes in. So what basically happens is, in the autoscaling service, you basically attach your AMI which you created, and using that AMI, it deploys more servers, right? This is why AMI is significant, or this is how AMI is related to autoscaling, and this is why do we need autoscaling. Let's move ahead and just give us a definition that what autoscaling exactly is. So like I said, whenever your load increases and you have to scale automatically up and down, you use autoscaling. So it's not only about scaling up, that is when your load increases, say 3 or 4 servers you have deployed, and when your load decreases, still 4 servers are there to sitting idle, right? So that is not the case. With autoscaling, you can also scale down as per your needs. You can configure everything which you can imagine about scaling up and scaling down in the autoscaling properties. Right? So this is why we need auto scaling. Now, one more thing that you need with auto scaling is, if you would have noticed, I said the number of servers that gets deployed in the auto scaling. Say there are 4 servers which get deployed during auto scaling. Right? Now the traffic has to be distributed equally. Right? So this traffic which has to be distributed has nothing to do with auto scaling. It has to be done by a separate entity, and that is what we are going to discuss in the next section. But before that, let me show you how you can configure the auto scaling properties and attach the related AMI so that the related servers are launched. All right, so let me go to my AWS console. So here am I, and as you can see, the AMIs have already been created. They are live server 1 and live server 2. Now what I'll be doing is I'll be creating auto scaling groups, or I'll be configuring the auto scaling properties so that these servers can be auto scaled as and when required. Right? So before that, I actually have to create a launch configuration. Now, what is a launch configuration? So if you look at the AMI, guys, you have only specified what kind of data should be there in your server. What you have not specified is what kind of machine you should launch every time there's a need. All right, so that is exactly what you do in launch configuration. So you have the data, but you don't have the information about the kind of machine that you want to launch. So that kind of stuff you will be specifying in the launch configuration. So what I'll be doing is I'll click on create launch configuration, and now it'll give me a wizard as same as that of any EC2 server. Right, in the EC2 server, I had to choose an operating system, right? So same, it will give me the wizard, but I don't have to go here. I'll have to go to a separate tab which is called my AMIs. Right, so I'll select my AMIs, and now I'll select the newly created AMI the AMI which I just created, which is say we are creating a launch configuration for our server 1 right now. So I'll select the live server 1. I'll click on select, and now it will ask me the kind of the configuration that I want for my server. Right, so I need a t2.micro because we are doing a demo today. Right, so we don't need much of computing power, so we just have to we'll select t2.micro and we'll name our launch configuration a thing. So let's name it as live server 1. Right, and the IAM role is not required, and I'll click on next. Now it'll ask me for adding the storage, so 8 GB is enough for an Ubuntu machine. I'll go to configure security groups. Right, and in these security groups, I just have to add the HTTP rule because I have to connect to all the instances that I'm launching. Right, so I'll select the HTTP rule from here. Right, and I'll click on review. So that is it, guys. Nothing else has to be configured here. All right, and it is asking me to check everything that I've just configured. Everything seems fine. I click on create launch configuration. Now it will ask me for the key pair. Right, so every server which will be launched, it will be associated with the key pair which you will be specifying here. All right, you can create a new one if you don't have already. I already have a key pair, so let me choose my key pair. So that is Hemant_2, and I acknowledge that I have this key pair, and I'll create the launch configuration. It just takes a second or two to do that, and we are done. Alright, so now we have created a launch configuration. We have specified what kind of machine we want. We have specified what kind of data should go into that machine. Now we'll be creating the auto scaling group in which we'll be specifying in which cases we want to auto scale. Alright, so let's create an auto scaling group now. Alright, so it has automatically picked up the launch configuration that we have just created, that is live server 1. Right, let's name this group as live server 1 group. Right, and what is the initial size that you want in your launch configuration? That is the minimum number of servers that you want, so let it be 1. And remember, guys, this is the most important part. When you are creating a launch configuration, ensure that you're doing it in your default VPC to be on the safe side, because there are a lot of settings that you have to do if you create a VPC on your own, and that becomes a hassle. All right, so if you accidentally delete your default VPC, which I did, right, so you have to contact the AWS support team and they'll help you out with it. they'll basically create one for you. You cannot create one on your own. All right. So always ensure that you are in your default VPC whenever you're creating your auto scaling group. All right, so now I'll be specifying the subnets. So basically you have to select a minimum number of 2 subnets, right? I'll be not getting into what are subnets, because then it'll be like a 3-hour session. We'll click on configure scaling properties. Now over here you can specify the properties that I was talking about. The when do you want your server to scale, right? So over here you can specify the average CPU utilization. Now what do you mean by average CPU utilization? Say there are 4 servers running as of now, right? So it takes the average of all the 4 servers, right? And if the average goes beyond whatever number you have specified here, say I specified 70 over here, right? So in that case, whenever the average CPU utilization will go beyond 70, it will launch one more server. Similarly, if it goes, I can configure one more property here which says if it goes below 20%, like scale down from one server. All right, so if there are 5 servers and the CPU utilization has gone less than 20%, it'll scale down from one server and come down to 4 servers. All right, and you can also set how many seconds should it wait. Say the traffic is spiking down and up like too frequently, right? So for that, what you can do is you can set a time. So if the 20% mark has been not crossed till say like 5 minutes, then it will scale down a server. Or if the 70% mark of the CPU utilization has been crossed over 5 minutes, it will then only scale up. It will not scale up if at only once for only 1 second it becomes 71%. All right, so you can specify all of that over here, but since I cannot load test my instance over here, I'll just keep it at its initial size, which just means that it'll, even if I delete my instance, that is one instance has to be there in any case. If I delete the instance, it will automatically launch it again. All right, so we'll select the keep this group at its initial size, and we'll go to configure notifications. So I don't want to configure the notifications, neither the tags. I'll click on review and I'll click on create auto scaling group. All right, so I've successfully created an auto scaling group for my live server 1. All right, similarly I'll do the same steps for my server 2 as well. I'll click on create auto scaling group, and I'll select a launch configuration which was there for my server 2. So I've not done that, so let's create a launch configuration first for our server 2. We'll go to AMIs and we'll select the server 2 part here. Alright, so I've selected server 2. I'll do the same steps that I did earlier, right? So let me give it the name as live server 2 group. I'll click on add storage, configure security group. Over here I'll add the HTTP rule, click on review and launch configuration, select the key pair, acknowledge it, create launch configuration. I'm doing the same steps, Skype. I'm not doing any new thing here. I've created the launch configuration. Now I'll create the auto scaling group, which is live server 2 group, right? And then the VPC, as I said, should be default subnets, a minimum of 2 subnets you should select. I'll click on scaling properties. I'll keep it at initial size, configure, review, and create the auto scaling group. All right, nothing much, guys. So same things that I did for my server 1, I've done for my server 2 as well. All right, so since I've created an auto scaling group, if you go to your EC2 dashboard, you would notice that 2 more servers are now being deployed. All right, so you can actually identify them over here. See, these 2 servers are being initialized. So these have just been created by your auto scaling group, because we've specified that a minimum number of 1 server should be there at all times, right? Now if you try to go to the IP address of this server, right, you will see that it will have the exact same settings for my EC2 instance. So this is my server 1. right? So as you can see, a new instance got created, but with the exact same settings. I didn't have to do anything. It automatically created an instance with the same settings. All right, and same is the case with server 2 as well, guys. If I go to my server 2 and try to access it, I'll see the same things over there as well. So I'll show you in a bit. Yeah, so this is my server 2. All right, so my autoscaling group is functioning fine. So let us come back to our slide now. So we are done with autoscaling. Now, like I said, you need to have an entity which will equally divide the traffic between the servers that you've just deployed. All right. So they say I've created two autoscaling groups, guys, as of now, right? And why I've created a second autoscaling group, I will tell you in a bit. But for now, understand that there is an autoscaling group. All right, and inside that autoscaling group, say there are 5 servers, and if a person is coming in, or a customer who has logged on to your website is coming in, how would his traffic be treated? How would he know which server to go to, right? So there comes in the third entity, which is called the load balancer. So what load balancer does is, a load balancer, your customer will basically be coming to your load balancer, and the load balancer will decide based on the usage of your servers that which server is more free, and then will give the connection to that server. All right, so this is basically the role of a load balancer. So like I said, a load balancer is a device that acts as a proxy and distributes network or application across a number of servers. Now, I've been saying it repeatedly that your servers are actually your traffic is actually distributed equally among the servers, right? But in a few moments, I'll tell you that there is one more way of distributing your traffic. All right, so before that, let me again stress on the point that this was your auto scaling group, guys. This is just the example that I took in the beginning, right? So there are like these set of users, and they're trying to access your website, and they are being routed to these servers. So this routing is actually done by a load balancer, right? Now, like I said, the traffic which is distributed, it is distributed in two types, right? The first type would be to equally distribute them among the number of servers. Like say there are 5 servers, so it will distribute it among the 5 servers. But if there are there are two kind of servers now, so your load balancer can identify what kind of request is being made by your user. For example, in your website or in your application, you have a part wherein you can process the image, right? And you have a part where you have your blogging section. All right, so if you want to process the image, you want your traffic to go to a different set of servers which are auto scaled at their own in their own auto scaling group, right? And if you have the blogging section, you have a different auto scaling group which is auto scaled at a different with a different auto scaling group, but you want everything to go from one single link. So the way to do that is using an application load balancer. So let me just repeat what I just said. So say this set of servers, they host your image processing part. They do all your image processing, and these set of servers, they host your blogs that you have on your application. All right. A user comes in, he just logs on to your website, and he goes to a URL which says, say, edureka.co/image. All right. If he goes to /image, your load balancer will see, okay, he's asking for the image kind of content, so he should go to this set of servers, because these servers serve the image purpose. And if you go to edureka.co/blog, your load balancer will identify, okay, this user, he is asking for the blog content, so he should go to this set of servers. All right, so all of that is done using your load balancer. If you compare it with the classic load balancer, it does not have that kind of intelligence, right? What it will do is basically all the traffic that it has got incoming to it, it will equally distribute it among the number of servers that are under it. All right, but with application load balancer, you have this option wherein you can divide the traffic according to the needs of the customers. All right. Now, when you have divided the traffic, again, the same thing will happen here as happens in classic load balancer, that at this point, it will equally distribute the traffic among the number of image servers, right? And similarly, the people who want to access the blog, it will equally distribute the traffic among the number of people who want to access the blog server. All right. So this is what an application load balancer is all about. So classic load balancer was something which was invented earlier, and these days nobody uses the classic load balancer anymore. People are using application load balancer. All right, and that is what our demonstration is going to be all about today. All right, so enough of talks. Let's move on to the hands-on, that is the demo part. So let me quickly show you what we are going to accomplish today. So basically a user will come in, he will have the address of your load balancer, and if he asks for the image path, or say server 1 in our case, he will go to the auto scaling group of server 1. If he asks for server 2, he will go to server 2, but all of them will have the same address, that is using your address of your load balancer. All right, so this is what we are going to accomplish today. Now, for those of you who didn't understand that why did we create two auto scaling groups, is because we want these servers, that is the image processing servers, to be scaled as well, and at the same time we want the blog servers to scale as well. All right, so that is the reason we want we created two auto scaling groups. So I created a server 1, which you can imagine is for your image processing, and I created an auto scaling group for server 2, which you can imagine is for your blogging section. All right, having said that, guys, now let's move on to my AWS console and go to our load balancers. All right, so what I'll be doing now is I'll be creating a new load balancer, and that load balancer would be of the type application load balancer. So as you can see, I have two options here. Either I can create a classic load balancer, or I can create an application load balancer. So I'll go on with the application load balancer, and I will name it as live load balancer, and the scheme is internet facing. So since mine is a website that I want you guys to access, right, so it could be internet facing. Otherwise, if you are working in a company and that company wants a load balancer for their internal websites that the companies have, you can actually opt for an internal load balancer as well. But since ours, we have a website and we want that to be used, we will use the internet facing load balancer. All right, and the listeners, it's HTTP, that's fine. And the availability zones, like I said, you have to select a minimum of 2 availability zones, and you'll click on configure security settings. All right, so now you'll be specifying the security group. Right, so in security group, it's better to create a new security group. Remember, guys, don't include the default security group for your load balancer. It's a good practice to always create a new security group so that you can customize your rules according to your needs. All right, so I'll create a new security group and specify the HTTP rule, and I'll click on next. And now comes the part wherein we'll be specifying the targets. All right, now what are targets? Now in application load balancer, guys, targets are basically but auto scaling groups. All right, so target 1 would be your auto scaling group 1, your target 2 would be auto scaling group 2, target 3, target 4. You can have as many targets as you want, but in this wizard you have to specify a minimum number 1. Right, so we'll create a new target group. We'll call it as say auto scaling live auto 1. All right, and the protocol is HTTP, port is 80. We'll click on next, and I'll review everything. I think everything is fine, and I'll create this load balancer. All right, so we have not done all the settings, guys. I'll show you how to do all the settings. For now, we have just created a plain load balancer. All right, so I have created a load balancer which is pointing to a target group 1, and that target group is not pointing to my auto scaling group as of now. All right, we will do that now in this part. So we have created, I just created a target group called live auto 1. I'll create one more target group which will be called live auto 2 for my second auto scaling group. All right, so I'll create this, and done. So I now have two target groups, that is live auto 1 and live auto 2. Now these two target groups have to point to my auto scaling groups respectively. Alright, now the way to do that, you cannot point them here. You have to go to your auto scaling groups, right? And in your auto scaling groups, you have to select the auto scaling group that you have just launched. So it is live server 1 group and live server 2 group. So I'll go to live server 1 group. I'll go to details, and over here you'll click on edit. All right, and inside edit you have this option for target groups. You don't have to specify anything in the load balancers. This option is only for classic load balancer, but we are creating an application load balancer, right? So we'll be specifying everything in the target groups. So for live server 1 group, we'll be specifying the demo server 1. So demo server 1 has already been it will be live auto 1, the target group that I just created, and live auto 1 is connected to your load balancer. So basically your load balancer will point to your target group, and your target group is now pointing to your auto scaling group 1, which are pointing to your instances. All right, so this is how it the visibility comes in. So I'll save it. The target group 1 is live server 1 group, and the target group 2 I'll be specifying in the second auto scaling group, which is here, that is live auto 2. All right, I'll save it, and let me quickly verify if I've done everything right. So this is live server 1 group, and this is live auto 1, fine. This is live server 2 group, and it is live auto 2, fine. So my load balancer can now see the auto scaling groups that I've just configured. So let me quickly go to my load balancer. Now comes the part, guys, wherein I'll be specifying when to go to auto scaling group 1 and when to go to auto scaling group 2. Like I said, we'll be specifying it using the kind of request that the user has made, right? So the way to do that is is by first selecting your load balancer and going to listeners. So once you go to listeners, guys, you will reach this particular page. Now in this you have to click on view or edit rules. Right, so once you click on view or edit rules, you will reach this page, which is kind of an if-else, if-else structured. So now what will you do is, so you can see that there's a default rule as of now, that any request which is made, it will go to live auto 1. All right, which means any request which is made, it will straight away pointed to the auto scaling group 1. Now we'll specify if the request if the user is asking for server 2, he should be pointed to server 2. So let us do that. The way we'll do it is like this. We'll click on add rules. We'll click on insert rule. And now I'll specify. So you have two options here. Either it could be the routing could be based on your host, that is the address of your website, or it could be based on the path. Now what is the difference? Say edureka.co, this is a host name, right? Now if I type in resources.edureka.co, it'll still point to my domain, but if I've specified resources.edureka.co, and if I write it over here and I specify it has to go to server 2, it'll go to server 2. Otherwise, if you type in resources.edureka.co, nothing will happen because you've not configured anything. Right? So that is the host path. With paths, the difference is that say you write edureka.co/blog. All right. So that /blog becomes the path. But with host, the thing is, the difference is resources.edureka.co. So that becomes one host name. Right? But with path, you're basically putting a slash and you are going into a particular folder. Alright, so you can specify the path here. Alright, it doesn't matter if you have not specified in your server for different you could the way you could have done the image processing and blog the other way around, rather than having it on two servers, was that you could have configured it inside two servers in your root directory. right? It could be server 1 for your image processing and server 2 for your blogs. But I don't want that, because your as distributed as your system is, it becomes more reliable, right? And that is the reason we have two different servers for two different set of things. So the way you can route your traffic to both these servers is by typing in the path. So say if I have to go to server 1, I'll type in server 1 slash star. So star basically means anything after server 1 can be accepted, but it has to go to, the request will be forwarded to live auto 1. Alright, so if I have server 1 in my path, anywhere in my path, it will go to live auto 1. So I'll save this rule. Similarly, I say that if it has server 2 in its path and anything after that, it has to go to live auto 2. Alright, I'll save it. And that is it, guys. Now my load balancer has saved its settings. Let's hope for the best and try executing it. So this is the link, guys, right? If you just type in this link, it'll by default go to server 1, right? So if I go to this link, you can see it is going to server 1 as of now. But if I specify slash server 1, it'll go to my server 1. And if I specify slash server 2, it'll go to my second server. Now you might be wondering that Hemant, you might have a different directory in your same server. So let me clear your doubt according to that. So what I'll do is I will go to my EC2 dashboard, right? And I'll go to server 1 and I'll quickly show you if what happens if I type in server 2 here. All right. So this is the IP address, right? So if I type in this IP address, I'm going to server 1. If I type in slash server 2, it will give me a 404 because there is no folder called server 2, right? Same is the case here. So if I go to this IP address, you can see server 1. If I don't specify anything after my address, it will still go to the same server that is here, that is this IP address, right? But if I specify slash server 2 over here, it will not be able to do so because this is not a load balancer, it is directly your IP address. But over here, if I specify server 2, it will redirect me to the second server. One second. Right, it will redirect me to the second server. And that is all that I need. Alright, so with one address, you are actually pointing to two servers, which will be solving your two problems. Now the real life use case, like I told you, it could be for different kind of tasks. Say you have a blogging section on your website and you have an image processing section on your website. If you want two different servers to host your two different services, you can do that easily using a load balancer. Alright guys, so with this I conclude my session for today. Today in this session we'll be talking about cloud security. Without making any further ado, let's move on to today's agenda to understand what all will be covered in today's session. So we'll start off this session by discussing the why and what of cloud security. After that, we'll be seeing how we can choose between a public, a private and a hybrid cloud. After that, we'll see whether cloud security is really a concern among companies who are planning to make a move onto the cloud. So once you have established that cloud security is really important, we'll see how secure should you make your application. After that, we'll be looking into the process of troubleshooting a threat in the cloud. After that, we'll be implementing that process in AWS. So guys, this is our agenda for today. Let's move on to the first topic of today's session, that why cloud security is important. So let's take an example here and talk of three very popular companies, LinkedIn, Sony and iCloud. So LinkedIn in 2012 experienced a cyber attack wherein 6.5 million usernames and passwords were made public by the hackers. After that, Sony experienced the most aggressive cyber attack in history wherein their highly confidential files like their financials, their upcoming movie projects were made public by the hackers, right? And this made a huge impact on the business front of Sony. iCloud, which is a service from Apple, also experienced a cyber attack wherein personal or private photos of users were made public by the hackers, right? So guys, now in all these three companies, you can see there's a breach in security which needs to be addressed, right? So cloud security has to be addressed. It needs to be there in the cloud computing world. So since now we've established that cloud security is really important, let's move on to understand what cloud security actually is. So what is cloud security? So it is a use of latest technologies and techniques in programming to secure your application which is hosted on the cloud, or the data which is hosted on the cloud, and the infrastructure which is associated with the cloud computing, right? And the other part of this is that whatever security techniques or whatever techniques or technology that you're using to secure your application should be updated as frequently as possible, because every day new threats are coming up, right? Every day there are new workarounds to problems, right? And you should be able to tackle these problems or these workarounds, and hence you should upgrade your security as frequently as possible, right? Moving ahead, let's understand how we can choose between a public, a private, and a hybrid cloud. So we've understood that what cloud security actually is. Now let's talk in terms of security and understand how we can choose between a public, a private, and a hybrid cloud. So if you were to choose between these three infrastructures, what should be our basis of judging which cloud we should choose, right? So you would opt for a private cloud when you have highly confidential files that you want to store on the cloud platform, right? Now there are two stories, or there are two ways of thinking a private infrastructure. You can either opt for private servers or private infrastructure on your own premises, or you can look up for servers, dedicated servers by your cloud provider, right? So that all comes under the private infrastructure. Then we have the public cloud infrastructure. In public cloud infrastructure, you would basically use websites that are public facing. So say if you have a products page where you have application which can be downloaded by the public, so that can be hosted on the public cloud, because there is nothing that has to be secret over there, right? So things like websites, things like data that is not confidential and you don't mind public seeing it, can be hosted on your public cloud. The third infrastructure is the most important infrastructure, which is the hybrid infrastructure, and this is the setup that most companies go for, right? So what if there's a use case wherein you have private files, of highly confidential files, and a website as well, right? So if you have this kind of use case, you might go for a hybrid infrastructure, which is kind of best of both worlds. You get the security or the comfort of the private infrastructure and the cost effectiveness of the public cloud as well, right? So your hybrid cloud is basically, if you want your highly confidential be stored on your own premises and your website be hosted on your public cloud, this infrastructure would be hybrid cloud infrastructure. So basically you would choose a private cloud if you have highly confidential files, if you choose a public cloud if you have files that are not that important or files that you don't mind people seeing, and you would choose a hybrid cloud infrastructure if you want best of both worlds, right? So this addresses how we can choose between a public, private, and hybrid cloud. Moving on, let's understand whether cloud security is really a concern. So we have discussed that why cloud security is important. We've discussed what is cloud security, right? Now let's talk about whether this really makes sense, right? So if we say that cloud security is really important and there's no one who's actually thinking about it, there's no point, right? So let's see if companies who are making a move to the cloud actually think about cloud security. So here's a Gartner research on companies who are making a plan to move to the cloud or who has not moved to the cloud yet, right? So what are their concerns? Why are not they doing so? So the topmost reason listed by these companies was security and privacy concerns, right? So as you can see, these companies who want to make a move to the cloud are also worried about their security on the cloud infrastructure. And this makes it clear that cloud security is actually very important, right? Now, we've understood that cloud security is really important. We have understood that companies are looking for cloud security, are actually following the practices for cloud security. But now, how secure should you make your application, right? What is the extent to which you should make your application secure? So let us start with this line. So it is said that cloud security is a mixture of art and science, right? Why? Let's see that. So it's a science because obviously you have to come up with new technologies and new techniques to protect your data, to protect your application, right? So it's a science because you have to be prepared with the technical part. But it is art as well. Why? Because you should create your techniques or you should create your technologies in such a way that your user experience is not hindered. Let me give you guys an example. Suppose you make an application, right? And for making it secure, you think, okay, after every 3 or 4 minutes, I'll ask the user for a password, right? From the security point of view, it seems okay, but from the user's point of view, it is actually hindering his user experience, right? So you should have that artist in you that you should understand when to stop or till where should you extend your security techniques. And also you should be creative as to what security techniques can be implemented so that the user experience is not hindered. For example, there is a two-step authentication you get that when you're logging into your Gmail account, right? So if you know your password, that is not enough. You should have an OTP as well to log into your Gmail account, right? So this might be hindering with user experience to some extent, but it is making your application secure as well, so, right? So you should have a balance between your science and the art part that you're applying on cloud security. Moving on, let's now discuss the process of troubleshooting a threat in the cloud. So let's take an example here. So like you're using Facebook, right? And you get a random message from some person saying there is some kind of story, like you usually get that while you're using Facebook, right? That such and such thing happened and click here to know more, right? You get that similar kind of message here. And by mistake, you actually click on that link. You didn't know that it's a spam and you click on that link. Now what happens is all the users that are there or all your friends on the Facebook chat gets that message, right? And they get furious as to why this kind of spam message is there in their inbox, right? And you get scared. Now you get angry as well and you have to bring your frustration out on Facebook. So you contact Facebook and you get to know that they already know the problem and they're already working on it and they're near to their solution. Now, how did they come to know that there is this kind of problem and needs to be solved, right? So basically cloud security is done in 3 stages. So the identification process or the threat identification process is done in 3 stages. The first stage is monitoring data. So you have AI algorithms which know what a normal system behavior is. And any deviation from this normal system behavior creates an alarm. And this alarm is then monitored by the cloud experts or the cloud security experts sitting over there. And if there's a threat, they see there's a threat, they go to the next step, which is gaining visibility, right? So you should understand what caused that problem, right? And or who caused that problem precisely. So your cloud security experts look for tools which give them the ability to look into the data and find or pinpoint that statement or pinpoint that event which caused this problem, right? So that is done using gaining visibility stage. And once we have established, okay, so this is the problem, then comes stage 3, which is managing access. So what this basically will do is it will give you a list of users. In case we are tracking the who, it will give you a list of users who have access and we will pinpoint the user who did that, right? And that user can be wiped out of the system using the managing access stage, right? So these are the stages which are involved in cloud security. Now, if we were to implement these stages in AWS, how would we do that? Let's see that. So the first stage was monitoring data, right? So if you have an application in AWS and you are experiencing this same kind of thing, what will you do for monitoring data? So you have a service in AWS called AWS CloudWatch. Now what is AWS CloudWatch? So basically it's a cloud monitoring tool. So you can monitor your EC2 and your other AWS resources on CloudWatch. How you can monitor them? You can monitor the network in, network out of your resource, and you can also monitor the traffic which is coming on to your instance, right? You can also create alarms on your CloudWatch. So if there's deviation from normal system behavior, like I said, So it'll create an alarm for you. It'll escalate the event and alert you about that thing so that you can go on and see what that problem actually is, right? So this is cloud, the monitoring tool, right? So this was about AWS CloudWatch. Let me give you a quick demo of how the AWS CloudWatch dashboard actually looks like. Okay guys, so this is your AWS dashboard. So now for accessing CloudWatch, you can go under the management tools. Here is CloudWatch. You'll click on CloudWatch. Now over here you can monitor anything, right? You'll go to metrics and you can see there are three metrics over here. You can monitor your EBS, you can monitor your EC2, you can monitor your S3, right? Now say suppose I want to monitor my EC2. So as you can see, so I have two instances running in my EC2. One is called for batch instance and the other is called WPS instance, right? Now these are all the metrics which are there. So I can check metrics for my WPS instance for network in. I can check the disk read ops. So let me select the network out metric and there'll be a graph over here. So I can see this graph. And as you can see, between 6 o'clock and 6:30, I experienced a surge in my traffic, right? So basically this is how you monitor your instance in CloudWatch. And you have all these default metrics to check how your instance is doing in your AWS, right? So this is what CloudWatch is. You can also set alarms here, right? So if you go to alarms, click on create alarm, you'll go to EC2 and you can select your metric from over here. Now I've selected discrete bytes over here. Now once I do that, it'll ask me if there's a time range to which I want to monitor that instance, right? Okay, let's not set any time range. Let's click on next. So when you click next, you will be prompted with this page. So you can set your alarm name. You can set your alarm description here, and then you can specify that for what read write number you should get this alarm for, right? So you'll be setting that over here. After that, you'll go to actions. So once an alarm is triggered, where should that alarm go? Who should that alarm go to, right? So you can set it over here. Now, whenever the state is alarm, right, what should we do? So when the state is alarm, you can send your notification to your SNS topic. Now what is SNS? So basically it's a notification service. We'll be discussing what SNS is in the next session. Don't worry if you don't understand. So basically for now what you can understand is that SNS is a protocol wherein you set, if you get a notification, what to do with that notification or whom to send to that notification, right? So if there's a topic called notify me in SNS. So in notify me, I have configured an email address that is my email address, that whenever a notification comes to the SNS service or the notify me topic to be precise, it sends an email to me, right, with that message. So I'll get a message with this alarm that such and such thing that has happened in CloudWatch. Now you do whatever is required. The other thing that you can do over here is in the same SNS topic, you can also configure a Lambda function to be executed, right? Now what that Lambda function will do, so say suppose I configure the metric to be of CPU usage, right? And I say whenever the 40% metric is crossed, create an alarm or like go to an alarm state, and it notifies the SNS notify me topic about this. In the notify me topic, I can configure a Lambda function to clear all the background processes in that EC2 instance, right? So if I do that, the CPU usage will automatically come down, right? So this becomes a use case that you want to launch a Lambda function whenever your CPU usage goes beyond 40%, right? And hence this is the way you would do it. So this was about CloudWatch. There's nothing much to it. You create alarms and you monitor metrics, right? Moving ahead, let's move on to the second process, which is gaining visibility. So for gaining visibility, basically you have to track your whatever activity is happening in your AWS account. So there's a service in AWS called CloudTrail, right? So the CloudTrail service is basically a logging service wherein each and every log to each and every API call is made. Now, how is it useful? Let's talk about the security perspective, right? So your hacker got access to your system. So you should know how he got access to your system. So if you have a time frame, say he got access to your system or you started to face the problem, say around 4 o'clock, right? So you can set the time between 2 o'clock and whatever the time is right now and monitor what all has been going around. And hence you can identify the place where that hacker got access to your system, right? Now this is the part where you'll get to know who that person actually is, or you can isolate the problem or which caused that. So if you take Q from our Facebook example, over here you can actually pinpoint who is responsible for those spam messages, because you'll all have those logs, right? You'll see the origin of those messages. Now, once you've done that, the next step is managing this guy out of the system or wiping this guy out of the system. But before that, let me show you guys how CloudTrail actually looks like. So let's go back to our AWS dashboard and go to our CloudTrail service. So again, under the management tools, you have the CloudTrail service. You'll click on the CloudTrail service and you will reach this dashboard. All right, so here you have the logs. So as you can see, you can set the time range here, but I'm not doing that. I'm just showing you the logs. So even for logging into my console, it is showing me that I've logged into my console at this time on this date, right? So every event is logged, guys. Every event that is happening on your AWS console is being logged. So let's talk about the S3 bucket. So somebody deleted a bucket and that has again been logged, right? So it happened at 7:38 p.m. on 28th of March 2017, right? So any activity, any kind of activity which happens in AWS will be logged over here. Okay guys, so this was about CloudTrail. So let's go back to our slide and move ahead in today's session. So like I said, so now you've identified who is responsible for your problem, right? So now the next step is managing access, right? So now you should be able to throw that person or remove that person from the system. So most of the times what happens is, like if you take our Facebook use case, so basically there was a user who triggered that problem, right? So the two things that you have to do is, first of all, you have to remove that spam from your system. So you've got to know where it originated, so now you start wiping it. After that, you have to debar that user from doing it again, right? So from the source, you'll get to know who that user is. Now, using managing access, you will actually get access to do all that, right? So if you talk about AWS, this service is called AWS IAM. So what AWS IAM does is, it basically authenticates that particular service. Now, you are a root user, right? So you can do anything. But what if you have employees, and obviously all employees will not have all the rights, right? Now, what if you want to give granular permissions to your employees? Now, for like in our example, what if one specific employee is capable to track down this problem, right? Or track down what has to be done. So you can give that particular person the rights. How? Using IAM, right? So IAM is used to provide granular permissions. It actually secures your access to the EC2 instances by giving you a private file, and also it is free to use, right? So let's see how IAM is used. So let me go back to my AWS console. Okay guys, so this is my AWS dashboard. I'll go to the security, identity and compliance domain and I'll click on IAM, right? Now over here, I'll click on roles. Now I can see all the roles which are there in my IAM, right? So since I would have identified which role is creating a problem, so I'll go to that role. So for example, I have a problem in say AWS Elastic Beanstalk EC2 role, right? I'll click on this. Now once I click, I will be getting this screen. So now I can see the permissions, the trust relationships, the access advice and the revoke sessions, right? So I'll go to revoke sessions and I'll click on revoke active sessions, and hence I'll be able to wipe out that user from accessing my AWS resources, right? So this is how you use IAM, guys. Now one more thing that you can do over here is you'll go back to your dashboards, go to roles. Now like I told you guys, you can actually create a role for a person who will be able to access restricted things on your AWS account, right? So let me quickly show you how you can do that. So you'll click on create new role and you'll give your role some name. So let's give it hello. over here, right? Click on next step, go to role for identity provider access, right? And now you can select how that user of yours will be accessing your AWS account, right? So allow users from Amazon Cognito, Amazon, Facebook, Google ID. All right, so let's select this. Now let us select Facebook and let's give it some random application ID, right? So anyways, not going to create this role. I'm just telling you guys how to do it, right? So basically you get your application ID by Facebook. Over there you'll be, since you are using Facebook to authenticate that guy to your AWS account, you'll get an application ID by going on to graph.facebook.com. You can do all of that over there. Okay, so that is not the concern. You'll enter the application ID and click on next step, right? So you'll get that policy document. So whatever you configured in your text boxes has actually been created in a JSON file, right? So you don't have to edit anything over here. Click on next step. Now you have to attach a policy. Now what is the policy? So policy is basically what all permissions you want to grant that user, right? So if you want to grant him the execution role for Lambda, you can do that. You can grant him the S3 execution role, right? So whatever policy that you create, you can actually create a policy in your IAM, right? I'm not going much in details of this because all of this is covered in your IAM session, but I'm showing you guys because I just told you guys how this can be done. So let me show you how it can be done, right? So you'll select whatever policy you want and click on next step and review it and create that role. This is it, guys, right? So you can actually select a policy, whatever policy you want that role to have, and hence, so policy is basically a permission that you want that role to have. So if he gets a permission to just review your instances, he'll be only able to review your instances. Okay, one more thing I want to make clear is that you don't have to give your security credentials to that guy anymore, because now you'll be specifying that user will be able to connect to Facebook. Okay, so also you have a part here wherein you can specify what specific user can access it, right? So I can type in my name here, and if I'm being logged in through Facebook, if my username is Hemant Sharma, only then I'll be able to connect to my AWS account, right? Now this is ID, right? I can also set the locale parameter, right? So ID I think is fine, wherein you will be adding the ID of the guy whom you want this AWS account be accessed by, right? So you all have Facebook IDs, right? So you all have to just punch in your Facebook IDs over here, click on next step, and then you'll be able to access this AWS account if I create this role right now with the policies that I'll be attaching to your role, right? So this is how you use IAM, guys. Let us go back to our session. Okay, so these are the three services, guys. So you have IAM, you have CloudTrail, and you have CloudWatch, using which you can control or you can actually see what is going on in your AWS account. So let's go ahead and start with today's session with the first topic, which is why do we need access management? Alright, so to discuss this topic, let's understand it using an example. Say you have a company in which you have a server, and this server has everything in it. It has all the modules in it, and it gives you it gives different users the permission to use the different servers, right? Now in your company, first of all, you should have an administrator which will have all the rights to access the server, right? So nobody in the today's IT world works on the root account, right? So there has to be an administrator account. So first we will create an administrator account with all the permissions. Now tomorrow, say a UI developer comes into your company, right? Now a UI developer will only work on the graphical tools, right? So he should only be allowed the graphical tools and not some other tools. Maybe he shall not be given the internet access or something like that, right? Maybe he's not giving the PowerPoint access, maybe he's not given some folders access, some drives access, anything like that. So all of that can be defined in the server by the administrator, and specific rights will be given to a UI developer, right? Similarly, if after that a business analyst comes in, so he should only be able to access the analytics module which is there in your server, right? He should not be able to get into the UI development part, or he should not be able to see the other aspects of what is there in your server, right? So each and every user or each every role will have specific rights assigned to them, right? And this is done by policies which are in turn given by administrators, right? So this is what access management is, that giving each role the specific rights that they deserve. And this is what we are going to accomplish today in AWS, right? So this is why we need access management. Let's go ahead and understand how can we accomplish this in AWS, right? So to accomplish this in AWS, you need a service called IAM. You have a service called IAM which uses this concept of access management and allows you to give it to your users who are going to use your account, right? So what is IAM? So IAM is basically a service from AWS using which you can give permissions to different users who are using the same AWS account that you have created, right? So in a company in any company, be it, you don't have to have 2 or 3 AWS accounts. You can have one AWS account on which a number of people can work, right? For example, you can define that maybe a developer would like to work on your AWS account, and he should only have the EC2 instances, or he should only work on the EC2 instances. You decide that, right? So you can define a policy like that, that only the developers will only be able to access the EC2 instances on your AWS account. Similarly, if say a database administrator comes in, so he should be only able to access the DB instances on your AWS account, and so on, right? So all of that is possible using IAM. But IAM is not only about creating users and creating policies. It's more, there is more to IAM, right? And hence we'll be discussing the different components of IAM now. So let's go on and see what are the different components. So there are basically 4 different components in the IAM service. So the first service is user, then we have groups, then we have roles, and then we have policies. Right? So the way we are going to go about these are, first I'm going to explain you each role or each service in IAM, each component in IAM, and then we're going to see how we can execute them or create them in the AWS console. Right? So let's start with the users. So the very first time you actually create a AWS account, that is basically the root account that you have created, right? So there is no user inside it. So why do we basically need a user? You need a user because you are supposed to give permissions to someone, right? So say I first of all want to give administrator rights to a user. Right? So you understand, you have to have an entity first to which you can assign permissions, right? So these entities are called users on AWS. So any person who wants to access your AWS account has to be added as a user in IAM, and then you can attach different policies onto that user. Right, so this is what user is all about. Let me go to my AWS management console and show you how you can create a user in IAM. All right, so give me a second. Alright guys, so this is my AWS sign in page. Alright, so this email ID, when you log in through your email ID and your password, that is basically your root account. So what I'm going to do right now is I'm going to log in using my root account and first create a admin account for myself. Alright guys, so you should never work in your root account. You should always have an administrator account to work in. The root account should only be used when there is an emergency. Say you have been logged out of your administrator account, only then you should be using your root account. So the first thing that you should do when you enter your root account is go to IAM, which is just right here. Go to IAM and then you will have this dashboard thing, right? Over here you can see there is a thing called users. You will click on users and you will click on add user. Alright, so now it will ask you for the username, so you can provide a username. Say I'll add my name first, so that be Hemant, right? And what kind of access do I want to give to this particular user? So there are basically 2 kinds of access that I can give. First is the AWS management console access, and then we have the programmatic access, right? So what is these two? if you want to, so there are basically two ways you can access the AWS resources, right? You can either access them using APIs, that is using your code. Say you have created an application which is interacting with your AWS resources, right? So in that case, if you're interacting with the APIs, using the APIs, that is called the programmatic access. Right. Secondly is the AWS Management Console access. That is when you are using the AWS website to actually deploy resources or create or remove policies or whatever. Right. So that is called the AWS Management Console access. So for my user, I'd be giving it both the accesses, that is programmatic access and the management console access. Also guys, when you enable the programmatic access, basically you get the access key and the secret key as well. What are these? I will be explaining you in a bit. Alright, so we have selected both of these options and then move ahead to choose the password. So do you want an auto-generated password or a custom password? I'll choose a custom password since I'm creating account for myself, right? So I'll choose a custom password. And do I want to reset the password on my first login? No, I don't want that. So I'll click on next permissions. All right, so what kind of permissions do I want my account to have? I will be configuring that over here. So as of now, there are no groups. There is no existing user that I can copy from. So I'll attach existing policies, and since I want to attach the administrator access, that is the first policy over here, I'll select that and click on next. Alright, so you can review all the settings that you did over here and click on create user. This will create a new user in your AWS account. So as you can see, I have got my access key ID and a secret access key. Now guys, the secret access key, you only get it to see only one time when you have created your account. So it is essential that you store your access key and your secret access key once you get this page. Alright, so let me store it quickly. So this is my access key ID. Why we are copying it, you'll get to know during the session. Don't worry. And my secret access key, which is this, so let me copy this and paste it in the notepad. Alright, so don't worry, you might be thinking that I've exposed my secret key to you, so I'll be deleting this account afterwards, so you don't have to worry about that. Alright, so I've got my access key ID and my secret access key, so that is done. Now what I'll be doing is I'll be logging out from my root account and logging in this user account that I just created. Alright, so one more thing that you have to be very careful of, that you will not be logging in through the same login page that you just saw, right? So you'll have to log in through a different login page now, and the URL for that is this, right? So you'll be logging in through this link from now on. So whenever you create a user, if you want them to log into your account, you have to give them this link to log into, right? So let us copy this link over here and log out from our root account. Alright, so I've logged out. I'll close this and I'll come here and go to this particular link. Alright, so once you reach this particular link, it will be asking you the account name, which will be self-filled by your link, right? So you have to give your username now, which is Hemant, and then the password. So I'll type in the password that I've given it and click on sign in. So now I have basically signed in to the user that I've just created on my root account. Right, so I no longer have to use my root account. I can basically lock away my root account for emergency purposes. I'll be using my administrator account from now on. I can do everything from my administrator account that could be done from my root account as well. But there are cases wherein you get locked out from your administrator account. In that cases, you will be needing your root access. All right. So moving on guys, so I'll go to IAM now. So as you can see, we have created a user and we have logged into that user. And if I go to IAM now, you can see that it will show that one user has been created. that is here. All right. So let's get back to our slide and discuss the next component. All right, so we've discussed what are users. Let's move on to the second component, which are groups. All right, so whenever you create users, they can also be combined into groups. Now, why do we need groups? We need groups because, say, let's take an example. So say you have 5 users, and these 5 users have to be given identical access, right? Say these 5 users belong to the development team, and the developing team has to have some common access that they all will have, right? Now, one way of doing this would be that I will go to each and every user and attach a policy that they need, right? The smart way to do this would be to include them inside one group, and to that group I will only once I will attach the policy, and it will apply to all these 5 users, right? So these are why groups are very important. Now, how we can create groups, let me shed a light on that. So you will go to you can see, you can click on groups over here, and what you'll do basically is you'll click on create new group. All right, so let me give the group name as live demo. All right, and I'll click on next step. Now it'll ask me the policy that I want to attach to this particular group. All right, so say for example, I just want this group to be able to access the S3 service from AWS. So what I'll do is I will select the policy which says Amazon S3 full access, and I'll click on next step. Now this policy basically tells you that you're going to only use the S3 service in the management console and no other service. All right, so I'll click on create group, and now whichever user I will be putting inside this group will have this property. All right, so I don't have to configure the policy for any user now. So what I'll do is I'll create a new user now. So say I create a new user saying test. All right, and then I'm not giving him the programmatic access, I'm just giving him the management console access. All right, I'll click on this and I'll give it a custom password, and then I don't want him to reset his password. I'll click on next, right? And now it is asking me whether I want to include it inside a group. So yes, I do. I want to include it inside the group that I've just created, and I'll click on next and review all the settings that I've just did and click on create user. Alright, so the test account has just been created. Now, as you can see guys, in the case of my account which I created, I got an access key and a secret access key, right? So in this case, I'm not getting any because I didn't select the programmatic access. Only when you select the programmatic access, it will give you the key so that your application can actually interact with the services that you have launched. Alright, so I've created a test user successfully. Let's log into this test user. So I will type in the URL that has been given to me. Right, now when I'll reach this page, I'll enter the username as test and the password as what I have entered, right? And I'll click on sign in. Now with this, you can see that I will now be able to see the management console. The management console will exactly look like how it was used to see, how I used to see it in my root account or my administrator account. But when you will try to access, say, a service which you have not been assigned to, say for example, I only have access to S3 right now because I've deployed it in the group where it has only the access to S3. If I try to go inside EC2, let's see what will happen. Right, so it says you're not authorized to describe running instances. As a matter of fact, I'm not authorized to see anything on my EC2 page. All right, so that is because I don't have access to the EC2 dashboard. But let's see if I can see the S3 dashboard. So I'll quickly go to S3, and if I have the S3 access, I'll be able to see all the buckets which are there in my S3. And yes, I do. So let me go inside a bucket and delete something so that, all right, so let me delete an object from this particular bucket. So yes, I can delete it. All right, so let me check if what happens if I delete or I detach this particular policy from that group. All right, let's see what happens. So I'll go to IAM and I'll go to groups. I'll go to this particular group and I can see that the policy is listed over here. What I'll do is I'll click on detach policy and let's see what happens now. Right, so I'll go to management console. So if now I try to access S3, it will show me that access is denied. Right, so I no longer have access to the S3 service on my AWS console. So this is how you can control access to different users. You can revoke access, you can include access, right? You can do all of that in IAM. Alright, so let us come back to our slide to discuss our next component. Alright, so we've discussed what are users, we've discussed what are groups. Now let's come down to roles. Alright, so roles are similar to users, but roles are actually assigned to applications. Alright, so users are actually assigned to people, right? So whenever you have a developer in the company, you will assign him the developer roles, right? But when you have roles, roles are basically assigned to applications. How? Let me explain you. Say you create an EC2 instance, and inside that EC2 instance you're hosting a web application. Now that web application has been designed in such a way that it has to interact with your S3 services, for example, that we'll be doing today. I'll be showing you the demonstration today for this, right? So say that application has to interact with the S3 service. Now if I want that application to interact with the S3 service, I have to give it permissions. And to give it permissions, I will use role. So I will create a role wherein I will specify that this role can access the S3 service, and I will attach this particular role to that particular EC2 instance in which my application is hosted. And in that case, my application will be able to interact with the S3 service. Right? It might sound complicated, guys, but it is very easy to implement. Let me show you how. So what I'll do now is I'll go back to my management console, which is here. All right, I'll go to the dashboard and say I'll go to roles now. All right, so I'll create a new role. Now roles can be assigned to any AWS service which is listed here. What I'll do is I'll assign it to I'll create a role type of EC2. All right, so I'll select Amazon EC2. And what type of role do I want to apply it to? I want to say have the access to S3, right? So I'll select Amazon S3 full access over here and I'll click on next step. So it'll ask me the role name. So let me specify the role name as edureka_1, right? And I'll click on create role. So with this, a role has now been created, but mind you guys, I've not attached this role to any EC2 instance, right? So what I'll do now is I'll go to my EC2 console. So over there, I already have built an EC2 instance. It is stopped, so I'll start it and attach this particular policy to that EC2 instance. All right, so my EC2 instance name is Hemant_1. So here it is. I'll go to actions, I'll start this particular instance, right? And what I can do is I can attach the policy using instance settings. It says attach or replace IAM role. I'll go here, I will go to the drop down and select the role that I've just created, which is edureka_1. I'll select that and I'll click on apply. Now with this, what will happen is my role is now my EC2 instance is now configured to interact with the S3 service in this particular account. Alright, so any application that I deploy in this EC2 instance will be able to interact with the S3. Okay, so I don't have to specify any access key, any secret access key. If you're still confused with that, be patient. We are getting on to where do we actually use these keys and where do we not. Alright, so this is what your roles are all about, right? So roles, like I said, they are for resources in AWS. Users are for people. Roles and users are similar things. You attach policies onto them, and they basically identify a particular instance or a particular person as the owner of that particular service, right? So I've discussed what roles are. Let's move on and discuss policies. So if you think about it, guys, we've actually been dealing with policies, right? So policies are nothing but permissions that you give to your with whatever role or user or group that you have created, right? So for example, I want to give the EC2 instance access, right? So that EC2 instance access is basically a policy that I'll be attaching to the user or to the roles. All right, let's see how we can create policies, guys. So I'll go to my management console, I'll go to IAM, right? So you can either create policies or you can actually use the already existing ones. So there are a couple of policies that have already been created in your AWS account, but you can go ahead and create your own policy as well. All right, so let me show you how. So say for my test account, what I'll do is I will go inside test account, all right, and I will add permissions, and I will attach existing policies directly, and here I am, guys. So now you can create policies as well. So you see the tab over here, guys, it says create policy. So if you feel the kind of policy that you want to create is not listed over here in the default policies, you can actually create one. And creating a policy is very easy, guys. You'll just click on create policy and you will see this page. Alright, so you'll have three options. You can either copy an AWS managed policy, that is a default policy. You can create your own policy by just typing in the JSON code. And if you're not comfortable with coding, what you can do is you can use the policy generator. Now, what is policy generator? Let me explain you. So with policy generator, you just have to select what effect do you want. Do you want it to allow it or do you want it to deny it? Right? So say I want to allow the EC2 service to this particular test account. All right, so I'll go to EC2. All right, here it is. I selected EC2. What kind of actions can he perform? Say I want to give him all the actions. You can do anything with EC2, and resource name is basically a particular resource. So with ARN you can identify a particular resource. So I don't want a particular resource to be assigned to him. I want he can access every resource in EC2, right? So I just add star for all of them, right? And click on next step. So with this, as you can see, it has automatically created a policy document for you. All you have to do now is click on create policy, and it will create the policy for you. So as you can see, there are 18 customer managed policies. There are now 19. So I can go here and select the policy over here. All right. So if I go to my user now, which is test, and go to permissions, I will just click on add inline policy, click on select, again go to EC2, select actions, all actions, right, and put it to star. So I'll click on add statement, click on next step, and click on apply policy. So a policy has been applied on the test user that it can actually access the EC2 instances now. So if I go to my test user now, in which I was not allowed to access the EC2 instances, I can actually use the EC2 instances now. So if I go to EC2, you can see it will not give me the access denied thing, right? So I can access all the instances over here as if I was using the root account, but only for the EC2 service, right? If I go to S3, you can see I will still have the access denied page because I've not been assigned the access to this particular service. All right. One more thing, guys. If what if you add an allow and a deny policy together inside a group? What will happen then? So in that case, so since I have allowed EC2 access, what I'll do is I'll deny EC2 access as well in this particular user. So I'll create one more policy, and I'll say deny. I'll select EC2. Right? I'll select the actions as all actions. I'll give the resources all, add the statement, and click on next step, apply the policy. So now I have denied EC2 instances as well, and created and allowed EC2 instances as well. What do you think will happen now? So if now I try to go to EC2, let's see what will happen. So it will say you're not authorized to use EC2 anymore, because whenever you're creating policy, guys, you either get the allow option or the deny option. If you have selected both of them, it will always prefer the least permission that you have given. So in our case, that is the deny option, right? So it will always deny the case even if you have allowed it in the same user, right? If you have mentioned that that particular service has to be denied to that particular user. All right, so this was about policies, guys. Let me come back to my slide. So we have discussed what are users, what are groups, what are roles, and what are policies. Let's go ahead and discuss the very important part of authentication, which is called the multi-factor authentication. So what is multi-factor authentication, guys? So multi-factor authentication is basically something like OTP that you get when you're logging into your Gmail account, right? So you enter your Gmail email ID, you enter your password, and when you click on continue, it'll ask you for your OTP, right? So same is the case here as well. You can configure your AWS account in such a way that you will enter your username, you'll enter your password, and when you click on login, it'll also ask you for a code that has to be given to it. Now that code is basically the multi-factor authentication thing that we're talking about. So there are basically two layers of security now. One layer is a password, and second layer becomes the code that you'll be entering, right? Now with AWS, there is an application called the Google Authenticator, right, which you can use to create a virtual multi-factor authentication device. Now, for those of you who already are using multi-factor authentication in your companies, so there's a thing called Gemalto, right? So people who work from home and they have to connect to their company's network, the way you connect it is using a Gemalto token, right? And so those of you who are from the IT background, you can relate to it, right? But if you want to go through a simpler way, you can actually create a virtual multi factor authentication device. And to create that in your AWS is pretty simple. You just have to download an application called Google Authenticator on your phone, and you have to connect that application to your AWS account, and that is it. Now it might sound tough, but it's very simple. Let me show you how. So you will basically go to your AWS management console, and you will go to the particular user that you want that multi-factor authentication to be assigned to. All right, so for example, I want it to be assigned to the test user, right? So what I'll do is I'll go to users, I'll go to test, right? And in the security credentials tab, I will have this page which says assigned MFA device. So it says no as of now, so I'll assign it a device. I'll click on edit, and now it'll give me an option between a virtual MFA device and a hardware MFA device. Now I have to choose among the two. So since I said you can create a virtual MFA device very easily, so I'll select the virtual MFA device. And now it is basically asking you to install the application on your phone. So we have already done that. Let's click on next step, and now you'll be presented with the screen. So basically now what you have to do is you will be logging into your Google Authenticator app, and you will be scanning this barcode from your phone. So let me show you how. Let me connect my phone to the computer so that you can see the screen. Give me a second. All right, so this is a screen to my phone, guys. So what I have to do now is I'll have to go to the Google Authenticator app, and it'll ask me to create an account. So I'll click on begin, and once I have that, basically now I'll have to scan the barcode from my mobile. So the way to do that is I'll click on scan a barcode, and then I'll scan this barcode over here. right? It might take some time, so be patient. Yeah, so it's done. Now you're all set, right? So you'll just click on done, and now you have to enter two codes that you will be receiving uh, on your Google Authenticator. So basically, these codes change from every 30 seconds, right? So I have to enter these codes over here. So it's 204 and then 020 and 353. 020 353, and I have to enter the next code as well. So let's wait for the next code, and it's 127891. So I'll enter that over here as well. So it's 127891, and that is it, guys. So now I'll click on activate virtual MFA, and it says the MFA device was successfully associated. So I'll click on finish, and that is it, guys. You're done, right? So now if I log out from my test account, that is from here, right? This is my test account. So if I log out from here right now, and try to log in again using test, so I'll come to my normal login page, right? So I'll enter my username and my password, which is this, and now I'll click on sign in. So now it will ask me for the MFA code. So let's see what is our MFA code as of now. So it has changed to 734552. So let us enter that, 734552, and click on submit. So with this, I'll now be able to log in to my AWS console using the test account, which I configured using the administrator account in IAM. Alright, so it's very simple, guys. You can actually get world-class security with the click of a button using IAM. Alright, so we have seen how we can do multi-factor authentication. Let's move on to the hands-on part now. So this is what you guys have been waiting for. So just give me a second so that I can configure everything on my end. Alright, so what we'll be doing now is I have created an application which can interact with the S3 service. Alright, so using that S3 service now, we'll be uploading files to our S3 console. And how we are going to do that? First, we are going to do that using localhost, and that is where our secret keys and my access key comes in. And then we have assigned a role to our EC2 instance, right? So we'll be accessing that website using EC2 without the access key and the secret access key, and we'll see, do we get the access to our S3 service or not? All right, so let us do that. So now what I'll do is I will go to my localhost application. So guys, this is basically my application. What I have to do is I'll choose a file, I'll upload a picture from any sample pictures, and then it'll upload it to a particular bucket that I've defined in S3, and the bucket looks something like this. Right, so that bucket's name is quarantine demo. So let me show you the bucket. So as of now, I think there are some objects. So let's delete those objects. So here it is. This is the bucket quarantine demo. So I have like 3 objects over here as of now. So let's delete these objects. Alright. So now what I'll be doing is, this is the code for my application, guys. Alright, so in this code, as you can see, I have not specified the key and the secret key as of now. So I'll get the key and the secret key from here, right? So let me quickly, so let me show you without the secret key and access key, how is this localhost website functioning. So if I try to upload a file as of now, say this is the file that I want to upload, I'll click on upload image and I'll get an error, right? Because it is not authenticating itself to the service that I want to go to. So now I'll add the credentials, that is the key and the secret key. Now the way to do that is like this. So I'll copy it and I'll paste it here. I'll delete this and this as well, not required. And now I'll paste my key and my secret key, which is this, right? So I'll copy the key over here and then my secret key as well over here. And now I'll save it. And if I try to access my localhost website now, I should be able to upload a file, right? So if I try to upload the file now, it says well done, S3 upload complete. So these credentials that I've just entered are basically credentials for my Hemant account. So if you want to see where did I get these credentials from again, you can basically go to users, you can go to your user and you can go at security credentials, and over here it will list you the access key ID. It will not list you the secret access key because it is only available once. You can only use it once, copy it once, you will not be able to see it again. And if I make this particular key inactive from over here, and if I try to upload anything again, I will again get an error because without the keys my account will not be authenticated to the S3 service. So as you can see, it says invalid access key because it is not valid anymore. Alright, so I can make it active again, but that is not required as of now. So what I'll do now is I've already configured this website on the EC2 console. Alright, so let me go to my EC2. Right, here it is. So remember in the starting of the session we created a role for S3 full access, right? So that role has been attached to my EC2 instance. So let me show you the website. Here it is. Alright, so I can access the website on my EC2. Now if I choose a file as of now and I try to upload the file, I'll be able to do so because my policy has been attached. Now let's see what happens if I detach the policy, right? So I'll go to this and I'll select no role, click on apply, yes, detach. And now if I try to upload a file again, as you can see, I see a blank page, which basically means that an error has occurred. Alright, so I am not able to upload any file because my role has been detached from my EC2 instance. So if I want it to be working again, I'll just simply go here, go to actions, settings, attach the role, that is this, click on apply, and it will again work. Right, I'll choose a file, say this file, upload the image, and it will work again. Works like a charm, right? So that is it, guys. You don't have to configure much. You just have to have the knowledge of IAM, and with that you can do complex procedures with the click of a button, and you don't have to swear about it. All right, you might be wondering, did I change anything in the code when I uploaded it to EC2? So you don't have to do anything, guys. You just have to delete the credentials, key, and secret, and you will upload the code as it is. You don't have to change anything. If it doesn't have the key mentioned in this particular function, it will basically get those keys from the metadata of EC2, and metadata is the place where your role is actually assigned, or your role is actually attached, right? So if it doesn't find the key in the code, it basically goes to the metadata and picks the key from over there. All right, so guys, that is it for the demo part.
In this session, we will be discussing about Amazon Redshift, the most popular cloud-based data warehouse. So let me run you through today's agenda quickly. We will begin by taking a look at traditional data warehouse. We'll be discussing its underlying architecture and the disadvantages of using traditional data warehouse. And then we'll move on to our today's topic, which is Amazon Redshift. Here, we'll be discussing its architecture, its key concepts, its unique features, and the advantages of using Amazon Redshift. And finally, we'll be doing a demo on Amazon Redshift. In this demo, we'll see how to import data from Amazon S3 to Amazon Redshift and perform queries on this data very easily. So I hope that was clear to you guys. Let's get started. I'm sure you know what a data warehouse is. You can think of data warehouse as a repository where data generated from your organization's operational systems and many other external sources is collected, transformed, and then stored. You can host this data warehouse on your organization's mainframe server or on cloud. But these days, companies are increasingly moving towards cloud-based data warehouses instead of traditional on-premise systems. And to know why, we need to understand the underlying architecture and the disadvantages of using traditional data warehouses. So let's begin by looking at architecture part. It is important to understand where the data comes from. Traditionally, data sources are divided into two groups. First, we have internal data, that is, the data which is being generated and consolidated from different departments within your organization. And then we have external data, that is, the data which is not getting generated in your organization. In other words, that is the data which is coming from external sources. So this traditional data warehouse follows a simple three-tier architecture. To begin with, we have bottom tier. In bottom tier, we have a warehouse database server, or you can say a relational database system. In this tier, using different kind of backend tools and utilities, we extract data from different sources and then cleanse the data and transform it before loading it into data warehouse. And then comes the middle tier. In middle tier, we have OLAP server. OLAP is an acronym for Online Analytical Processing. This OLAP performs multidimensional analysis of business data and transforms the data into a format such that we can perform complex calculations, trend analysis, and data modeling on this data very comfortably. Finally, we have top tier. This top tier is like a front-end client layer. This tier holds different kind of query and reporting tools using which the client applications can perform data analysis, query reporting, and data mining. So to summarize what we have learned till now, traditional data warehouse as a simple three-tier architecture. In the bottom tier, we have backend tools using which we collect and cleanse the data. And then in middle tier, we have tools, which is OLAP server, using which we transform the data into the way we want. And then finally, top tier, in which using different query and reporting tools, we can perform data analysis and data mining. Moving on to the disadvantages of traditional data warehouse concept, there is this leading US business service company, and this company is running a commercial enterprise data warehouse. This data warehouse has data coming from different sources across different regions. The first problem that this company faced was when it was setting up a traditional data warehouse. As we discussed earlier, the architecture of traditional data warehouse is not very simple. It consists of data models, extract, transform, and load processes, which we call ETL, and you have BI tools sitting on top. So this US-based company had to spend a lot of money and resources to set up a traditional data warehouse. Data warehouse, which was initially 5 terabytes, was growing over 20% year over year, and it was expected that there might be higher growth in future. So to meet this continuously increasing storage and compute needs, the company had to continuously keep upgrading the hardware. Again, this task of upgrading the hardware continuously involves a lot of money, manpower, and too many resources. So, autoscaling in traditional data warehouse is not an easy concept. And since the company could not meet all the storage and compute needs easily, it was facing a lot of performance issues as well. And finally, the company had to deal with increasing costs. Initially, they had to spend a lot on setting up data warehouse. like that to spend on hardware, manpower, electricity, security, real estate, and deployment costs, and many other. And as their data warehouse grew, they had to spend again to meet storage and compute needs. So to sum it up, setting up a data warehouse and deploying it and managing it later involves a lot of money and resources. Moreover, auto-scaling in traditional data warehouse is not an easy concept. Because of all these reasons, many companies are increasingly moving towards cloud-based warehouses instead of traditional on-premise systems. So guys, in this session, we'll be dealing with one of the most famous cloud-based data warehouse provided by Amazon, which is Amazon Redshift. In simple words, Amazon Redshift is a fast, scalable data warehouse that makes it simple and cost effective for you to analyze all your data across your data warehouse and data lake. Guys, I have a definition which is put up on the screen, and I have few words which I have highlighted over there. So as we progress through the course of this session, we'll know what those words exactly mean. So let's ignore them for now. But there are certain key concepts which you should be aware of when you're dealing with Amazon Redshift. So we'll discuss them now. Amazon Redshift Dataware is a collection of compute resources which we call nodes. And these nodes, when organized into a group, they become clusters. Each of these clusters run an Amazon Redshift engine and it contains one or more databases. So this cluster has a leader node and one or more compute nodes. As for the leader node, it receives queries from client applications and then it passes these queries and develops a suitable query execution plan. And then it coordinates the parallel execution of these plans with one or more compute nodes. Once the compute nodes finish executing this plan, again the leader node aggregates the results from all these intermediate compute nodes and then sends it back to client application. Then we have compute nodes. You can think of these compute nodes as a compute resources that execute the query plan which was developed by leader node. And when they are executing this plan, they transmit data among themselves to solve many queries. These compute nodes are further divided into slices, which we call node slices. Each of these node slices receive part of memory and disk space. So the leader node distributes data and part of user query that it receives from client application to these node slices. And all these node slices work in parallel to perform operation and increase the performance of your Redshift data warehouse. So to say, we have leader node, we have compute nodes and node slices. But how do they interact with client application? That is the question here. So I have these client applications, basically BI tools, or it can be any other analytical tools, which communicate with Amazon Redshift using drivers like JDBC and ODBC. JDBC refers to Java Database Connectivity Driver. It is an API for programming language Java. Then we have ODBC. It refers to other database connectivity driver and it uses SQL to interact with leader node. So basically using these drivers, client application sends a query to leader node. Leader node, on receiving the client application's queries, it passes these queries and develops a suitable execution plan. Once the plan is set up, compute nodes and compute slices start working on this plan. They transmit data among themselves to solve these queries. So once the execution is done, leader node again aggregates the results from all these intermediate nodes and sends it back to client application. So this is the simple explanation of Amazon Redshift concepts. Moving on, when you launch a cluster, you need to specify the node type. Basically, we have two types of nodes. Dense storage nodes. These are storage optimized and are used to handle huge data workloads. And basically, they use hard disk drive or HDD type of storage. And then we have dense compute. These dense compute nodes are compute optimized and they are used to handle high performance intensive workloads. And they mainly use solid state drive or SSD kind of storage. But there are three things that you should keep in mind when choosing one among them. Firstly, you should be aware of the amount of data that you want to import into your Amazon Redshift, and then the complexity of the queries that you run on your database, and the need of downstream systems that depends on the results of these queries. So, keeping these three things in mind, you can choose either dense storage nodes or dense compute nodes. So guys, that was the architecture and its key concepts. Now, we'll take a look at few reasons as to why Amazon Redshift is very popular. As we discussed earlier, setting up a traditional data warehouse involves a lot of money and resources. But it's very easy to set up, deploy, and manage a suitable data warehouse using Amazon Redshift. On Amazon Redshift console, you will find Create a Cluster option. When you click on that option, Amazon Redshift asks you for certain details like the type of node you want to choose, the number of nodes, the VPC in which you want to create your data warehouse, user ID, password, and many other details. Once you feel that you have given the right set of details, you have an option which says launch the cluster. And one click, your data warehouse is just created. So with one click, you can easily create a data warehouse in Amazon Redshift. Once your data warehouse is set up, Amazon Redshift automates most of the common administrative tasks like managing, monitoring, and scaling your database. So you don't have to worry about managing or scaling your database needs. So that's how easy it is to develop or set up a data warehouse using Amazon Redshift. We also learned that auto-scaling is difficult in traditional data warehouse, but you can scale quickly to meet your needs in Amazon Redshift. Well, we already know that a cluster node has a leader node and one or more compute nodes. So if you want to auto-scale in Amazon Redshift, all you have to do is resize your cluster size. As we know, these compute nodes are like compute resources. So if you want to scale up, you can increase the number of compute nodes. Similarly, if you want to scale down, you just have to decrease the amount of compute nodes. Alternatively, we have something called single node and multiple node. In single node cluster, one node takes the responsibilities of both leader and compute functionalities. And the multi-node cluster contains one leader node and user-specified number of compute nodes. So suppose you want to resize your cluster and you are using a single node cluster, then you can change from single node cluster to multi-node cluster. Similarly, you can change from multiple node cluster to single node cluster when needed. So that's how easy it is to scale up and down in Amazon Redshift. Moving on, we learned earlier that while using traditional data warehouses, it's possible that the performance of your data warehouse might decrease. But with Amazon Redshift, you can get 10 times better performance than any other traditional data warehouse. It uses a combination of different strategies like columnar storage and massively parallel processing strategies to deliver high throughput and response times. So let's discuss these strategies one by one. Well, first we have columnar data storage. To understand what that is, first we should know row storage. Most of the traditional data warehouse and databases use this row storage. In row storage, all the data about a record is stored in one row. Okay, so let's say I have this database here. I have 3 columns and 2 rows. The first column contains a unique number associated with student. The second column contains the name of a student and the third column contains the age. As we already know, data is stored in form of blocks in databases or data warehouses. So as you can see in row storage, the block 1 contains all information there is about a particular student, his SSN, his name, and then age. So basically, it stores all the information that there is in a single row. So in the first block, you have information about first student, and in the second block, you have information about second student, and it goes on. Now the columnar storage. Again, I'm using the same database. Again, I have 3 columns and 2 rows. But column storage stores data by columns, with data for each column stored together. So again, we have blocks, but the first block here has all the data that is there in first column. So you have all the SSN stored in first block and all names stored in second block and all the ages stored in third block. So it goes on. There are a lot of advantages of using this column storage. Firstly, since in column storage, a single block contains same type of data, you can achieve better data compression. As you can see, columnar storage can hold values 3 times the records as row-based storage. Because of this, the number of input-output operations decreases. And thirdly, by storing all the records for one field together, columnar database can query and perform analysis on similar type of data far quicker than row storage. So this is how the concept of columnar storage, which is used by Amazon Redshift, provides us a better performance. And then we have massively parallel processing. I'm sure you might have heard of parallel processing in computer science. It's just that number of different processors work together or compute together or in parallel. Similarly, massive parallel processing in Amazon Redshift is nothing but clustering. We have already discussed this earlier. We have a cluster, and this cluster has a leader node and one or more compute nodes. And this compute nodes is further divided into something called node slices. So when this leader node receives a query, it develops an execution plan, and this compute nodes and compute slices work together or in parallel to execute this plan. And later, this leader node sends the results back to client application. So basically, this compute slices and compute nodes work in parallel to achieve better performance. Moreover, Amazon Redshift is also able to smartly recognize the data on nodes before running a query, which dramatically boosts the performance. So that's how we can get a 10 times better performance using Amazon Redshift. And then the cost. In traditional data warehouses, people had to spend a lot of money to set up and then later to maintain the data warehouse. But Amazon Redshift is the most cost-effective cloud-based data warehouse. If you remember, in traditional data warehouse, they had to spend on hardware, real estate, manpower, electricity, and deployment costs and many others. And as their data warehouse grew, they had to spend again on meeting the storage and compute needs. But in Amazon Redshift, we don't have to pay any upfront cost. So Amazon Redshift is most cost effective and it costs 1/10 of traditional data warehouse. You can start small for just $0.25 per hour without any commitments, and you can gradually scale up later if you need. In addition to all those advantages, Amazon Redshift allows you to query data from Data Lake. Data Lake is a storage repository that holds a vast amount of raw data in its native format until it is needed. So in Data Lake, you have data in different formats. You can load data from Amazon S3 into your Amazon Redshift cluster for analysis very easily. That is, from Data Lake, you can store easily into your Amazon Redshift. But it needs more effort and cost. Effort because loading data into Amazon Redshift cluster involves extract, transform, and load, which we simply call ETL process. And this process is very time consuming and compute intensive. And it's costly because uploading lots of data, cold data from Amazon S3 for analysis requires growing your clusters, which is again costly and requires a lot of resources. So as a solution, we have something called Amazon Redshift Spectrum, which acts as an interface between your Amazon S3 or Data Lake and Amazon Redshift. So you can directly query data stored in Amazon S3 or Data Lake with this Redshift Spectrum without need for unnecessary data movement. I hope that was clear. And finally, with Amazon Redshift, your data is safe and secure. It offers backup and recovery. So as soon as data is created or stored in Amazon Redshift, a copy of that data is made, and through secure connections, a snapshot of it is sent to Amazon S3 for later. So suppose you lose your data, or if you have deleted the data from Amazon Redshift by mistake, you can restore the data easily from Amazon S3 service. Amazon Redshift also provides you with an option to encrypt your data. So when you enable this encrypt option, all the data in your cluster, in your leader node and your compute nodes and node slices is encrypted, and this way your data is very safe and secure. So guys, these are all the advantages of using Amazon Redshift. So now you have a basic idea of its architecture, its various key concepts like clusters, nodes, leader node, node slices. Now it's time to work on a demo. In this demo, we'll see how to transport data from Amazon S3 to Amazon Redshift Data Warehouse and perform simple queries. So I hope that was clear to you guys. Let's get started. But the first thing, there are certain softwares which you need to pre-install so that you can start working on Amazon Redshift. First, suppose you want to perform queries on the data on Amazon Redshift, then you need a SQL workbench where you can perform your queries. And as we learned earlier, the client application need a connection to communicate with Redshift. So we need to install a JDBC driver. And for that JDBC driver to run, we need to have a Java runtime environment. So we have three things to install here now. I'll show you how to install each of them. And I have this Java runtime environment download link by softonic.com. So it says free download and you click on that, it'll be downloaded. You can store it anywhere. And once you're done with that, search for Amazon Redshift documentation. So here it is. Okay, not that. This one. And when you scroll down, it says Amazon Redshift get started. Click on that. And in the step one, we have prerequisites. Okay. Scroll down and it says in the step 2, you have an option where you can download or go to SQL Workbench website and download it. So click on that. And here it says build current version. And you have download generic packages for all systems. You can download it. Once you click on that, it'll start downloading. And there is one more thing, which is JDBC driver. Go back to documentation part. Scroll down and the step 4, you can see configure a JDBC connection. Click on that. It'll take to your page where you have JDBC drivers of different version. You can download the first one. Click on this and it'll be downloaded. So once all these three things are downloaded, store them in a file of your choice. Well, I have stored them on my desktop. I have this AWS folder and in that Redshift. So here's my workbench, a zip file. It was a zip file, so I extracted all the files. And then I have my JDBC driver here. Well, Java runtime environment isn't download, so that's okay. So I hope that was easy. So just install all these things and you're set to go. And we're back to our Amazon management console. I have previously used Amazon Redshift, so I have this Amazon Redshift in recently visited services. Anyway, you can search for Amazon Redshift here. Here it is. Well, it's taking time to load. Okay, this is my Amazon Redshift console page, and you have different kind of options on your navigation pane on the left side. And there are two ways to create or launch a cluster. First, you have quick launch cluster option and launch cluster option. This is the very easy way to launch a cluster. But suppose you want the freedom to specify all the details as in the VPCs, the security groups, different type of nodes, username, password, and all that, you can go for launch cluster option. Let's go ahead and explore that. So first it asks for a name, let's say my cluster, and database, DT1, and the port, this is default port, 5439 is the default port which will be handled by Amazon Redshift. Then the master username, let's say AWS user, and password. That's it. And confirm your password and click on continue option. So cluster details are done and dusted. Then you have node configurations. Well, for the free tier, you only have DC2 large. But suppose you have a premium membership, then you can choose any of this. For this DC2 large, this is the CPU capacity, memory, and storage. And the input output performance is moderate. You can go ahead and choose the cluster type. We discussed this. We have multi-node and single node. In single node, we have both the leader and the compute node responsibilities handled by single node. The multi-node, we have a single leader node and user specified number of compute nodes. Click on continue. And then here it asks for the VPC details, parameter group, and suppose you want encryption or not, and all the details. So basically, in this launch cluster option, you have the freedom to specify all the details. But for this demo, I'm going to use quick launch cluster option. So again, as for the free tier, I'm using DC2 large. And again, for the free tier, I'm using DC2 large type. It says there are 2 compute nodes. And let's retain the same cluster name. As for the master user, AWS user, now let me give the password. And the default port is 5439. And last option, we have to choose among the available IAM users or IAM roles. But the question is why we need a IAM role here. In this demo, I said that we're trying to import data from Amazon S3, but you need certain set of permissions to access data which is stored in Amazon S3. For that, we need to create a IAM role. So let's go back to IAM service. Let me close all these tabs. Okay. Here you have roles option. You can click on that and click create role. And since we're dealing with Amazon Redshift, select Redshift, Redshift customizable, and click on next permissions. So we want Amazon Redshift to access data from Amazon S3. So search for S3 here. And you have a permission which says Amazon S3 read-only access. Well, for this demo, this is an if, but there is one more permission which says Amazon S3 full access. So you can perform read and write operations as well. As for this demo, I'm going to choose this permission which says Amazon S3 read-only access provides read-only access to all the buckets in Amazon S3. And click on next review. Give your role a name. Let's say my Redshift role 2. And click on create role. So now our Amazon Redshift database has permission to access data from Amazon S3. Let's go back to Redshift console. Okay, let me refresh this. And now it's showing the role which has been created is showing here. So as you can see, unlike other launch option in this, I didn't have to specify much details, just the node type, the number of nodes, and then the master username, cluster identifier, and password, and the default database port. And you can click on launch cluster option. So with one click, you've easily deployed a database on Amazon Redshift. If you remember, when we tried to use this launch cluster option, we had option to select a default database or use or create our own database. But when you use this quick launch cluster option, a default database called dev will be created for us. So guys, this cluster has been created. So before we connect it to your SQL workbench, let's try to explore here. You need to make sure that the database health status and in maintenance status, everything is in green color. As for the cluster status, it should be available. And for the database health, it should be healthy. Only then you can make a perfect connection with your SQL workbench. So you have this icon here, click on that. Well, you get all the information there is about your cluster. Or you can just go ahead and click on this cluster. So this is the endpoint. This tells me all about how to make a connection with this cluster. I have this. When I click on that, it says publicly accessible, yes. And the username is AWS user. And the security groups, apparently it just shows the TCP rules which are set. So that's about the endpoint. Then the cluster name, you have cluster type, node type, and it shows the nodes and the zone and the date and time when it was created. And you have cluster version as well. On the right side, you have cluster status, which is available, database health healthy. So is it currently in maintenance mode? No. And then you have parameter group apply status, which is in sync with your database. And there are a few other features as well. But here you can see this VPC group. Click on that. Go for inbound and make sure it is set for TCP. Okay, edit. Make this custom TCP rule. And here 5439 custom. That's it. And click on save option. So that's the default port with which you can access the Redshift. And let's go back. Clusters. Okay, where were we? We changed the default group of VPC. So this is the URL with which you can connect to the SQL workbench. So let's copy this and paste it in our text file. I've pasted it over there. Well, if you're using ODBC connection, then you can use this URL. When you scroll down, you have capacity details of your entire cluster. It's DC2 large. So 7 EC2 compute units, total memory, storage, and platform. Okay. Let's go back to this IAM role. But I should have an IAM role option here. Let me see. Check it out. Okay. There's an option which says see IAM roles. You can copy this entire thing and paste it again in the editor so that while connecting it, it'll be easy for us to find it. Okay. Then, so now your cluster is created, your database or data warehouse is set up. Now you can just connect it with SQL Workbench and start working on it. So let's go back to the folder where I've stored my Workbench. Here it is. When you scroll down, there's a file which says SQL Workbench executable jar file. Open. So here it is. It's asking for a default profile name. Let's say new profile 1. Okay. Then driver. That was Amazon Redshift driver only, JDBC driver. And this was the URL. We copied it earlier in the editor, so I'm going to paste it over here now. This is the URL. Control C and paste it. AWS user in the password. Okay, that should work. Make sure that you select this auto commit, save it, and then click on OK. It says connecting to the database. Now it's successfully connected. So I can easily perform queries now. First, let's create some tables. Well, I'm using the sample database from Amazon S3. So you have this AWS Redshift documentation. Go back to that. And here it says get started. And in the step 6, you have this default SQL queries and tables provided. So you can go ahead and use that. I have it stored in my editor. So I'm going to copy. First, I'm going to create all the tables. Control C and paste it over there. Let's check what tables are there. First, we have user table. Well, this is like an auction data schema. So you have user table, many users, and you have category users, the category, different categories to which users belong to. And then you have date on which a particular event occurred. Then you have event table, all the details regarding an event. Listing, as in the items which are being sold are listed here, all the details about the items. Then you have sales, as in which user is buying, how much, which item, and all that details. So basically we have 6 to 7 tables. I'm going to select all that and say run option. So here it says table users created, table venue created, category, date, event, listing, and sales. So all the tables are easily created now. As for the next part, we need to copy the data or the data for the database from Amazon S3 to Amazon Redshift. Let's go back to the editor. And I have this copy command. I'll explain you the format. Control C. And let's paste it right here. Okay, let's explore this copy command. It says copy to the table users which you just created from this path. That is from the file which is stored in S3 bucket. But this is the credentials AWS IAM role which we copied to the editor earlier. Apparently, we're just giving a permission to access the data from S3. So we need to copy this IAM role here. And then we have delimiter. As in, let me go back to editor and show you an example. Okay. Let's say I have a data. Let's say I have name, Archana, space, some age, D, hobbies, So you can see this straight line. This is the delimiter, as in the thing which you're using to separate all the fields or the columns. So going back, so that's delimiter which separates the data. And this is region in which your S3 bucket is located. So that's it. But we have to replace the IAM role. This is the ARN of the role. I'm going to copy it. And wherever this is, you need to just paste it. Control V. Okay, we're done. Last one. So select everything and click on this execute button. It might take a while because the data set which was stored in Amazon S3 might contain large number of rows, so it might take a while. So as you can see, it states executing statement here. It says 1 out of 7 finished. So we have 6 more to go. So this SQL workbench has successfully executed all the script which we have written here. Let's go and start performing some simple queries. Let's say I want to extract the metadata of user table. I have this query. Okay, select star from page table definition. So since we are extracting metadata from table name, let's say users, and click on execute option. So you have so many columns. Here it says first column user ID of type integer, encoding delta. Then you have username, first name, last name, city, state, email. So basically that's the metadata or the structure of user table. So we have sales ID, list ID, seller ID, buyer ID, and many other details. Let's execute some other command. Let's say I want to find total sales on a given date. Okay. Sum the count. Here I have some function which will count the number of sales from sales and date, where the sales date ID is date ID, and the date on which I want to calculate, I've specified it here, and then click. Okay, the sum error, it should show a number here. Rest is working, only that is not working. I've selected the user table and I've asked them to display all that there is in the user table. So this is the data. Okay, select star from users. So I want to extract the names of people who are from, let's say some states. Let's consider some state. Let's take NH. So STATE like NH. It should work now. It says executing statement. So these are the people who are from state NH. So basically, once you've the perfect connection from your SQL workbench to your Amazon Redshift, you can perform whatever queries you like. So let's go back to our Amazon Redshift console. Well, so this is the cluster. I'm going to click on this. Here you have queries. When you click on that, all the queries which you performed till now will be shown. So this is the query. So it says first name from users was from state NH. This was the query which we performed earlier. So you have all the data or all the information regarding the queries which you executed. Well, that's all about Amazon Redshift. So guys, this is how easy it is to create a data warehouse using Amazon Redshift. Go ahead and explore many other features of Amazon Redshift. Well, I've just showed a part of them here. So go ahead and create a database, perform various queries, and have fun.
So when you talk about software development, you have to mention DevOps. Now let's try to understand why. To do that, let me give you this basic definition first. So it is nothing but a set of practices intended to reduce the time between committing a change to a system and the change being placed into normal production while ensuring high quality. Yes, very textbookish. And again, for people who do not know what DevOps is, this might seem a little vague. So let me just simplify this definition for you people. Again, you see an image here. What you see is you see a developer, you see an operator, and there is a deployment wall, which none of these two is ready to take responsibility of. They're pushing their responsibility on someone else. So yes, this is what the scenario is when you talk about software development. Again, let me give you a little more idea about this particular term. So let's try to understand how developers work and how operators work. And when you talk about developers, their responsibility is to create code, to update this code whenever required, wait for the next releases, and if there are any changes, commit those changes, submit those changes, and again, move it to the production environment where the operators take care of it. Then wait for the feedback from the operators if there is any, and then again, go through the changes if there are any. likewise wait for newer softwares, newer products to work on. So yes, this is what their responsibility is. Create code, create applications, right? So what happens here is when you do create a software, so there are constant releases that you need to focus on. We all know that every now and then you'd be getting a Windows update or your mobile phone update saying that, okay, you have a new operating system, new release, new version, update it. So this is how the technology is working. Everything gets updated every now and then. So the reason this is happening is people want to stay competitive in the market, the software companies at least, and they want to ensure that their product has the latest features. So this puts burden on the developers because they have to constantly update their softwares. Now, once they update a particular software, it has to go and work in the production environment. But at times it does not work in the production environment because the developer environment and the production environment might be a little different. So something that works in the developer environment might not work in the production environment. So again, some changes are thrown back by the operators and developers again get stuck. So they have to wait till they get the response from the operators. And if it takes a longer while, their work is stuck. Now, if you take a look at it from the operator's perspective, their job is to ensure that whatever is working in the developer environment, it has to work in the production environment as well. They deal with the customers, get their feedbacks, and if there are any changes which need to be implemented, at times they implement it themselves. If there are any core or important changes that are required, those have to be forwarded to the developers. So yes, what happens at times is what works, as I've already mentioned, works in the developer environment does not work in the production environment. And operators might feel that this was the responsibility of the developer, which they did not do, and probably they are facing problem because of it. Again, the customer inputs, if those are forwarded back to the developers team, the operator team has to depend on the developers to make those changes, right? So as you can see, these two teams are interdependent on each other. And at times they feel that somebody else's work, the developers' work is pushed upon the administrators, or the developers feel that the administrators' team's work is pushed upon their side. So there is this constant tussle which the company owners have to take care of. They have to think as in, okay, if this goes on, how can I generate or produce new releases, new softwares every now and then? This could be a problem, right? So this is what DevOps does. As the name suggests, it is dev plus ops. That means it combines the operations team and the DevOps team. When I say combine, they bring in this approach where integration and deployment and delivery, it happens continuously. And the fact that these things happen continuously, we do not see the tussle between these two teams. So yes, as you move further, DevOps helps you unite these two teams and they can work happily together. So this is what happens in DevOps. You code, you plan, you release, there's deployment, there's operations, there's monitoring, there's testing, everything happens in a pipeline. And these are some of the popular DevOps tools that let you take care of all these things. But now, again, this is DevOps in general. You have Git, you have Puppet, you have Chef, you have Ansible, SaltStack that help you automate this process of integration and deployment of your software. But the fact that everything is moving to cloud these days, we are thinking about how can we do all these things on cloud? Do I need to move in these many tools? If you want, definitely you can move all these tools. But a platform like AWS, which is a popular cloud service provider, what they have done is they've ensured that all the requirements of DevOps can be taken care on the platform itself, and you have various services that are made available to you that help you in this process. Now, say for example, you have EC2, right? Instances. Now, you can launch servers at your will. You can launch instances at your will. So if your concern is scaling up and down, AWS takes care of it. You have various services which help you monitor your process. So monitoring is something that is taken care of. There's auto scaling. There are various other services which this cloud front, which actually lets you create content delivery networks. I mean, you can have temporary caches where you can store your data and stuff like that. So there are various AWS services that actually help you carry out the DevOps or the CI/CD process with a lot more ease. And that is why DevOps and AWS, they form a very good combination or a combo. Hence, we are talking about this term today, that is AWS DevOps. Now that we have some idea about what AWS is, what DevOps is, let's try to understand how continuous integration, delivery, and deployment work with AWS and how they incorporate the DevOps approach. To do that, let's try to understand continuous integration and delivery first. So let's take a look at this diagram to understand this process. So these are the 4 steps that are there. You have split the entire chunk of codes into segments. So guys, think of it as more of your MapReduce kind of an action. I mean, what happens is in your continuous integration and delivery, we are trying to bridge in the gap between the developer team and the operations team, right? So we try and automate this process of integration and delivery.
So the fact that continuously you have various software updates, which I just mentioned, right? So what if I have like 50 or maybe 100 developers who are working parallelly? Now there are certain resources that need to be used by everyone, right? So what problem it creates is, suppose if I'm working on a particular code, I work on that piece of code. And if somebody else is working on that piece of code, and we have this central system where the data needs to be stored. So I'm working on this piece of code, I make a particular change and I store it there. Now someone else is working on this piece of code and that someone makes a change and he or she stores it there, right? So tomorrow if I come back, probably I need a fresh copy of this piece of code. What if I just start working on the piece of code that I'm working and then I submit that code there? So there would be an ambiguity, right? Whose code to be accepted? Whose code's copy should be made? So we need this central system to be so smart that each time I submit a code, it updates, it runs tests on it and sees whether it's the most relevant piece. And if someone else submits their piece of code, then tests are run on that piece of code. This system should be able to ensure that each of us next time when we go and pick the piece of code, we get the latest piece of code and we get the most updated one or the best piece of code. So this process of committing the code, putting in that piece of code and automating this whole process so that as it moves further, it also gets delivered and deployed to the production in the similar manner with the tests that need to be conducted is called as continuous integration and delivery. Now, integration, as I've mentioned here, the continuous updates in the source code or the code that I'm building, the code is built, compiled. And when I talk about delivery and deployment, the pieces of code, once they're ready to move to the production environment, those are continuously deployed to the end customer. Now, deployment seems a very easy process, right? I mean, picking up the code and giving to the end customer. No, it's not that easy. Deployment actually involves taking care of all the servers and stuff like that. And spawning up these servers is a difficult task. So automating this process becomes very important. And if you do it manually, you're going to suffer a lot. So yes, this is where continuous integration and delivery comes into picture. Code, it is continuously generated, it is compiled, it is built, then compiled again, then tested, again, then delivered, and made sure that it gets deployed to the end customer the way it was supposed to be. So you can see that there are certain steps here. It says split the entire chunk into codes or into segments, keep small segments of codes into manageable form, basically integrate these segments multiple times a day, which I mentioned that there should be a central system, and then adopt a continuous integration methodology to coordinate with your team. So this is what happens. I mean, you have a source code repository where the developers work, they continuously submit their pieces of code. Now repository, think of it as a central place where the changes are constantly committed. Then you have a build server where everything gets compiled, reviewed, tested, integrated, and then packaged as well. Finally, certain tests, final tests are run to go through the final integrities, and then it goes to the production environment where this process, the building, the staging, and the committing process, it gets kind of automated to reduce your efforts. So guys, when you talk about AWS in particular, you have something called as AWS code pipeline, which lets you simplify this process. It lets you create a channel or a pipeline in which all these processes can be automated. So let's take a look at those processes as well. First, let's get through the definition part. Let's see what it has to say. I would be blankly reading this thing and then probably we'd be having the explanation part that follows. So as the definition says, it is a code pipeline, which is nothing but a continuous delivery service. We talked about continuous delivery already. And you can use the service to model, visualize, and automate certain steps required to release your software. Something that we've already discussed in continuous integration and delivery. So this is basically a continuous delivery service which lets you automate all these processes. So as I mentioned, automating these processes becomes very important. So once you do use this service, these are some of the features it provides you. It lets you monitor your processes in real time, which becomes very important because we are talking about deploying softwares at a greater pace. So if this can happen at real time, I mean, if there is any change and if it is committed right away, probably you're saving a lot of time, right? You ensure consistent release process. Yes, as I've told you, deploying servers is a difficult task and time consuming task. If this can be automated, a lot of effort is saved. Speed up delivery while improving quality. Yes, we've talked about this as well. And view pipeline history details. Monitoring becomes very important, guys. So what code pipeline does is actually it lets you take a look at all the processes that are happening. I mean, if your application is built, it goes to the source, then it moves to the deployment. All these processes can be tracked in the pipeline. You get constant updates as in, okay, this happened at this stage. If anything failed, you can detect as in, okay, this is the stage where it is failing, maybe stage number 3, stage number 4. And accordingly, you can edit the stuff that has happened at that stage only. So viewing the pipeline history details actually helps a lot. And this is where code pipeline comes into picture. So this is what the architecture of code pipeline looks like. It's fairly simple. Guys, so some of this might seem a little repetitive to you people because the concepts are similar. The concepts which we discussed, those can be implemented by using code pipeline. So yes, I've talked about these things, but let's try to understand how the architecture works. And we would be using some other terms and discuss some terms in the future slides as well, which we've already talked about. But each of these services, they do this task a little differently or help you automate these processes. Hence the discussion. So let's see to how much level can we keep it unique, and let's go ahead with this discussion as well. So let's see how the code pipeline works. Basically, there are developers, as I've already mentioned, these developers would be working on various pieces of codes. So you have continuous changes and fixes that need to be uploaded. So you have various services. One of them is code commit, which lets you have an initial source management system kind of a thing, which lets you basically take care of repositories and stuff like that. So it lets you directly connect with Git. I would be talking about Git, what Git is, but for people who know what Git is, if you have to manage your Git repositories, you have a service called as code commit. So this is what happens if there are any changes, those go to the source, your developers can commit those changes there, and then it goes into the build stage. This is where all the development happens. Your source code is compiled and it is tested. Then it goes to the staging phase where it is deployed and tested. Now, when I say tested, these are some final tests that have to be implemented before the code gets deployed. Then it has to be approved manually. It has to be checked manually whether everything is in place. And finally, the code is deployed to the public servers where customers can use it. Again, if they have any changes, as I've mentioned, those can be readily taken from them and it goes back again to the developers and the cycle continues so that there is continuous deployment of code. This is another look at it. It is very simple, but this is more from AWS perspective. So if there are any changes that developers commit, those go to the source. Now your data is stored in a container called as S3, that is simple storage service in the form of objects. So if there is any change that has to happen, the data is either fetched from the storage container, which is S3, and the changes are built. And then again, a copy of it is maintained in the form of zip. As you can see here, there are continuous changes that are happening and those get stored in the S3 bucket. Now S3 should preferably be on the region or in the place where your pipeline is. That helps you carry out the process of continuous integration and delivery with ease. In case if you are concerned with multiple regions, you need to have a bucket at each region to simplify these processes. So again, here to the code gets to the source. It is probably submitted to the build stage where the changes happen. A copy is maintained at S3 and then it goes to the staging. Again, a copy is maintained and then it gets deployed. So this is how the code pipeline works. And to actually go ahead and implement all the actions of code pipeline, you have a service or these services, that is your code deploy, build, and code commit in AWS. So these services actually help you carry out some or most of these processes that are there. Let's take a look at those services and understand what do they do. So first and foremost, you have your code deploy, code build, and code commit. So this is not the order in which you deal with these things. Now, these things actually help you in automating your continuous delivery and deployment process. They have their individual commitments. Let's talk about them one by one. First, let's talk about code commit, which is last in the slide. So basically, I talked about moving your piece of code to a central place where you can continuously commit your code and get the freshest or the best copy that is there, right? So code commit, what it does is it helps you manage your repositories in a much better way. I mean, think of it as a central repository. So it also lets you connect with Git, which itself is a central storage or a place where you can commit your code. You can push and pull that piece of code from there, work on it, make own copy of it, submit it back to the main server or your main or central operating place where your code gets distributed to everyone. So that is Git. And what code commit does is it lets you integrate with Git in a much better way. So you do not have to worry about working on two different things. It helps you in automatic authorization, pulling in the repositories that are there in your Git account, and a number of other things. So yeah, that is what code commit does. Then you have something called as code build. As the name suggests, it helps you automate the process of building your code, where your code gets compiled, tested, certain tests are performed, and again, making sure that artifacts or the copies of your code are maintained in your S3 and stuff like that. So that is what code build does. And then you have code deploy. As I've already mentioned, deployment is not an easy task. I mean, if we are stuck in a situation where we are supposed to manage the repositories, we are supposed to work on quite a few things. In that case, if we are forced to kind of take a look at the servers as well, spawn new instances, spawn new piece of servers, that could be a tedious task. So code deploy helps you automate these processes as well. So this was some basic introduction to these things. Let's just move further and take a look at the demo so that we can talk about some of these terms and the terms that we've discussed previously in a little more detail. Now, in one of my previous sessions, I did give you a demo on continuous integration and delivery. I believe there were certain terms that people felt were taken care of in a speedy way. Hope that I've explained most of the terms with more finesse this time and in more detail. As we go through the demo too, I would try and be as slow as possible so that you understand what is happening here. So let's just jump into the demo part, guys. So guys, what I've done is I've gone ahead and I've switched into my AWS console for people who are new to AWS. Again, you can have a free tier account with AWS. It's very easy. You have to go and sign in, put in your credit card or debit card details. A free verification would happen and probably you'd be given access to these services. Now, most of these services are made available to you for free for one complete year. Now, there is certain limitation on these services. So you have to follow those limitations. If you cross those limitations, maybe you would be charged, but that happens rarely. I mean, if you want to get started, definitely this 1 year free subscription is more than enough to get hands-on on most of the services. So I would suggest that you create this free tier account. If you've taken a look at my previous videos, you would know that how to create a free tier account. If not, it's fairly simple. Just go to your browser and type AWS free tier, and probably you'd be guided as in what details have to be entered. It's not a complex process. It is fairly simple and it happens very easily. So you just have to go ahead and do that. Once you do that, again, you'd be having access to this console, guys. So once you have an access to this console, you have all the services that you can use. So in today's session, we would be working on a similar demo that we worked in our one of the previous sessions. Here we would be creating an application, a PaaS application, platform as a service application, and we would be deploying that application using our code pipeline. So there would be talking about other terms as well, like code commit, code deploy, and code build. So do not worry, we would be discussing those as well. So this is what the demo is for today's session. So guys, let's start by creating our PaaS application. To do that, we would be using Elastic Beanstalk, which lets you have a ready to use template and using which you can create a simple application. Now, this being a demo, guys, we would be creating a very simple and a basic application. So just come here and type Elastic Beanstalk. So when I come to this page, guys, if you've created an application, it would show you those applications. But the fact that if you're using it for the first time, this is the console that you'd be getting. That is why I have created this demo account so that probably we get to see how you can start from the scratch. So if you click on get started, guys, creating an application here is very easy, like extremely easy. You have to enter in certain details only. It takes a while to create an application, understandable. I would tell you why it takes the time, but once it happens very quickly. So all you have to do is give your application name. Let's call it, say, deployment app. I'm very bad at naming conventions. Let's assume that this is good. You can choose a platform, guys. You can choose whatever platform you want. Say PHP is what I'm choosing right now. As I've told you, it's a PaaS service. PaaS, that is platform as a service, means that you have a ready to use platform, guys. And that is why you can just choose your platform. And your Elastic Beanstalk would ensure that it takes care of all the background activities. You do not have to set up your infrastructure. It takes care of it. So once I select the platform, I can use the sample application or use the code if I have. In this case, I would be using a sample code that AWS has to offer. And I say create. There you go, guys. This thing is creating my application. So whatever is happening here, it shows that these are the processes. Now it is creating a bucket to store all the data and stuff like that. So it would take care of all these things, guys. It might take a couple of minutes. So meanwhile, let's just go ahead and do something else. Let me just open AWS console again somewhere else. I hope it does not ask me to sign in again. I've already signed in. So meanwhile, that application gets created. Let me just go ahead and create a pipeline, guys. So code pipeline again. It's fairly simple, guys. What happens here is very easy. I just go ahead and put in certain details here as well, and my pipeline would be created. So do you want to use the new environment or want to stick to the old one? You can click on old, right? And you can go back and create it the way it was done, or you can use the previous environment. I'm going to stick with that. I was very comfortable with that. So let's just stick with it. If you want, you can use the new interface. There's not a lot of difference, certain little or minor differences. So you can just come here and add in the name of the pipeline that you want to create, say demo pipeline. I say next. Source provider. Guys, I would be using GitHub here because I want to basically pick up a repository from GitHub that helps me in deployment. So I need to connect to GitHub for that. It would ask me to authorize. If you have an account, you can always do that so that it can basically bring in all the repositories that you have. So just say authorize. If not, you'll have to sign in once. So my account has been added here, guys. Repository, I need to pick a repository. This is the repository that I would be picking. Do not worry, I would be sharing this piece of code. Or else what you can do is you can just go to GitHub and type AWS code pipeline S3 code deploy Linux. Now it is a repository given to you by AWS. If you take a look at it and if you type it just the way it is named here from AWS, you should get that repository in GitHub. You just have to go ahead and fork it into your GitHub account, and probably you'd be able to import that repository directly. You can see that repository has been forked here into my GitHub account. You just type the name here, this name, search it, and probably there would be an option here, fork. I forked it, so it does not activate this option for me. In your case, it would be activated. You have to just click on it and the repository would be forked into your account. So I'm getting or importing a fork from my GitHub. I've authorized my account, and then I can just go ahead and do the stuff. Branch, master branch, yes, and just do the next step. Build provider, no build here. I don't have anything major to build, so I don't need to go ahead and provide a build provider. You can use code build, right? Guys, if you want to move or basically deploy your code to EC2 instances, you can use code build if you want. In this case, I have an application in which I have an EC2 instance and stuff like that. So I don't need to go ahead and do any building stuff, hence no build for me. So I say next, deployment provider. In this case, my deployment provider would be my EBS. So we have that option. Yes, select EBS, Elastic Beanstalk, not EBS. EBS stands for Elastic Block Storage. That is a different thing, guys. Elastic Beanstalk, make sure you do that. Application name, deployment app was the name, right? Yep. And the environment. This is the environment. It creates the environment on its own. I believe that it has created the environment. It says it is starting. I hope the environment has been created. So guys, let's just see whether our application is up and running so that probably I can pass in the details. Yes, the application has been created, guys. So let's just go back and select this. Say next. Now create an IAM role is what it is saying. So let's say sample. Okay, guys. So what happens normally is an IAM user gets created each time you create a role. So in this case, it is asking me to create one. It's access, create a new IAM role, AWS code pipeline. And I say allow. Successful. So a role has been created. Next step. Now it gives me the details, guys. Basically, it would tell me what are the stuff that I've done. So everything is here. I don't think I need to cross check it. You might just cross check the stuff that has happened and say create a pipeline. So guys, the pipeline has been created here. As you can see, these are the stages that have happened. If you want, you can just go ahead and say release a change. Now these things are happening, guys, and let's hope the deployment also happens successfully. We've just created an IAM user. Let's see whether it falls in place. Everything is in place. As far as the source part is concerned, it has succeeded. And now the deployment is in progress. So it might take a while. Meanwhile, just go back and take a look at this application. So if I open this application, guys, it would give me an overview of what has happened with this application, guys. As you can see, these were the steps that were implemented. Now the application is available for deployment. It successfully launched the deployment environment. It started with everything that it was supposed to do, like create or launch an EC2 instance and stuff like that. So everything is mentioned here, what happened at what time. So this is a PaaS service, guys, and it works in the background. I mean, if you actually go ahead and launch an instance on your own, configure IAM users, configure security groups, it takes a longer while. But what the service does is it automates that process. It understands that you need an EC2 instance. It launches that instance. It assigns security groups, VPCs and stuff like that. All you have to do is run your application on top of it, as simple as that. So it has taken care of everything and run a PHP application for me. So yes, this is what has happened here. If I just go back here. Meanwhile, let's see whether our code has successfully run. You can see what has happened here. I've released the change as well. And you can view the pipeline history if you want. You can click on this icon and all the details will be given to you, what happened in what stage. So these are the things that have happened till time. Now guys, let's just go back and take a look at something that we could. So I'm gonna come here and say service EC2 because my app launched an EC2 instance. So there should be an instance created by Elastic Beanstalk. See, one instance is running. It has a key pair attached to it as well. So these are the details, guys. I have a public IP associated with it. If I copy it, there you go, copy this IP, and I say run this IP, you have successfully created a pipeline that retrieved this source application from an Amazon S3 bucket and deployed it to 3 instances. It did not deploy it to 3 instances using code deploy. It deployed it to only 1 instance. You see this message that it deployed it to 3 instances is because the code or the repository that I used, it was supposed to deploy it to different instances if there are multiple instances, and hence this message would have made more sense then. But the fact that we've deployed it to only one EC2 instance, it should actually display that message. So the message that you're supposed to give, you can actually come back here and make change to the piece of code that you worked on. If you go to the readme md file, I think this is where the piece of code is. There you go. Okay, no, not here. Okay, where is that file that needs to be edited? Let me just take a look at some other files as well. Yeah, this is the file, sorry. So if you go to the index.file, here is the message, guys. So you can probably make a change to this message. Instead of saying 3, you can say 1 here, edit this piece of code, and then you submit the code again. So when you do launch or type in this IP address, probably that change would be reflected. So guys, what we've done is we've actually gone ahead and created a pipeline successfully. And in that process, we've actually gone ahead and moved or deployed our application from here. So guys, in case if I do go ahead and commit changes to the code that I just talked about, those would get reflected right away in my history when I talk about this pipeline. So it does give you continuous integration and deployment. So I hope that this session made sense to you people. And we've talked or touched upon most of the stuff that I wanted to talk about. And as far as this session goes, guys, I would be resting it here.
So let's start with the first question. Now, our first question says, I have some private servers on my premises. Also, I have distributed some of my workload on the public cloud. What is this architecture called? So basically, our workload has been divided between the public cloud and the private cloud. Now, they're asking me, what is this architecture called? It's a pretty basic question, guys. But if you look at the options, they're quite confusing. The first option is a virtual private network. Then we have private cloud, which is obviously not there. Then we have a virtual private cloud, could be the option. And then we have hybrid cloud. All right, guys, so what do you think? What do you think is the right answer for this? Come on, guys, let's be more interactive in this session, because if it's a two-way thing, then it's going to be interesting for you and for me as well. So let's make it as interactive as possible, and let's get the most out of this session today. All right, so Ashish says it's either virtual private cloud or a hybrid cloud. So Ashish, it's actually only one out of all the 4, so give one answer. Okay, I can see some of you are saying the right answer. Some are confused. It's okay, I shall clear your doubts. All right, guys, so the answer is hybrid cloud. Now, why a hybrid cloud? Because, okay, so let's actually discuss the first 3 options, which are actually not the right answer. So it is not a virtual private network, because a virtual private network is something that you use to connect your private cloud and your public, right? So to connect between your private cloud and the public cloud, you actually have to make a connection, and that connection is done using a virtual private network. All right. Then we have private cloud. So private cloud is something wherein you have your own servers on your own premise, right? But in our case, we have public cloud involved, so it is obviously not private cloud. Virtual private cloud is not the option as well, because a virtual private cloud is basically a logical isolation kind of thing, wherein you isolate your instances from the rest of the instances on your AWS infrastructure. And this logical isolation cloud is called a virtual private cloud. And then we have hybrid cloud, which I think fits aptly by its name as well, wherein it's a mixture of your public cloud and your private cloud infrastructure. All right, so let's see the answer. So the answer is hybrid cloud, and the explanation is like this: because we are using both the public cloud and your on-premises servers, which is a private cloud, we call it an hybrid architecture, right? And it says here that if you wouldn't it be better if your private and public cloud were all on the same network, right? So basically, when you connect your public cloud and the private cloud together using virtual private network, you basically are accessing one network, and you feel that all your resources which are there on the public cloud and the private cloud are actually there in one network, right? So it seems it's a virtual private network. Virtually, you feel that you are on the same network, but they are actually two different resources or two different locations from where you're accessing your resources. All right, guys. So, guys, any questions regarding to the first question that we have discussed? Anything that you're not clear with? It was a very basic question, but then we are getting a lot of concepts here. We have a virtual private network concept, then we have the virtual private cloud concept, right? So it can be confusing, and this is how they ask you in interviews as well, right? So you have to be very clear in your answer. You have to be very clear in your thoughts that what shall be the right answer. All right. So I can see that people are giving me a go. They're all clear. Okay, guys. So let's move on to the next question then. So our next question starts with our section 1, which is EC2 questions. So from here, we'll be talking all about AWS. So let's start with the question first. So we have a video transcoding application, and the videos are processed according to a queue. If the processing of a video is interrupted in one instance, it is resumed in another instance. Okay, good enough. Then currently there is a huge backlog of videos which needs to be processed. For this, you need to add more instances, but you need these instances only until your backlog is reduced. All right, so once your backlog is reduced, you don't need those many servers. So which pricing option should be the efficient, should be the most cost efficient for this? Okay, guys, so first of all, when you have question like this, a lot of things are added into it to make it confusing. So first of all, the thing says, the first line reads that it's a video transcoding application. So it is not relevant to your question, right? It is not relevant to what is being asked. So you can discard that out. And then it says the videos are processed according to a queue. Again, it's there to confuse you. Don't. The first thing that you should look out into a question which you're trying, when you're trying to figure out an answer, is the important parts. What is important in the question? You should be able to identify that. So according to me, the thing that is important is that there is a huge backlog of videos. So there is a lot of pending work, and this pending work has to be reduced, right? And once it is reduced, we will not be needing those many servers. So basically, we are increasing our number of servers to actually reduce the number of backlogs that we have. And once we have reduced that, we have an application wherein we don't need those many servers anymore. So we should get rid of them, right? So now it is asking me which pricing option should be efficient for this setup. Now you have three kind of pricing options. You have on-demand pricing, then you have spot pricing, and then you have reserved pricing, right? So your spot pricing is basically used when you want servers at the minimum cost. So basically what happens is, why spot pricing has been introduced is because of this, that AWS has centers, right? It has server zones where it has a lot of servers. Now, not all the time that the servers are actually being used. Some of the times they're idle, right? So in times like this, when the servers are idle, what AWS does is it gives you a discount, that since no server is being used, I shall give you a discount if you want to use my servers. Now, in this case, you use spot pricing. So if you are going for spot pricing, you see these reduced rates from AWS whenever their servers are idle, and you should bid a rate, right? So say example, servers are being offered at some particular price, and you say, okay, I want these many servers, but I can only afford $10. So as long as these servers can be allotted to me for $10, I shall use them, right? So you set your price at $10 and then you use the servers. But the moment the demand increases in that particular server location, the prices go up again, all right? And if the price crosses $10, your server shall be shut down, right? You'll not be able to access that server anymore, right? So this is what spot pricing is. You basically bid for the minimum price, and whenever the price go up, your server is taken from you, right? Then second type of pricing is called reserved pricing, wherein you reserve your servers for a particular amount of time, say a 1 year term or a 3 year term, right? So the application for this could be when, say, I have a company, right? And my company has a website. So my website is hosted on AWS. Now my website is going to be there till my company is there, right? So it makes sense for me to actually reserve the instances for like the maximum term possible, because I'm in no plan to sell my company and hence take down my website, right? Now, the reason people opt for reserved instances is because as compared to the on-demand pricing, the reserved pricing is actually pretty cheap, right? So if you reserve your instances for a longer term, you get discounts from AWS, right? And then we have on-demand pricing, wherein we can get as many servers as we want at the time what we want as per your requirement at whatever time you require, and the pricing for them are standard, right? I'll not say they're high, but they are standard, but they are more than reserved pricing and your spot pricing. Now, our question says that we have to reduce the backlog, and once the backlog has been reduced, we'd have to get rid of the servers. So obviously we'll not be using reserved instances because we cannot say when our backlog will be ending, right? We cannot be using spot prices because we want that backlog to be reduced as soon as possible. So what we'll do is we'll be using on-demand instances or on-demand pricing, and using that we will reduce the workload, or we'll reduce the backlog of the videos, and once it's been reduced, we will reduce the server size for our instance, right? So the answer for this should be on-demand instances. And if you read the explanation, you should be using an on-demand instance for the same, because the workload has to be processed now, meaning it is urgent. Secondly, you don't need them once your backlog is cleared, therefore reserved instance is out of the picture. And since the work is urgent, you cannot stop the work on an instance just because the spot price spiked, right? So therefore spot pricing can also not be used, and hence we'll be using on-demand instance. All right, guys, so any doubt in this question, anything that you're not clear with? Why are we using on-demand pricing? Okay, so since you guys are clear, let's go on to the next question. So our next question says we have a distributed application that periodically processes large amount of data. Now, like I said, first we have to identify what in the question is an important information and what is not, right? Because some of the things that you have mentioned in the question are there to confuse you, right? So we have to identify what is important. So it says we have a distributed application that periodically processes large volumes of data, and it is designed to recover gracefully from an Amazon EC2 instance failure. That means if one Amazon region goes down, your traffic will be redirected to a healthy region wherein the servers are ready to take the traffic, right? So it's a failover, and you're required to accomplish this task in the most cost efficient way. So I think the most important lines in this question are, first of all, the agenda is to get it done in the least cost possible, right? The most cost efficient way. And then it says that the data is processed periodically, as in the data is not being processed continuously, but periodically. It could be a 1 week term or a 3 or 4 day term, right? So it is not being used continuously. So first of all, if we are not using it continuously, I think reserved instances are out of the picture because your servers will be idle most of the times, right? Same is the case with on-demand instances as well. So we are left with spot instances and dedicated instances. And dedicated instances are something wherein you get the whole server. So basically what happens is in your cloud infrastructure, on every single server, you have a lot of clients using it, right? You have a lot of clients using that particular server, but like that server has been internally divided into your operating systems, right? So you will never know that some other person is also working on your machine, but this is how it is. It is a multi-tenant architecture. But when we have dedicated instances, basically you get a server for your own use, right? There is no one else on that particular server that you are using. So I don't think it is related to something what we are asking the question. And obviously, as you must have guessed, that dedicated instances are not cheap. They are quite expensive because you get the whole server, right? So the most cost efficient way, and since the job is done periodically, I think we should go for spot instances. On demand instances, one more reason is that it is not acceptable for this particular use case is because you'll have to actually pay a lot, right? So I think the most closely going option is between spot instances and on-demand instances, because on-demand instances could be launched anytime and could be shut down anytime we want. And since it's periodic, it makes sense to use on-demand instances as well. But guys, if you look at spot instances and on-demand instances, the cheaper option is with spot instances. So we should go for spot instances first and then on-demand instances. So let's see the answer. So yes, our answer says it's spot instances. Why? Because since the work we are addressing here is not continuous, a reserved instance shall be idle at times. Good. And same goes with on-demand instances, and it does not make sense to launch an on-demand instance whenever work comes up since it's expensive. All right. So spot instances will be the right fit because of the low rates and no long-term commitment. Bang on, guys. So we'll be using spot instances for this particular use case. Any doubts, guys? Anything that we are not sure of in this question? Okay, so Rohit is saying why not use on-demand instances, because we can launch them anytime we want. Right, Rohit? But if you look at the question says we have to do it in the most cost-efficient way. And obviously, since spot pricing is an option like that, that it is meant to give you servers at a very cheap price. And again, the manual work is going to be same. In on-demand instances as well, you have to launch the servers manually at that instant when you want to process your data. And in spot instances as well, you have to manually launch your servers when you want to process your data. And both of them can be ended at whatever time you want. But since spot instances is more cheaper, we will choose that option. Yeah, but then if this question or if this statement was not there, that we are not bounded by costs, then obviously we would have gone with on-demand instances. All right, is that clear? Okay, guys, any more doubts? All right, so let's move on to the next question then. So our next question is, how is stopping and terminating an instance different from each other? Nice question. It's actually pretty confusing for beginners, but I think you guys should be knowing this. So let's see what the answer is. So stopping and starting an instance is basically when you stop an instance, it is actually not deleted. It is there on the system, but you are not charged for a stopped instance. Right? But when you terminate an instance, what happens is it's first, if the instance is in a running state, it first comes to a stop state and then it gets deleted, right? So stopping an instance and terminating an instance, basically the difference is when you stop an instance, you are not charged although, but your instance is not deleted. So you might be incurring some storage charges. But when you talk about terminating an instance, you're stopping the instance, but you're also deleting the instance at that instant as well, right? You're not charged with any storage options as well, right? So this is the difference between stopping an instance and terminating an instance. Let's go ahead and move on to the next question. So the next question says, when will you incur costs with an elastic IP address? And the options are when an EIP is allocated, when it is allocated and associated with the running instance, when it is allocated and associated with the stopped instance, and costs are incurred regardless of whether the EIP is associated with the running instance or not. Okay, so the answer for this, guys, is I think it's a tough one because I know most of you would not have used an elastic IP address until now. So it is, you're charged when you are allocated an elastic IP address, but you have not detached it with your stopped instance, in the sense that you are not using your instance as well, but you have attached an elastic IP address with the stopped instance. So in that case, you are also not using it, and also the other users on the internet can also not use that particular IP address, right? And that is the reason, I guess, that Amazon charges you. So basically, you are charged for three scenes. You are charged for in three cases for an elastic IP. So the three cases are when you use more than one elastic IP with your instance, when your elastic IP is attached to a stopped instance, which we just discussed, and when your elastic IP is not attached to any instance. Now, why are we being charged is because of this. Because guys, IP address is a rare commodity, right? It is a limited commodity. It is not something which is there in the countless terms, right? So a particular set of IP addresses are there. Now, as you must have recalled, an elastic IP address is something which is static, right? So the difference between an elastic IP address and a normal IP address is this, that say you launch an instance, an EC2 instance, right? And you are allocated an IP address. Now that address will be attached to your instance as long as that instance is running. But whenever you restart your instance or when you stop that instance and run it again, that IP address will change. All right. To avoid that, we have elastic IP addresses. Now, what happens with elastic IP address is this, that your instance or is actually physically attached to an IP address, and that IP address never changes. Even when you stop that instance, when you're running that instance, that IP address is going to be the same. All right. So, and the third scene is that the IP address is not attached to any instance. So, right. So you allocate yourself an elastic IP, but you don't attach it to any of your running instances. So in that case, what happens is that IP address is blocked with you, but you're not using it on your own. And also the people outside you who might want to use a static IP address cannot use it as well, right? So it becomes a problem. And that is the reason Amazon has regularized this, and they charge you if you have IP addresses which are not being used by you, right? And so yeah, so when they are not being used by you. All right, so guys, any questions on this slide? Any questions or any doubts related to this particular question? Pretty straightforward, right? Okay, so yeah, so I can see everyone understood it. Okay guys, so let's move on to our next question. So our next question says, how is a spot instance different from an on-demand instance or a reserved instance? We have discussed it earlier as well, so let's see the answer. So like I said, a spot instance is basically used for bidding. An on-demand instance is used when you want the servers then and there, right? And a reserved instance is used when you're looking at long-term commitments in terms of your application, right? So let's read the explanation. So first of all, let's understand that spot instance, on-demand instance, and reserved instance are all models for pricing. Cool. Moving along, spot instances provide the ability for customers to purchase compute capacity with no upfront commitments. Right? So you don't commit anything. You are not saying that I'm going to use it for like a year or 1.5 years or 2 years or 3 years. You just get that instance for as long as that bidding price is there. All right. And we get it at hourly rates, usually lower than on-demand rate in each region. Spot instances are just like bidding. So like I said, you bid your price and the spot price fluctuates based on supply and demand for instances. So whenever there's a demand for instances, your spot price increases automatically. But the customer will never pay more than the maximum price that they have specified. So whatever price that you have specified for your particular server, you will not be charged even a penny more than that, right? So if the spot price goes beyond it, your server will be terminated, right? So if the spot price moves higher than a customer's maximum price, the customer's EC2 instance will be shut down automatically, like I said. But the reverse is not true. So yeah, so when your spot instances say your server got terminated, right? But if the spot price again comes down below $10, it is not like your server will start running again, right? So you have to do it again manually. You have to again put your bidding price, again you have to choose a server and it will be launched. All right. So, and then in spot and on-demand instance, there is no commitment for the duration for the user side, even in on-demand instance. But the difference is that the on-demand instance is basically more expensive than your on-demand instances. And there is no commitment for the duration from the user side. However, in reserved instances, one has to stick to the time period that he has chosen. So if you take, so if you say you reserve your instances for 1 year, these instances will be yours for 1 year. Before that time, you shall not be able to come out of the plan. And that is why you have some payments, some upfront payments that you have to do in case you're opting for your reserved instances. All right, guys, so let's move on to the next question now. So the next question says, what kind of network performance parameters can you expect when you launch instances in a cluster placement group? All right. So this question is actually a very good question. So when you launch instances in a cluster placement group, what basically happens is you get three benefits out of it. So first of all, you get 10 GB per second of single flow data. You get 20 Gbps in multiflow, that is the data would be coming to you and going from you as well. So the bandwidth is 20 Gbps. And the network traffic outside the placement group will be limited to 5 Gbps. Right? So whatever instances you have included in the cluster placement group will get these speeds, that is 10 Gbps and 20 Gbps. And the instances which will be outside this placement group will experience speeds that will be limited to 5 Gbps. Now these speeds are actually speeds which are related to each other. It's not the internet speed, guys. So say there are two servers in a cluster placement group. So these two servers can interact with each other with speed of 10 Gbps, right? So this is what this question is all about. So in whatever services or whatever instances that you have launched in cluster placement group, and if they are related to each other, they can actually transfer to and fro at a very high speed. And this is what cluster placement group is all about. All right. Any questions that you have on this? Okay, so cool. So I think everyone is clear. Let's go ahead. Let's jump on to the next question. All right. So our next question is to deploy a 4-node cluster of Hadoop in AWS. Which instance type can be used? So the type of instance which is used is called EMR, that is Elastic MapReduce. Now, before I go on to why we are using it, let's understand what happens in a Hadoop cluster. So the Hadoop cluster follows a master-slave concept. The master machine processes all the data, slave machines store the data and act as data nodes, right? So your machine is actually storing the data, or the Hadoop cluster is storing the data on the data nodes, right? And the master server will be doing all the processing. And this is how it works. So then obviously, since the master is doing all the processing, the master has been given a higher RAM and a much better CPU than your slave servers, right? So you can configure the configuration of a machine depending on your workload. So if your workload is more, if it requires more processing, you can actually choose an instance like that. So in this case, we shall be choosing a C4.8x large instance for the master machine, whereas for the slave machine, we can choose an I2.large instance, and it should be storage optimized, right? And if you don't want to deal with configuring your instance and installing a Hadoop cluster manually. Now, all of this is done when you are doing it manually. Like, so one instance that I told you was EMR, that is Elastic MapReduce. But if you want to do everything manually, that you want to set up clusters and everything, you can do it using EC2 as well. In that case, you'll be actually deploying quite a few EC2 servers. One EC2 server will be your master machine, and the other EC2 servers will become your slaves. And this is what the configuration is for. But if you don't want to deal with all these hassles, what you can do is you can straight away launch an Amazon EMR, which is Elastic MapReduce, which automatically configures the servers for you. And you dump your data, whatever data that has to be processed, you dump it on S3. And what EMR will do is it will pick up that data from whatever bucket that you have specified, process it, and dump it back to whatever bucket you have specified, either in the same bucket or some other bucket as well, right? So this is how you shall approach an Hadoop cluster, right? So the purpose is not to understand how a Hadoop cluster, the working of a Hadoop cluster, but to see basically how a Hadoop architecture is, and depending on that, deciding what instance to be used. So if you're using EC2, you should have a master machine and some slave machines. And if you don't want to deal with all these hassles, you can actually go for EMR, which is Elastic MapReduce, and Elastic MapReduce shall do each and every configuration for you, right? Okay, guys, so let's go to our next question now. So our next question says, how do you choose an availability zone? Now, this is a very important question, guys. This actually tests your architect skills, because as an architect, you are required to do a specific task with all the features, but at the minimum cost possible, right? So you have to choose an availability zone with the cost in mind as well. So let's see, how shall we choose an availability zone? So we have taken an example here. So basically, if you look at the figure, the regions that we get to choose between is Mumbai and North Virginia, all right? The instance type is M4.4x large. There are 16 virtual CPUs and a 64 gigabytes RAM. And then the pricing for Mumbai, it's $691 monthly, right? And for North Virginia, for 1 year, it's $480 monthly. And the latency from USA to India is low, and from India to USA, it's high, right? So these are the parameters that we have. These are the things that we have to analyze, right? So if you go and see the explanation, it says there's a company which has user base in India, right? So our user base is in India, right? So if it's in India, we shall be choosing a region. If it's in India, you would say, why not choose a region which is more closer to you? But as an architect, you have to actually look at a lot of things, and let's see how we go about it, right? So with the reference to the above figure, the regions to choose between are Mumbai and North Virginia. And if you compare the hourly prices, now the hourly price, if you look at, the Mumbai is at $0.9 hourly and North Virginia is $0.6 hourly, right? So obviously the cost is less if we host a website on North Virginia region, but cost is not only the factor, the performance should also be high. So let's look at the performance statistics. So if you look at the latency, guys, so latency basically means the response time, right? So the response time is something like this, that from USA to India, the latency is low, right? So that means that if you're accessing from USA your website, the latency is low. But from India to USA, that means if your website is hosted in India and a person is USA is trying to access your website, the latency is high. All right. So obviously, if a person is in USA and he's trying to access your website, obviously if the server is in USA, your latency would be lower, right? But like what we are analyzing is between India and USA. So if it's from USA to India, the latency is low. But what we have observed is that if it's from India to USA, that if the website is hosted in India and the USA guy is trying to access it, the latency is slightly higher, right? Now, if you look at both the things, so North Virginia is less in price as well and is less in latency as well. So our obvious choice should be North Virginia, right? So you should take performance, you should take pricing and some logics as well when you're considering or when you're choosing an availability zone, right? So this is actually something which is very trivial for an organization because this lays down the basis and how your website is going to perform when it's on the cloud, right? So this is about that, guys. Okay, so let's move forward. Okay, so our next question says, if one static IP address, is it enough for every instance that you have running on your AWS infrastructure? So it depends. Every instance comes with its own private and public address. The private address is associated exclusively with the instance and is returned to Amazon EC2 only when it is stopped or terminated, right? So only when it will be stopped or terminated, your IP address will change. But if you don't stop your instance is being executed from the time it has been launched, your IP address will not change, right? So this is about that. So if you don't plan on stopping your instance, I think opting for an elastic IP address should not be in your checklist, right? However, this can be replaced by elastic IP which stays with the instance as long as the user doesn't manually detach it, right? So if your instance demands that it should be stopped in near future and be launched again at a particular time, and you don't want your IP address to be changed, you shall go ahead and opt for an elastic IP address. Sometimes it happens, guys, that some fault in that availability might happen and your server might crash or something like that and might restart. In that case, your IP address will change. So to be on the safer side, even if you're hosting a website which is there 24/7, it is better if you opt for a static IP address, right? Now again, if you have a lot of instances and you are hosting multiple websites on your one EC2 server, in that case you might require more than one elastic IP address because each website, like I said, should have a static IP address associated with it. So with that, we have answered this question, guys. So the next question says, what are the best practices for security in Amazon EC2, right? Now there are ways that you practice that you have actually learned from somewhere, and the next way is the best way to do it, right? Now Amazon has actually given out some best practices that you should do when you are actually using their services. So if you follow these best practices, these are actually very efficient, and Amazon suggests you that it should be followed. So let's look at the best practices, guys. So one should use IAM to control access to your AWS resources. So IAM is basically a tool wherein you grant access to your users for your AWS resources, in the sense that if you are a company and you have one AWS account with you, and some of your employees want to actually review what instances you have launched, it is not advisable to give your account information to your employees. What you can do is you can actually assign a role for that particular user, as in, say, that user has to be given only the view rights. So he can only view your AWS dashboard. He cannot change anything, or he cannot launch a new instance or delete one, right? So like it says, you should use IAM to control access to your AWS resources. You should restrict access by only allowing trusted hosts or network to access ports on your instance, right? And then you should review the rules in your security groups regularly. You should review the inbound IP addresses, the outbound IP addresses, so that there is no malicious server that is trying to interact with you, right? And only open up permissions that you require. You should not play around with the permissions of a particular server or instance, because if you don't know anything, you might cause a permanent damage to a server. When I say permanent damage, I mean it might be a damage for your business, right? And it says that disable password-based logins for instances. Password can be found or cracked. So right, yeah. So if you log in using your passwords, those passwords can be cracked using brute force, or maybe guessing, or maybe someone might see you typing that particular password and your account might get compromised, right? So you should not use password-based logins. You should basically try using your public key, private key setup, wherein that public key is uploaded, matched against your private key, and then you get the authentication. Yes, all right. So one should try using that instead of password-based logins. All right, guys. So these are the best practices for using EC2. Any doubts in whatever we have discussed? Anything that you didn't understand here? Okay, so let's move forward and let's move on to the next question. So we are done with these two questions, guys. We covered around 10 questions. Okay, so let's begin with the next section, which talks about Amazon storage. All right. So let's look at our first question. You need to configure an Amazon S3 bucket to serve static assets for your public-facing web application. Which method will ensure that all objects uploaded to the bucket are set to public read? Alright guys, so let's look at the options here. So the first option is set permissions on the object to public read during upload. Alright, so this is not something that I will suggest you, because every time you shall upload an object, you shall set its permission to public read, which is not possible. Alright, so it is not something which is robust, right? The second option is configure the bucket policy to set all objects to public read. This is something that we can do, but let's explore the other options as well. Use IAM roles to set the bucket to public read, not something that I recommend. And then Amazon S3 objects default to public read, so no action is needed. This is not something which is there. All right, so here we will say that we should configure the bucket policy to set all objects to public read, right? So rather than making a change, so like I said, it is not possible to make change to every object, right? So rather than making changes to every object, it is better to set the policy of the whole bucket, right? IAM is used to give more granular permissions. Since this is a website, all objects will be public by default. All right, so like the question says, it's a static website, right? So the default permission for the objects, it will be public by default. And if you want it to be only public read, you have to manually set it in the bucket policy once. And whenever more objects are added to the bucket, then all the objects shall have that property of public read. All right. All right. So the question says a customer wants to leverage S3 and Amazon Glacier as part of their backup and archive infrastructure. The customer plans to use third-party software to support this integration. Which approach will limit the access of the third-party software to only Amazon S3 bucket named company backup? All right, so let's look at the options. A custom bucket policy limited to Amazon S3 API in 3 Amazon Glacier archive company backup. No. A custom bucket policy limited to Amazon S3 API and company backup. Okay, a custom IAM user policy limited to the Amazon S3 API for the Amazon Glacier archive company backup, and the D option is a custom IAM user policy limited to the Amazon S3 API and company backup. Now, as you can see here, guys, we are trying to give a very granular permission for the use of a S3 bucket called company backup for our software, right? So what we can do is we shall go with, I think, option D, wherein a custom IAM user policy will be limited to the Amazon S3 API and the company backup option, right? So C is not the answer, since S3 API will not be accessing Amazon Glacier. A company bucket policy, so bucket policies will not be used here. What will be used is an IAM policy, since we are going ahead for a third-party software which is trying to access the company backup bucket, right? So we shall be using an IAM policy for this particular thing. So like the explanation says, thank you from the previous questions. This use case involves granular permissions and hence IAM would be used here. All right, makes sense. Next question, a customer implemented AWS storage gateway with the gateway cached volume at the main office, right? So the gateway has a volume at the main office and even takes the link between the main and the branch office offline. So the link gets broken because of some reason. Which methods will enable the branch office to access their data? All right, so let's look at the options here, guys. So the option A says restore by implementing a lifecycle policy on the Amazon S3 bucket. Okay. B option is make an Amazon Glacier restore API call to load the files into another Amazon S3 bucket within 4 to 6 hours. Now 4 to 6 hours is a lot of time. Launch a new AWS storage gateway instance AMI in Amazon EC2 and restore from a gateway snapshot. This seems feasible. Create an Amazon EBS volume from a gateway snapshot and mount it to an Amazon EC2 instance. Now guys, what you should take from this question is, forget about the options, right? What you should take from this question is that we are talking about a business here, right? And the link has gone down. Now, rather than troubleshooting the problem or trying to understand what the problem here is, you should straight away go ahead and launch a new connection, right? So I think we should go with option C, that is launch a new AWS storage gateway instance AMI in Amazon EC2 and restore from a gateway snapshot. And that is what it is here, because like I said, time is of the essence in a business, right? And I think when time is of the essence, you won't want your link to be up in the next 4 to 6 hours. You want it then and there, right? And that is the reason you should actually go ahead and launch a new connection. So let's say launch a new AWS storage gateway instance, AMI, and Amazon S3 and restore from the gateway snapshot. So your gateway might have dumped a snapshot. It's recent configuration, so you can take that snapshot and be restored in a couple of minutes, say like maximum by a half an hour, right? So one option says 3, 4 to 6 hours. That is actually not viable. All right, moving ahead, guys. Let's move on to the next question. When you need to move data over long distances using the internet, for instance, across countries or continents to your Amazon S3 bucket, which method or service will you use? All right, so the options are Amazon Glacier. So no, obviously Amazon Glacier is an archiving service. We'll not be using it. Amazon CloudFront, it's a content delivery network. We can actually use it. And then we have Amazon Transfer Acceleration. It basically accelerates your transfer using CDN, which can be used. And then we have Amazon Snowball, which is basically used when you're transferring data over long distances, right? When you have huge amount of data and you want it to be moved, you actually use Amazon Snowball. But the thing with Amazon Snowball is, guys, that it is only limited to the US right now. And over here, we're talking about transferring data across continents, right? So Snowball is out of the picture. Amazon Glacier is out of the picture. And transfer acceleration is actually using CloudFront for transferring data. right? So with transfer acceleration, what happens is your data is cached to a nearby location, and from that location you receive your data. So that data comes at a very high speed rate than your normal traditional transfer, right? So you shall go ahead and do it with transfer acceleration. Let's see what the answer is. So yes, it is transfer acceleration. Let's see what the explanation says. You will not use Snowball because for now the Snowball service does not support cross-region data transfer. And since you're transferring across countries, Snowballs cannot be used. True. Then transfer acceleration shall be the right choice here as it throttles your data transfer with the use of optimized network paths, which is CDN, and Amazon Container Linear, exactly up to 300% compared to normal data transfer speed. So your data transfer speed is increased up to 300% as compared to when you're transferring it traditionally, right? So transfer acceleration should be the choice for you. So, okay, so let's go ahead then. So the next question is, how can you speed up data transfer in Snowball? Okay, so let's see. The data transfer can be increased by performing multiple copy operations at one time. That is, if the workstation is powerful enough, you can initiate multiple CP commands, each from different terminals, all right? So if your workstation has a lot of processing power, you can actually exploit that power by launching multiple terminals in your workstation and starting the CP command for different chunks of your files. So then data will actually get transferred parallelly, which will actually help copying things faster, right? Copying from multiple workstations to the same server. So again, you are copying everything parallelly, and hence it increases the threshold or the bandwidth of the data coming into Snowball. Transfer large files or by creating a batch of small files. This will reduce the encryption overhead, right? So you can transfer large files, or you can create a batch as a group of small files, which is again a large file, so that the encryption overhead reduces because each file is encrypted when it is transferred to the Snowball. And eliminating unnecessary hops, that is basically what it's saying is that you should not have an intermediate system in between. It is better if you transfer directly from your main server to the Snowball. So with that, the transfer speed will increase, and hence your data transfer will happen more faster, right? So this is how you can speed up data transfer in Snowball. Pretty straightforward. I know it might be clear to you. So we are done with the Amazon storage section, guys. We are done with the questions. Let's go ahead and discuss the virtual private cloud now. Now this is, guys, a very important section because most of the questions will be asked from this section. So let's actually focus more on this section now. So let's see the first question. So it says, if you launch an EC2 instance and assign each instance a predetermined private IP address, what should you do? So you should launch the instance from a private Amazon AMI, assign a group of sequential elastic IP address to the instance, launch the instance in a VPC, or launch the instance in a placement group. So I told you guys that placement group is basically when you want to increase the transfer speeds between two particular instances or two particular servers, right? So, and what we want to do is we want to assign each instance a predetermined private IP address. So placement group will not help. Assign a group of sequential elastic IP address to the instances. We can do this, but it will cost us because we are taking in a lot of elastic IP addresses. Launch the instance from a private AMI. Now, elastic IP address, guys, it could be done when we were dealing with public IP addresses, but what we are dealing with is private IP addresses, that is the IP addresses which are there within your organization. So obviously, elastic IP addresses again cannot be used. So D and B option is out of the picture. Then launch the instance from a private AMI. So this is irrelevant. It doesn't make sense. So the C option, which says launch the instance in an Amazon VPC, is the correct option because the best way of connecting to your cloud resources from your own data center is the VPC. Once you connect your data center to the VPC in which your instances are present, each instance is assigned a private IP address, which can be accessed from your data center. And you can actually specify which instance should have what IP address because it's a private IP address, right? So you have full control of it. Okay, so is it possible to change the private IP addresses of an EC2 while it is running or stopped in a VPC? So is it possible to change IP address of an instance if it's running or if it's stopped? right? So let's see what is the answer for this. So primary private IP addresses is attached to the instance throughout its lifetime and cannot be changed, right? But secondary private IP addresses can be unassigned, assigned, or moved between interfaces or instances at any point. All right, so you cannot change the primary private IP address for your particular instance, but you can go ahead and change the secondary private address for your particular instance, if even if it is running or stopped or whatever, right? Obviously not if it's terminated. So the two states which comes there is running or stopped, right? So if your instance is running, you can change the secondary IP address, but in none of the cases you can change the private IP address because it is attached to the system as long as the system is running. All right, pretty straightforward. Let's move on to the next question. So the next question is, why do you make subnets? So let's look at the options. Because there is shortage of networks to efficiently utilize networks that have a large number of hosts, because there is shortage of hosts and to efficiently utilize networks that have small number of hosts. All right, so subnets, let's understand what are subnets. So subnets are basically subnetworks that you create in a network to increase the accessibility or managing the number of hosts. Now, the reason you do it is because there are a lot of hosts in a company, right? There are a lot of computers. Now, to make managing these computers easier, what you can do is you can subdivide the network, right? And with each subdivision, the number of hosts gets divided, and hence it becomes easier for you to handle the number of hosts, right? And that is the reason it is used. So if you look at the explanation, it says if there is a network which has a large number of hosts, managing all these hosts can be a tedious job. Therefore, we divide this network into subnets or subnetworks so that managing these hosts becomes simpler, right? So you make subnets to make your job easier of managing a large number of hosts, all right? Moving ahead, guys, let's move on to the next question, which is which of the following is true? Okay, this can be tricky. You can attach multiple route tables to a subnet. You can attach multiple subnets to a route table, both A and B, and none of these. So the right answer is you can attach multiple subnets to a route table. So basically, why we'll not attach multiple route tables to a subnet is because a route table is basically used to route your packets to a particular destination, right? So if you have multiple route tables in your network, it will lead to confusion as to where the packet has to go, because each route table will have then a different location. And if it has the same location, there's no point of having multiple route tables, right? So a packet can go only one place, and that is why you have only one route table. But you can have a lot of subnets which are attached to a route table to ease out the routing process, all right? So you can attach multiple subnets to a route table is the correct option in this particular question. All right, moving ahead, guys. So in CloudFront, what happens when content is not present at a location and a request is made to it? So CloudFront is the content delivery network that I told you guys about. So what happens when the content is not present at an edge location? So an edge location is basically a place which is nearer to the user, right? So the question says, if the guy is trying to access a website which has CloudFront enabled, right? But the edge location which is near to that user is not having that particular website, what will happen in that case? And the options are: an error 404 not found is returned. CloudFront delivers the content directly from the original server and stores it in the cache of the edge location. The request is kept on hold till content is delivered to the edge location, and the request is routed to the next closest edge location, right? So let's see what's the correct answer. All right, so in this case, what happens is the first request, which happens like this, is actually served using the origin server. But meanwhile, your request is being served from the origin server, the website is cached onto the edge location as well, the new edge location which has not been used as of yet. Otherwise, the website would have been cached here as of by now, right? But could be a case wherein you have newly applied CloudFront to your website and it is not there at much of the edge locations. So when a user tries to access it from a new location, and if the edge location near to him does not have those many servers, what happens is your website is served using the origin server, so you might experience some more latency, right? The latency could be more, but meanwhile, while you'll be served that website will be cached in the background to the edge location. So whenever you'll be trying to access that website from the next time, latency will actually be less because now the website will be there in your edge location. All right. So this is what happens. Moving ahead, if my AWS Direct Connect fails, will I lose my connectivity? So Direct Connect is basically a way that you connect to the AWS infrastructure. So it is basically a lease line that you have between your infrastructure and AWS infrastructure. So let's say what the explanation says. So if a backup AWS Direct Connect has been configured, in the event of a failure, it will switch over to the second one, that is the failover, right? And it is recommended to enable bifunctional forwarding detection when configuring your connections, or to ensure easier, faster detection and failover. So if you enable bidirectional forwarded detection, what will happen is that if there is a failure which is going to happen, it will be detected more faster, and in that case you can take preventive measures, right? On the other hand, if you have configured a backup IPsec VPN connection, all VPLC traffic will fail over to the backup VPN connection automatically, right? So if you have taken the measures, it will go on to the failover. But if you do not have AWS Direct Connect failover like installed in your in-network or in your infrastructure, your VPC traffic will be dropped in the event of a failure. So your VPC traffic will actually be dropped. You will no longer be able to access the infrastructure that you were connected to in case it fails and you have not planned any failover, right? So this is what happens. Okay, so yeah, next question, guys. So yeah, so we're done with VPC, guys. Let's move on to the next section, which is Amazon database. All right, so our first question says, if I launch a standby RDS instance, will it be in the same availability zone as my primary? And the options are only for Oracle RDS types, yes, only if it is configured at launch, or no. So if you launch a standby RDS instance, will it be in the same availability zone? So I think it's a no, because what's the point of having a same standby RDS instance if it's in the same availability zone? And it agrees with me. So since the purpose of having a standby instance is to avoid an infrastructure failure if it happens, then the standby instance is stored in a different availability zone, which is physically different independent infrastructure, right? So it makes sense, because if your standby instance is in the same availability zone as your RDS or as your primary RDS instance, and that particular availability zone fails, your standby as well as your primary instance will go down, and you don't want that, right? And that is the reason you have a standby instance. So you have a standby instance. Whenever your primary instance is down, you will fail over to the standby instance. So if there's a natural calamity in that particular region, or there's a power outage in that particular region, your primary instance will fail, and you need to have your standby instance in some other availability zone, so that whenever one availability zone goes down, your traffic will be redirected to the other availability zone where your standby RDS instance has actually been launched. All right. So this was about it, guys. Pretty straightforward. Let's move on to the next question. So when would I prefer provisioned IOPS over standard RDS storage? So provisioned IOPS basically offers you higher input output rates, right? So when do we prefer provisioned IOPS? So the options are, if you have a batch oriented workload, if you use production, online transaction processing, OLTP workloads, if you have workloads that are not sensitive to consistent performance, or all of the above. All right. So basically, you would use provisioned IOPS when you want higher rates of input outputs whenever you're storing something. And I think when you have a batch oriented workload, that is continuous in nature, right? So when something is continuous in nature, you obviously want it to be read faster and written faster as well, right? So the input output rate has to be higher. And I think the option A is the perfect use case for this. So I would prefer a provisioned IOPS whenever I have a batch oriented workload. Let's see what the answer says. Okay, and the answer agrees with me as well. So provisioned IOPS deliver high IO rates, but on the other hand, it is expensive as well. Mention, they enable full utilization of systems, therefore provision IOPS will be preferred for batch-oriented workload, right? So a batch-oriented workload has continuous workload, right? There is no interruption. It will be utilized. The provisioned IOPS that you'll be paying for will be utilized fully. But if you look at other workloads with like the online transaction and the B option that I had with, that is online transaction processing workload, it wouldn't have been continuous because you don't know when your workload will be back, right? So, and provisioned IOPS, like I said, is expensive. So why not use a workload which is continuous and at the same time does not intervene or does not have any pauses or is not idle for some time, and hence it will be value for your money, right? So I'll choose the provisioned IOPS whenever I have a batch-oriented workload. That'll get the things done faster. All right, moving ahead, guys, let's look at the next question, which is, if I'm running my DB instance as a multi-AZ deployment, can I use a standby DB instance for read or write operations along with my primary DB instance? So no, you cannot do that because the reason for a standby instance is basically for a failover, right? So no, a standby instance cannot be used with primary DB instance. Only one DB instance can be used at a time. The standby DB instance is solely used for standby purposes. All right, and the explanation says it cannot be used unless the primary instance goes down, right? So you cannot use your standby instance unless and until your primary instance is not working anymore. All right, so you cannot use them simultaneously. Okay, having said that, guys, let's move on to the next question. So your company's branch offices are all over the world. They use a software with a multi-regional deployment on AWS. So they're using multi-regions for their particular workload. They have servers in multi-regions, and they use MySQL 5.6 for data persistence. Okay. The task is to run an hourly batch process and read data from every region to compute cross-regional reports, which will be distributed to all the branches. Okay, so it is an hourly process wherein your data will be read from every region. It will be processed and will be distributed to all the branches again. This should be done in the shortest time possible. So basically time is of the essence. And how will you build this DB architecture in order to meet the requirement? So the requirement is that it should be done in the shortest time possible. And the kind of workload is a batch process. And once it gets the reports from all the regions, it is computed and the computed result is sent back to the individual offices. So let's look at the options. For each regional deployment, use RDS MySQL with the master in the region and read replica in the headquarters. For each regional deployment, use MySQL on EC2 with the master in the region and send hourly EBS snapshots to the HQ region. For each regional deployment, use RDS MySQL with the master in the region and send hourly RDS snapshots to the HQ region. For each regional deployment, use MySQL on EC2 with the master in the region and use S3 to copy data files hourly to HQ region. Alright, so first of all, we should not be using MySQL on EC2 because it is not good practice. We should always go for distributed workloads and hence we'll be using RDS. So B and D are out of the picture. So since we're using RDS MySQL with the master in the region and read replica in the HQ region, and the other option says with the master in the region and send hourly RDS snapshots to the HQ region. All right, so let's see what the answer is for this. So the answer is RDS MySQL with the master in the region and a read replica in the HQ region. Now for this so let's look at the explanation. So we will take an RDS instance as a master because it will manage our database for us. So since we have to read from every region, we'll put a read replica of this instance in every region where the data has to be read from. Option C is not correct since putting a read replica would be more efficient than putting a snapshot. Obviously because a read replica is lesser in size than a snapshot. A snapshot is huge, right? If you take the snapshot of your primary instance every time, it will actually be very huge for you to send it to every office. It'll actually slow down the bandwidth. It'll eat up a lot of bandwidth of your internet because you'll be sending snapshots at an hourly basis. So if you see this, you'll be sending snapshot every hour, and snapshots, like I said, are not small in size, guys. They're pretty huge, right? So it shall not be an efficient way of doing it. So the better way of doing it is by installing a read replica in the HQ regions, wherein From the read replica, you can read it because all you want to do is read the report, right? So you can do it using the read replica. So the next question says, can I run more than 1 DB instance for Amazon RDS for free, right? So let's look at the explanation. So yes, you can do that, and you can do it actually using the free tier, right? Any use exceeding 750 instance hours will be billable for you, right? And actually what happens in free tier, it's basically like this, that you, and in totality you are given 750 instance hours, right? So you can either run an EC2, or you can run an RDS, or you can run some other service. Now the thing is that with RDS, for example, if I'm just taking for an example, like if you run 2 RDS instances, right? For now the number of hours that has been allotted to you is 750 hours, right? So if you run 2 instances together, these instance hours will actually be divided by 2, and then each of your service will run for free for 375 hours, right? And similarly, if you increase the number of instances again, so it will be divided by the number of instances that you have running right now. Now, this is not limited to RDS, this is limited to each and every service which is there in free tier, right? So the more the number of services, lesser the number of hours become, or the division takes place between the number of hours, all right? So next question says, which AWS service will you use to collect and process e-commerce data for near real-time analysis, right? So the options are Amazon Elastic Cache, Amazon DynamoDB, Amazon Redshift, and then you have Amazon Elastic MapReduce, right? So which service will you use to collect and process e-commerce data for near-time analysis? So DynamoDB is a NoSQL database, right? Elastic MapReduce is a Hadoop cluster. Redshift is basically a database warehouse, and Elastic Cache is basically a very fast memory that you have. So it is basically used when you have data. So it's basically similar to your RAM, which is accessible more faster than your primitive storage devices like your hard drive or your SSDs, right? So same is the case with Elastic Cache. So the answer for this would be Amazon DynamoDB and Amazon Redshift. Now Amazon DynamoDB, why it will be used? Because it's a NoSQL database, right? For every unstructured data that will be coming from an e-commerce website will be stored in your DynamoDB. And Redshift is actually a data warehouse, which is basically used for analysis, right? So it'll pick up the data from DynamoDB, analyze it, and then you can review it for whatever analysis you want to do. So this is what we'll be using. We'll be using DynamoDB and we'll be using Amazon Redshift. All right, guys. Sounds simple. Okay, so like basically you can answer each and every question, guys, that we have discussed so far. It's not something that it's rocket science that you can't understand it. The basic thing is, the underlying thing is that you should understand each and every service properly, right? So if you don't know what DynamoDB is, or if you don't know what Redshift is, you cannot answer this question. But if you have the basic understanding that DynamoDB is a NoSQL database and Redshift is a data warehouse service, you can easily identify that for analysis. I will use Redshift, and since the e-commerce data is going to be unstructured, the data that I'm going to analyze, it will be stored in DynamoDB. Right? Pretty common sense. Okay, so let's move on to the next question then. So our next question says, a company is deploying a new 2-tier web application in AWS. The company has limited staff and requires high availability, and the application requires complex queries and table joins. Which configuration provides the solution for the company's requirement? So let's look at the options here. The option A says MySQL installed on 2 Amazon EC2 instance in a single availability zone. So single availability zone will not be something that we should be looking out for, because we want it to be highly available. Our application, Amazon RDS for MySQL with multi-AZ. Okay, then we have Amazon Elastic Cache. It's not a database. Then we have Amazon DynamoDB. So DynamoDB is a NoSQL database. MySQL is a relational database, right? And our application requires complex queries and table joins. Now the answer for this, guys, it should be DynamoDB, because DynamoDB has the ability to scale more than RDS or any other relational database service, and therefore DynamoDB would be an op choice, right? And we can deploy it in multi-availability zones as well. and then it shall serve our purpose of being highly available, and also it can withstand complex queries and table joins. All right, seems good enough. Let's move on to the next question. So our next question is, what happens to my backups and my DB snapshots if I delete my DB instance? All right. So when you delete your DB instance, guys, you have an option of creating a final DB snapshot. Now, if you do that, you can restore your DB from that DB snapshot. RDS retains the user created DB snapshot along with all other manually created DB snapshot after the instance is deleted. But if you delete the snapshot of your DB instance, there is no way that you can get it back. But once you try deleting your instance, it will always ask you whether you want a snapshot or not. Right? Even if you are in a hurry and you click yes, that yes is actually for creating a snapshot, right? And people tend to go for a positive answer, right? So in any case, if you press yes, it will create a snapshot. You have to be careful if you don't want a snapshot to be created. All right. So yeah, so that is the scene. So this question was pretty straightforward. Answers are our query. Let's move forward. So which of the following use cases are suitable for Amazon DynamoDB? All right. So DynamoDB, like I told you guys, it's a NoSQL database. So is it managing web sessions, storing JSON documents, storing metadata for Amazon S3 objects, or running relational joins and complex objects? Now the answer is managing web sessions, storing JSON documents, and storing metadata for Amazon S3 objects, right? So it's A, B, and C. Now relational database store entry data in the form of table and rows, right? So non-relational database represent data in the form of JSON documents. Running relational joins itself answers the fact this stance is more suitable for a relational database, that is running relational joins and everything, right? And DynamoDB being a NoSQL database can be more related to task A, B, and C, right? So if you look at the options, running relational joins, although you can do that on DynamoDB as well, but why to do it when you have relational databases, right? So I think the most apt for the fourth should be a relational database. The first three are perfectly apt for our DynamoDB, and hence we have put the answer like this. All right, let's move on to the next question. So our next question is, your application has to retrieve data from your user's mobile every 5 minutes, and the data is stored in DynamoDB. Okay, so your data is retrieved every 5 minutes and it is stored in DynamoDB. Later every day at a particular time, the data is extracted into S3 on a per user basis, and then your application is later used to visualize the data to the user. So what basically is happening is your mobile is sending data every 5 minutes to DynamoDB, and every day on a particular time, the DynamoDB data is dumped onto S3, and then that data which is dumped on S3 is used for analysis. All right. So this is the particular task. You're asked to optimize the architecture of the backend system to lower cost. What would you recommend? All right, so these are the options. Use Elastic Cache to cache reads from the Amazon DynamoDB table and reduce provisioned read throughput. All right, so like I said, Elastic Cache is a very fast storage service. So whatever is there on Elastic Cache can be read very fast, right? And it can be dumped onto Elastic Cache at that very much speed as well. So let's see what our explanation says. Since our work requires the data to be extracted and analyzed, to optimize this process, a person would use provisioned I/O. But since it is expensive, using an Elastic Cache memory instead to cache the results in the memory can reduce the provision read throughput and hence reduce cost without affecting the performance. So absolutely right. If you want increased performance, since we want to analyze data, we have to actually read a lot of data and then be able to visualize it, right? So for reading a lot of data, one way of doing it is that you have it on your S3 main hard drive, so S3 file system, and you read it in a particular fashion, and then you read it in a normal fashion. The other way to do it is that dump the data on Elastic Cache and read it from there. Now, as you know that the data which is dumped on Elastic Cache can be done at a very fast rate, and even the reading can be done at a very fast rate. Having said that, if you had to use provisioned I/O in this case, since you're using it every day, provisioned I/O is very expensive. In terms, it is expensive. It is more expensive than your Elastic Cache, right? And if you use Elastic Cache, you'll get the same results, right? So why not use Elastic Cache than Provision IO when both are offering high speeds, right? So this is how you can improve the backend architecture. Moving on, our next question says you are running a website on EC2 instances deployed across multiple availability zones with multiple AZ, RDS, MySQL, extra large DB instance. The site performs a high number of small reads and writes per second and relies on an eventual consistency model. After comprehensive tests, you discover that there is a read contention on RDS MySQL. Which are the best approaches to meet these requirements? Right? And we have to choose two answers. So what basically we're trying to do is we are running a website on EC2 instances, right? Which is deployed across multiple AZs with an extra large DB instance. So it is deployed across multiple AZs and the website is actually deployed on EC2, right? It performs a high number of small read and writes per second and relies on eventual consistent model. Okay. After comprehensive tests, you discover there is a read contention on Radius MySQL in the sense that the instances that are for your website have a read contention in the sense they're competing to read on RDS MySQL. Which are the best approaches to meet these requirements? Now, how can we reduce the contention so that the latency can be reduced? Right, so let's see the answer for this. So the answer is deploy Elastic Cache in-memory cache running in each availability zone, and C, increase the RDS MySQL instance size and implement provisioned IOPS. Okay, so what basically this will do is that first of all, we're increasing the instance size so that we can serve more users, and at the same time to serve their requests faster, since we are doing a lot of read and write, small read and writes, and hence a lot of read and writes. To do them faster, we have implemented provisioned IO. Along with that, we can also deploy an Elastic Cache which can dump data onto itself. So basically why are we using Elastic Cache is because sometimes there is the reading of data which has already been read, right? So something which is accessed more frequently can be stored on Elastic Cache. And how will that help is that with provisioned IO, you are charged for each and every input output, right? But if that frequently accessed data is on Elastic Cache, the IO for that can be reduced and hence cost can be reduced. And at the same time, when you're reading it from Elastic Cache, you are reading it from the same exact speed, right? So with provisioned IO, you have high speed, and with the Elastic Cache as well, you have high speed, right? So when you're doing that, you are getting the data faster as well, and at the same time, you're reducing costs. So that should be the viable solution for this. Moving further, guys, let's start with our next question. So our next question says, a startup is running a pilot deployment of around 100 sensors to measure street noise and air quality in urban areas for 3 months. All right. It was noted that every month around 4 GB of sensor data is generated. The company uses a load balanced auto scale layer of EC2 instances and RDS data with 500 GB standard storage. The pilot was a success, and now they want to deploy at least 100K sensors, which need to be supported by the backend. Okay, so you need to store the data for at least 2 years to analyze it. Which set of the following would you prefer? Okay, so basically they are increasing the number of sensors and they want to store the data for at least 2 years, and after that they'll analyze it. So they're asking which option to choose. Options are add an SQS queue to ingestion layer to buffer writes to ARDS instance, ingest data into DynamoDB table, and move all data to Redshift cluster. Okay, replace the RDS instance with the 6-node Redshift cluster with 96 TB of storage, or keep the current architecture but upgrade the RDS storage 3 TB and 10K provision IOPS. And the answer is replace the RDS instance with the 6-node Redshift cluster with 96 TB of storage. And the explanation is that you should be preferred. Redshift cluster would be preferred because it is easy to scale. Also, the work would be done in parallel through the nodes. Therefore, is perfect for a bigger workload like an R use case. Okay, sounds well. Since each month 4 GB of data is generated, therefore in 2 years it should be around 96 GB. And since the servers will be increased to 100K in number, 96 GB will approximately become 96 TB, and hence option C is the right answer. Okay, so it's a mathematical answer, guys. So it says with 96 GB for 2 years, each month 4 GB of data is generated, all right, and therefore in 2 years it should be around 96 GB. It's basically 2 years has 24 months, so 24 into 4 is 96 GB. And since the servers will be increased to 100K, right, so now we had 100 trillion sensors, so we are increasing it by 1,000 factor, right? So if 100 sensors were generating 96 GB in 2 years, 100,000 will increase 96,000 GB, right? So 96,000 GB is approximately 96 TB, and hence this answer, right? Where you're using a Redshift cluster because it is easy to scale, and we have chosen 96 TB because that is how we came to it mathematically. All right, so this is the answer.
So first and foremost, I would start by talking about different job trends that are there in the current market. If you talk about cloud engineering, we would also discuss certain parameters that affect a cloud engineer's salary. Then we would get into the details of job descriptions that are there in the market that different companies require in order to hire a cloud engineer. Moving further, I would also talk about what skills you should possess and how should you actually go ahead and shape your resume in order to apply for certain companies. Having said that, guys, let's just move further and take a look at some of the job trends. Now, guys, what I've done is I've actually gone ahead and jotted down certain figures for job vacancies in US and in India, which tell the number as in, okay, these are the vacancies. Now, these numbers are specific to Indeed, which is a popular job portal. There are quite a few other portals. So this number might not be consistent, it might vary. But as far as Indeed is concerned, these are the numbers and these are the vacancies. So guys, now these are certain factors here. I would like to lay stress on quite a few other pointers as well. To do that, what I've done is recently I've written an article on this particular topic, which talks about job trends and salaries in particular. So I would like to refer that blog and walk you through that blog so that we can discuss some of these pointers in little more detail. So let me just quickly switch to the blog part. So yeah, guys, this is the article that I've written recently. If you take a look at it, there are certain factors here. Now, ZipRecruiter, they gave in a number of or the average salary of a cloud engineer, and they state that it is in the range of somewhere around 104K to 145K dollars. Now, that is a huge amount if you talk about US dollars. And even if you talk about the salary in India, now the fact that I'm recording this session from India, I believe I should give the number in Indian rupees as well. And the currency states that, or the figures state that the amount is somewhere in the range of 15 to 20 lakhs for a mid-level ranged experienced person. Even for a fresher, the amount is fairly high, but it actually depends on the skill set that you have. Having said that, it also states that is ZipRecruiter that it goes as high as somewhere around 250K US dollars, which is a very big number, right? And if you can actually go ahead and pick up the right amount of skills, you would be getting a high amount of salaries, all I can say. Having said that, let's just move further and take a look at some of the other trends that are there in the market. Now, this is another interesting image which is given by Tech Target. Now, they have put in certain stats in front of you. Now, if you take a look at it, they say that the average salary in USA is somewhere around 115,000. Now, guys, this number might vary depending upon the number of data you take in because different people refer to different websites and they pick up data from different sources. So based on that data set, this number might vary a little. As I've already told you, it is somewhere in the range of 105 to 145K US dollars. Again, if you put in or take in data from other sources, that might vary a little, but that is more or less what the salary that you can expect. Another important pointer here is that you can expect a lot of growth rate in cloud computing in recent or in near future. If you take a look at it, it says that it's a 121% growth rate for job postings between 2013 to 17. So these are the number of job postings that are there in the current market, or these are the numbers that have actually taken a rise in recent times. And guys, this number is going to rise. Why? Take a look at the number of global spend these companies are doing these days when you talk about cloud computing in particular. 2017, it was somewhere around 153.5 billion. Then it moved to 186.4 billion. And by 2021, it is expected to go somewhere around 302, which is almost the double that you had in 2017, guys. So the fact or this fact in particular states that companies are ready to invest in this particular domain. And that means they would be requiring people who have skills in this particular domain and hence the need for this kind of a role. So if you talk about job trends, salary, cloud computing is something that is booming and it is going to boom in near future as well. So you can expect good pay scale, you can expect good kind of life if you talk about a career in this particular domain. There's one more fact here, guys. These are some of the skills that employers normally demand a lot. As you can see, Python is something that is trending. If you talk about programming languages, everybody knows how important Python is because it's making news everywhere. People even claim that it has dethroned Java. I do not know whether it's true or not. I don't get into those kind of debates. The reason people are claiming that is because it has actually changed the way programming happens these days, and that is why the popularity. And one more factor that I would like to state here is if you take a look at its predecessor, not predecessor, but the one that follows before Python in this chart, it is AWS. It says 50% or 58% of people normally demand the skill in the market. So yes, you can gauge by it as in how popular AWS has become. It is a popular cloud platform. So the fact that AWS goes well with all the programming languages or all the tools that follow in this chart, you can make sure that, or you can assume how popular AWS or cloud platform has become. So again, this stat states that if you try to make a career in this domain, it is going to be a good option for you, or it's going to be a bliss for you is all I can say. Let's move further, guys, and take a look at some of the other factors as well. Now let's jump into the salary part, which follows our pattern in the agenda, which I discussed. So when you talk about different parameters that affect salary, one of them is what are the companies that are trying to hire cloud engineers and what is the salary they're offering. Now, guys, if you take a look at some of the numbers here, Resolute Technologies, VMware, Amazon, Accenture, Microsoft. Now, these are popular companies, guys. And on an average, they're paying you somewhere around 170, 160,000 US dollars, which is a huge amount. And again, if you ask me about the companies that are going to hire for cloud engineering, almost all the major companies that deal with computing or data processing, they are going to switch to cloud in near future. Companies like GE, General Electricals, they've actually gone ahead and moved to cloud already, which is a big company, and quite a few other companies. Now, if you talk about Amazon, if you talk about Google, Microsoft, they themselves are marketing cloud computing. They have their own service providers that actually act as vendors in providing these cloud computing services. So yes, major companies are going to move to cloud and they're going to hire you as a cloud engineer. Having said that, let's take a look at some of the other factors that concern a salary of a cloud engineer. Now, guys, if you take a look at salaries based on the job roles, now these are the three major job roles, that is a solutions architect, a DevOps engineer, and a SysOps engineer. And these are the average salaries. I do not agree with these numbers that much. Numbers can be deceiving at times. Probably solutions architect is one of the most demanded cloud jobs. I mean, it is the most popular cloud certification, no matter what vendor you talk about. Solutions architect is something that people demand a lot. So these are some of the job roles. Now, apart from these job roles, there are various other job roles as well, but more or less they follow this particular category or these three categories. As we move further, we would be talking about these job roles. Do not worry about that, but these are some of the numbers I want you to take a note of. Again, guys, based on the location, your salary might vary, and these are some of the positive numbers that are there. Again, I've used Indeed as a source here, if I'm not wrong, because most of the data that I've picked from it is a combination of Indeed, Payscale, and a couple of other websites that are popular when you talk about job trends. So yes, when you talk about Indeed, these are the numbers that they've given, as in based on the states or the location in USA, these are the salaries which people can claim on an average. You have numbers for India as well. Now, these are three of the major states that recruit. I know Delhi is one more state, but their numbers are similar to Maharashtra mostly. So, yep, you can take that into consideration as well. And I'm sorry, Delhi is not a state city, which popularly hires a lot of engineers as well. Delhi, Gurgaon, in that domain or in that region in particular, the salaries are similar to what you get for Maharashtra, guys. So, yep, these are the three states that the website shows numbers for, guys. And Karnataka, which is the IT hub of India, you can see the salary goes as high as this. This is the average salary. Maharashtra in particular, this is what, which is very closely followed or follows very closely to Karnataka. Tamil Nadu too has a lot of requirements for cloud engineers. And as I've already mentioned, if you go to the Delhi part of the country, yes, there too people are looking for these skills as well. It's not that the other parts of the country are not looking for people with these skills. It's just that these are the major hubs and they come into the reckoning when you talk about the stats or the data. There are other regions and states where people are normally hiring cloud engineers there as well. I constantly go through or do market research a lot when you talk about cloud engineering in particular. And yes, I've seen requirements in other states as well. Again, guys, these are the number of job vacancies which you saw in the presentation. So guys, yes, these are certain numbers that are there. And again, the numbers are based on Indeed, guys. If you take a look at the other websites as well, you might find more numbers So again, this is just a parameter, guys. And to be honest, there are a lot more vacancies than what these numbers state. The problem here is people are not skilled enough to actually go ahead and get these jobs. So yes, if you are rightly skilled, definitely these jobs would be yours. Salaries based on experience, again, you can see mid-level has the most number of salaries, guys. Why is that? Because cloud engineering mostly is a branch where you would be expected to have certain skills that you've learned while you've worked. So an experience of 3 to 4 years is the best place or the best time for you to move to cloud. Even 2 years is what I would say. It's not that freshers should not move into this role. They can, but again, the number of placements that happen for freshers is lesser. Why? Because the chances of them getting picked as a cloud engineer mostly happens through campuses. I would be talking about this factor as well. Do not worry. Once we talk about the resume part, I would help you even if you are an entry level person, a mid level or mid skill person, or a senior person. I'd be talking about these pointers. I'm just stating certain numbers here. So entry level people normally find it a little difficult. The most expected part is mid level. Why? Because salary is something that companies can bargain on, and these people are rightly skilled. Senior level two, people hire these people. But what happens is, since you are very experienced, you normally would be expecting managerial kind of positions, right? So you cannot have too many manager positions. So it is understandable the number is not that high. But considering that as well, 180 on an average is a good number. So guys, these were some of the parameters I wanted to talk about, salaries and certain job trends. I hope I've discussed enough. So guys, let's just move further and switch to the presentation part where I would be discussing certain other pointers that concern cloud engineer. So guys, let's just move further and talk about cloud engineer skills and also the job description. Now guys, I've actually clubbed two topics from the agenda here, and I would be actually going to and forth while discussing these pointers because I feel they are very interlinked or very connected to each other. So let's talk about these pointers. First and foremost, let's talk about certain skill requirements. If you want to become a cloud engineer, what are the stuffs that you should know? Now, guys, for people who have experience, you probably might know some of these pointers already, but I am wanting to take everyone on this similar page. And while doing that, I would be talking it from the very basic part as well. So let's get started with the basics first, as in what are the skills or knowledge set that you have in order to becoming a cloud engineer? So you need to have an understanding of why do you need cloud computing and what are the different domains that impact cloud computing, because based on that you'd be able to decide as in, okay, what do you want to do with cloud computing? It is a very vast domain and it has various services that are there or that are made available to you, using which you can do so many things. You can focus on marketing, proper software development, architectural part. For that, you need to understand why do you need cloud computing, what are the different domains that it affects, and once you do that, probably you would be in a better state to decide how do you want to use cloud computing for your own benefit. Moving further, you would also be required to have knowledge about different cloud service models, as in these are something that tell you how can you use your applications or how can you build your applications using cloud computing. That is why understanding of this topic is important. You need to have an understanding of different deployment models, which again is similar to or related to cloud service models as well. It is the way cloud services are provided to you by your cloud vendor. That is why understanding of different deployment models is also important. You should understand why do you need to move to cloud computing and why is it different from an on-premise architecture or an infrastructure rather. Finally, you need to have an understanding of different cloud service providers or vendors in the market, because having an understanding and thorough knowledge of at least one cloud service provider is very important. And guys, when I say a cloud service provider, it is very important to understand that there are various in the market, but preferably people normally start with AWS and they gradually move to Azure, which are two of the most popular cloud service providers. So what are the computing fundamentals that you need to have? Now, as a cloud engineer, guys, I won't lie to you. I won't say that you don't need any prior programming experience or anything like that. As a cloud engineer, guys, you need to have understanding of computing fundamentals, and it is very important in becoming a good cloud engineer. What should you know? Networking is very important, guys. Now, it is not that much into programming, but understanding of computing, it starts with networking. You need to understand how routing works, what are different network protocols, what are different networking layers, etc., and how do you use networking for an organization, because it is very important. You would be talking about a lot of applications, a lot of data, a lot of scalability, application building and stuff like that. So for that, networking becomes very important. Computer security, guys. Now, when you talk about cloud, the first question people ask is it secure? Most of the people do not know what cloud computing does or how it ensures security. Let me give you a fact. They use shared security model. What it is, I won't be getting into the details, but you and your cloud vendor, you actually go ahead and decide certain security principles and those are implemented. So if you are working on a cloud platform and if you are into the security part, you need to ensure quite a few things as in how to make your application secure. What are the protocols that you should follow and stuff like that. And for that, you need knowledge about access policies, encryption, etc. Understanding of systems is very important, guys, where you need to know what are the different design principles, what kind of methodology are you using, and where do you get the knowledge for these things, your computer architecture. You need to have an understanding of databases. You need to learn SQL, which is very important because you are going to deal with a lot of data. And guys, since you're talking about cloud platform, you would be dealing with different kinds of instances or virtual environments. And for that, understanding of Linux fundamentals is very important. So these are some of the basics, guys, which you should understand. And I would suggest that if you are completely new to cloud computing, focus on these pointers as well. So these were some of the basic skills that you needed to have. Now let's just go ahead and take a look at certain job roles. And based on those job roles, what are the skills that you should pick up? Guys, now again, these are the responsibilities that even major companies would be expecting from you. So when I said I would be talking about job description, now these are certain roles and the pointers that I'm going to talk about, the responsibilities, those are the skill sets that major companies expect from you when you actually do go ahead and try to apply for cloud engineering jobs. So first and foremost, we have an cloud architect, cloud developer, and an admin. SysOps admin is nothing but system operations administrator. So guys, let's try to talk about these roles in detail. Guys, I won't be getting into the definition part. I would be sticking to what I've experienced till time when you talk about cloud engineering. So my definitions are going to be very general and basic so that everybody can understand. So if you talk about a cloud architect, these are the people who are responsible for drawing the blueprint. I mean, they actually design your application as in this is how it looks. So their part is designing, planning stuff like, okay, when I actually go ahead and build an application, this is how much I might be expected to probably scale, or these are the current softwares, or these are the current programming languages that I would be needing. They also take into consideration when it comes to migrating your application, which already exists on premise. So they need to understand what are the parameters that affect the current application on premises. And based on that, decide as in, okay, these are the changes that we need to make when we move this application to cloud. So this is what a cloud engineer does. They actually help you design a flow for your application to actually go ahead and work on cloud. Let's just move further and take a look at some of the common responsibilities that a cloud engineer or a cloud architect is actually responsible for. They're actually responsible for designing and deploying dynamically scalable, available, fault tolerant, and reliable applications, something I talked about while going through the definition part. They actually design and deploy applications. Now, these are some of the pointers that concern an application, like how available it is, how easily can scale, how fault tolerant it is. Let's not get into the details of that. I'm sure nobody wants to get into the details of that. You should be able to select an appropriate cloud service to design and deploy for your applications. I mean, you would be dealing with different cloud vendors. So you should know, okay, if I have real-time data, what kind of an application do I use? If it's static, what kind of application do I use? So having an understanding of these things is also very important for an architect. Again, I talked about migration. What are the factors they need to consider while migrating an application to cloud? Again, you are expected to design and deploy enterprise-wide scalable operations. Now, again, it sounds similar to the point which I discussed, right? But again, you also need to have an understanding of operations that are performed while your application is working. Now, this is something that is important when you talk about the deployment process and dealing with the customers part, because based on that, your operations team has to put in certain inputs and it is designed properly at the beginning. Your workload gets reduced here. So this is where cloud architect again comes into picture. Implement cost control strategies to ensure maximum cost optimization. Money is something that is very important. And if you plan your applications properly, as in, okay, in case of using a particular kind of a service, if I use the other one, would it be cost effective? This is the decision again your cloud architect should be able to take. Okay. Moving further, we have the cloud developer. Now, we have already designed our application with the help of an architect. Next is building an application. Who does that? Your developer. So they need to have strong understanding of programming. Apart from that, let's move further and take a look at some of the pointers as in what are the other things they need to be concerned with. Expertise in at least one high level programming language. I'm sure it's more than one, but yeah, you should know the basic programming fundamentals so that you can understand how the coding works. Skills for developing, deploying, and debugging cloud applications. API, CLI, SDKs, it is very important, guys, because you would be integrating a lot of applications And for that, understanding of how application protocol interfaces work is very important. Now, command line interfaces are something that you would be working on with a lot as well. So having an understanding of those also helps. Application lifecycle management, which is very important. Ability to use continuous integration and pipelines for deployment. Now, this is something both developers and the admins do. So you need to have an understanding of how these pipelines are created, how they work, and how do you deploy your data continuously. You should have the knowledge or the understanding of key features of service providers, guys, because again, if you're building an application on cloud, guys, you should know how these service providers work, because you would be using a particular service to go ahead and actually build a particular part of your application. So an understanding of different cloud service providers is very important. You should be able to code and also make sure that you are thorough with the security essentials. Skills in writing and correcting and debugging code. Again, testing and building is something that goes parallelly. Serverless applications. Cloud computing supports serverless computing, and that is where you should know what serverless applications are and how should you use containers. Containers are something that are trending in the market, and you need to have an understanding of those as well. If you take a look at the resumes or the job descriptions in the market, people expect you to have understanding of different service providers, understanding of different APIs, at least one programming language, and they have this thing mentioned there as in a knowledge in Kubernetes or Docker would be an add-on. So that means they consider these skills as well. Then we have the admin, guys. Now our application has been designed and it has been developed. Now it needs to be maintained by someone or monitored by someone. Who better than an administrator? So their job is to actually go ahead and make sure that the application runs perfectly in the production environment. What do? They need to have an experience as a system admin, and they should be able to understand how virtualization works, something which is very important for scaling your application in case of peak times. Monitor and audit your applications. Again, have understanding of networking, which is very core for an admin role, and to translate architectural requirements because they are the ones who take care of it in the production atmosphere or the environment. They should be able to actually go ahead and control the data flow, because again, if something goes wrong somewhere, that is during the process of CI/CD, they should be able to detect that and get in touch with the developers team as well. Appropriate service based. They should also have the knowledge of security. If something goes down, how should they actually go ahead and take care of it? Again, optimization is something that is not the concern to a greater extent as far as your architects are concerned. Administrators have lesser responsibility in it. Okay, networking is something that has repeated, I believe, but yeah, we've discussed that already. And migration is something they are also concerned with, because I've already talked about the fact that they deal with the production environment. So guys, these are some of the responsibilities that different cloud engineers take care of. And these are some of the responsibilities that companies would be expecting you to be skilled in. So these are some of the pointers I wanted to talk about. That is about the job description and the roles and responsibilities of a cloud engineer. Let's move further and try to talk about what kind of resume you should have. So guys, I won't be telling you what are the pointers that you need to enter in particularly, but I would be briefing you on certain important facts that or points that you should actually consider while actually going ahead and building your resume. So guys, it's very important you introduce yourself properly. Even if you are a fresher, you should be able to express the fact that you are an enthusiast when it comes to cloud computing. So a cloud computing enthusiast with experience on working with these things. Now you might ask, as an experience as a fresher, how do I show that, right? Obviously, if company does not hire you, you cannot have experience, but that does not mean you should not show your energy or your will to work on cloud computing. How do you do that? Guys, understand how different service providers work. Create an account on AWS, Azure, or GCP. They have free tiers. They have like template projects, maybe 40 minutes, 50 minutes, 2 hours, 1 week, projects like those. Take up those projects. And when you build your resume, tell your hirers that, okay, these are the things I've worked on because it intrigued me. And while doing that, I received or researched on certain pointers like these. And that is why I want this job, or I am a good candidate for this particular job. So again, introduction should not have all these pointers, but an introduction as in why are you into cloud computing? A short introduction would help. As in what are your skills or what are your strengths in short? Maybe in 3 to 4 lines would be more than enough. Then education. Again, while during your education, if you worked on cloud computing or cloud engineering or the related skills that we've talked about, highlight those. Tell companies as in, okay, these are the reasons why you should actually go ahead and hire me. Now, again, guys, you should not just write an essay over it. You should have proper pointers and proper highlights saying, okay, these are the pointers I want to show. And your hires would actually focus on those pointers. And if it is crisp, they would actually appreciate it. experience. Again, if you worked on projects as a fresher, put those. If you are an experienced person, if you are an admin, for example, tell them what you worked on. If you are a developer, tell them what you worked on. You can also tell them if you worked on technologies that actually relate to cloud. If you've researched on different cloud service providers, you can actually relate and understand, okay, these are the technologies I'm working on, and probably these can be moved to cloud, or I can do all these things on cloud as well. So you should be able to show your experience in that particular way, which indicates that, okay, you're actually interested in cloud computing. Skills. We've actually discussed about every possible pointer that is there when you talk about cloud engineering. So while actually going ahead and building your resume, make sure that you add in those pointers and work on those pointers, not just add those, because a company is not going to hire you based on your resume, right? They would actually call you for an interview based on a resume. But then if you have these pointers, you need to back it up with skills, right? Guys, if you are interested in knowing about the exact skills, we have a blog which says Cloud Engineer Roles and Responsibilities by Eureka, and which talks about the not roles and responsibilities, it is skills you should learn in order to become a cloud engineer, if I'm not wrong. So you should actually go through that blog, which talks about the must have skills. Now, the skills that a cloud engineer should have are plenty. I mean, no matter what domain you come from, when it relates to computing, you can actually move to cloud. So the skills might be endless, but we've tried and jot down some important skills. So you might want to take a look at that blog as well. The blogs and the resources that I've used in this session, I would be putting the details of those in the description, and you can actually take a look at those. Do not worry about that, but just a suggestion, you might want to take a look at those. Now, guys, these are some of the pointers that I wanted to talk about, as in what are the job trends, what salary you can expect, what are the parameters that are taken into consideration, what companies look for, and how do you actually go ahead and build your resume. In case if you people are interested in actually going ahead and taking up a certification, this might be a good option for you. I don't want to actually go ahead and stall a lot of time. I'm going to keep it sweet and simple. Now, this is everybody's decision or anybody's decision, as in whether they actually want to go ahead and prepare. Again, you might prepare on your own as well. I've prepared for cloud engineering on my own. I've actually gone ahead and tried studying cloud engineering a lot on my own, and that has helped me a lot. But again, if you can actually go ahead and take a structured approach, it would be a good option for you. There are quite a few good companies that actually hire good training for cloud. This is one of those, guys. I just want to bring this to your notice. It is up to you whether you want to go for it or not. You can get in touch with the people by clicking on this panel. As you can see, it is a cloud masters program with 10 courses, 200 plus hours of interactive learning, and they have a flexible schedule that actually can be modified based on your needs. If you go ahead and take a look at the details, they have the prices here, which are real time, which change, guys. If you are in touch with Edureka and you participate in the contests, probably you might get a bigger discount. Apart from that, some testimonies here and the course details, as in what are the courses that would be covered in this Cloud Masters program. They try to actually cover the basics, the essentials, then help you with the different cloud service providers, help you learn DevOps, which is very important and something that is trending when you talk about cloud and basically software development life cycles. And finally, you would be working on a project. Apart from that, you'd be having various self-paced courses that would help you in preparing for the certification process as well. So in case if you are interested in actually going ahead and taking up a structured approach, this might not be that bad of an option. It's up to you. No suggestions when it comes to taking up these courses. But yeah, you might want to consider this. Having said that, as far as this particular session goes, guys, I would be resting it here and here. Thank you. Bye-bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!